The big one. See if I have a good picture. I'm looking through scrubbing through my photographs here. Big chungus. There's the big one. The big one looks exactly like the small one. It's exactly the same. It's just literally scaled up in every way. It's double the parts. Or, well, double the size. Probably like triple the parts. Let me see if I have a good picture of Kerbals like standing next to one. I know I do somewhere. That's the small one. That's the one we just launched. 5A. I know I have pictures of Kerbal standing next to this. That's the big one. Yeah, okay. There you go. That's the big one right there. See the Kerbal? Yep. What are the benefits of using the smaller engines for the orbital bird versus the larger one? You have better thrust to weight control, Lunchbox Guy, with the smaller engines, but more importantly, they're more efficient. More delta V, dude. Higher specific impulse. So you're more efficient. Get the most out of your fuel. Yep, there's the crew access arm that I made for it and everything. It's a big one. I'll take your entire stock of... Nice. Anyway, let's double box this thing.
You know, the whole reason, it sounds cliche, but the whole reason you do flight tests is to find out things about your spacecraft. This is the first time that Starliner has flown that complex choreography for rendezvous and docking. And you know, whatever you find on this flight test, we're going to go through today. We're going to have the dynamics of undocking, the fly around, and then the return to Earth, landing there. And you know, we'll go over this. They'll go over this spacecraft, go over all that data very thoroughly. Make whatever updates need to be made, and you know, this spacecraft will be returned to Florida, processed, and then reused on a future mission. There's another crewed flight test coming up that's going to be with astronauts.
So what we see here is Starliner on the OFT-2 mission. We saw it go up and dock the other day. They're gonna undock, but we also have SpaceX with their launch coverage here for the Falcon 9 Transporter 5, and the coverage did just go live, so we have a double box here. Starliner undocking should be in about 15 minutes. I'm fast forwarding to get us caught up. So we got a nice double box going here. There we go.
Space station in orbit, Steve, like you mentioned, where this is.
I'm going to mix the audio
test.
here.
There are test objectives for the undocking and landing, which will be carefully monitored by all the flight controllers here in Mission Control Houston, in the Starliner Mission Control Room, as well as the International Space Station Mission Control. But it did spend 5 days docked to the orbiting complex. We mentioned a number of objectives that were evaluated and achieved on its approach and docking to the International Space Station. But once docked, the mission, of course, did not stop. We were able to go through some of the hatch opening procedures. We were able to test the vehicle itself, understand a little bit better about the habitable environment inside the Starliner spacecraft. We were able to circulate air. We tested some communications with various locations on board the International Space Station. We provided an umbilical between the station and the Starliner to charge the batteries.
We have the double box, dudes.
Quiescent mode. Of course, the Starliner now is in a flight test, and it's only spending 5 days aboard the International Space Station, but its ultimate goal is to do long-duration missions aboard the station, so it'll be spending a long time docked. So it tested a certain mode. On
Starliner, what's the purpose of the black perforated ring with holes in the service module? Is that for aero? Oh, that's a good question. I get asked that a lot. Okay, Couch, do you want the full nerd answer? Or do you want, like, straightforward? Because it's kind of complicated. Chat answer. Okay, the short story is to get the aerodynamics going off the capsule to be the same no matter where you are during the ascent. That's the easy way to put it. It is a little bit more complicated than that. We actually looked into it. Okay, so basically aerodynamics, you know, the name. So aero, atmosphere, dynamics, changing conditions, right? I just shot a Rosie right there. The rocket's basically going through changing conditions. The atmospheric pressure goes away once you get up there because there's no air up there, right? So, basically what happens is you have the way the air moves over Starliner during its ascent when it's on Atlas changes. It does change. And it can change... It can change, especially when it's in the transonic regime. So when it's breaking the sound barrier on the way up, the aerodynamics can change to the point where it can damage the vehicle. Yeah, it can cause a lot of vibrations that can resonate with the vehicle and break things. There's vibrational forces that can like undo a bolt, for instance, right? Now, don't get me wrong. That's not the exact reason why they do it. But the long story short is that they get it. That thing is there to basically make sure that Starliner, the air that's moving over Starliner, moves around it the exact same way every time, no matter where it is during ascent. It's actually really smart. Yeah, it's there for aero stability during ascent is the easy way to say it.
Go for launch.
Okay. Yeah. So for the more technical folks, right? For the more technical folks, what that thing is designed to do is it's basically designed to curtail the it curtails the boundary layer trail, I think is what it's called. I forget the name. Long story short, basically aero creeps up the side of Starliner. Starliner's pointed nose pushes the air out of the way. And there's a huge low pressure point at the bottom of Starliner because, or at the base of the service module, right around where the cheese grater is on the side, and air likes to go up. It basically creates a vortex off the side of Starliner, and the air goes up, right? And it flows through that cheese grater, and that basically makes it so the air that's flowing up basically does the same thing every time. It comes from having a launch vehicle with a stubby nose cone, believe it or not. If you look at Falcon 9 right there, it has a very, very long, it has a nose cone and then a very long cylindric section after it, around the fairing. That, you don't need to worry about the air kind of vortexing right here. You don't need to worry about it as much. But on Starliner, you have the service module and then you have nothing, the Centaur stage right behind it. And since there's no cylindric section right there, right? They need to put that aeroskirt to make a more cylindric section, and then they need the cheese grater to help kind of regulate how the air goes over Starliner. Yeah, dude, it has to do with shock loading, and I'm forgetting. I'm blanking on the name. Basically, the air comes up, and the air almost has surface tension, kind of like water, at certain speeds. But that's not the right terminology. That's really not the right way to say it. It's a hammerhead style launch vehicle, Hillis, but yeah, I'll get you the thread if you want to know, if anybody wants to know more. All right.
And gets the number 9 after the number of Merlin 1D engines,
All right.
or M1D engines, at the base of the rocket. What you see on your screen are 4 key parts that make up the rocket: the first and second stages, the black inner stage in between, and then the payload fairing at the very top.
These are going to launch literally at the exact same time.
The bottom 2/3 of the vehicle, and that's what we refer to as the booster. Those 9 Merlin engines do the bulk of the work to get
kind of
Falcon 9
couch
off the ground and up into the.
I'll get
thinner
more
parts
into it
of
later
the
when
Earth's
Starliner
atmosphere.
undocks if you want. Just
For
remind
today's
me
mission, it'll be flying a southern trajectory along Florida's eastern coast, which may make this flight visible from the ground. At about 2.5 minutes into flight,
For strong back retread.
Okay.
about 2.5 minutes into flight, the first stage will
What's that,
separate and make
Jazzus?
its way back to Earth and target a landing back on land at landing zone 1, or LZ1,
Yep.
which you see there on your screen. For those keeping track, today's mission marks the 8th flight for this particular booster, including the most recent transporter mission back in April. On top of the first stage is the black carbon fiber inner stage. It connects the two stages and houses the pneumatic pushers that allow the first and second stage to separate during flight. Then on top of the inner stage is the second stage, which will take the 59 spacecraft to their eventual destination in orbit. After launch, be sure to check out the velocity gauge that you'll see on your screen. See how fast we're going when stage 1 separates, and then how fast we're going when we shut down second stage. You'll notice that the second stage actually contributes more velocity than the first stage. Right now, the spacecraft are enclosed inside the large barrel structure with the there we just heard the call out, and you can see on your screen that the strong back is now retracting ever so slightly. So the spacecraft are enclosed in the barrel structure with the pointed nose that you...
SpaceX stream, I did fast forward, but I'll fast forward again just to be sure. Okay, fast forwarding on both ends. You see Sonny Williams over there in mission control. Starliner trained astronaut, and I think that's Joshua Kutrick there, Canadian astronaut, to her left. And then there's the, this is the flight director bench right here. I think that's Josh Kutrick, but I could be misremembering. So over here on the right monitor, guys, we have Starliner undocking coverage, and then on the left we have SpaceX with Transporter 5 here. Transporter 5 is a rideshare mission with a bunch of small satellites on it. Basically, it's a big freight train of small satellites inside of a big rocket, inside of Falcon 9. Falcon 9 has basically a Christmas tree. It looks like a Christmas tree, the payload attachment fitting inside of that payload fairing with a bunch of small satellites attached to it. And basically the idea is that Falcon 9 is going to deliver all these satellites, and if everybody pays a little bit, you know, they all contribute to the launch, right? Which is called a rideshare mission. Rideshare is basically where you don't just have one primary satellite, you have a bunch of them. These SpaceX Transporter missions are designed to be rideshare missions to give people a lower cost access to low Earth orbit, because theoretically with the Transporter rockets, right, if you launch like 40 satellites on a $40 million rocket, right, that's $1 million per payload. That's $1 million for your small sat into low Earth orbit is insanely good. That is really, really, really inexpensive. That is competitive with the small sat launchers that are around. So SpaceX is trying to get that small sat market too. There you go, Bellbox. That's cool. So that's what's happening on the left here. On the right, we have Starliner attached to the space station still. That should be undocking here in a moment. Starliner is going to undock from the space station while Falcon 9 is ascending into orbit. So it would be nice if they didn't do that, but hey,
now,
space waits for no man.
We'll see some of that leftover liquid oxygen venting now that the stage 1 has been closed out, as we heard that call.
I'm keying in both audios
that's totally
here.
Normal. That's just the leftover liquid oxygen left in our
full screen.
lines.
No, you're not paying attention. Both of these are going to happen at the same time, pretty much. So I don't want to full screen one or the other, dudes.
Falcon 9 is in startup.
I mean, we could go big screen, but I know the second that we do it, they're going to undock that Starliner.
Startup, meaning the flight computers now have control of the launch countdown.
Okay. The autopilot is engaged.
Go for launch.
Launch director reports
All
go
right,
for
that
launch
was
on the
our
Transporter
final
5.
Go for launch coming from our launch director. So now at T-minus 30 seconds,
Send up the
all
authority to
systems
proceed
remain go
command
for launch.
to
Let's
Starliner
watch
to
as Falcon
undock.
9 takes our 59 spacecraft
Starliner
into
remains
orbit.
on a timeline for undocking in 1 minute 15 seconds from now.
Damn it.
T-minus 15 seconds.
All right, ready?
Station Houston on 2, undocked ATP has been sent. Be advised that when
8,
EDS hook motors are driving,
6,
space-to-space
5,
Sound suppressor is on.
3,
Stand by for ignition.
2, 1, 0. Ignition.
Okay, one rocket flying, a pod undocking, all at the same time. Welcome to new space.
Chamber pressure normal. Vehicles pitching down.
Okay, everything looks good there.
Starliner's nose are set to open. They are going through that motion. Telemetry coming down from the vehicle showing each Show the status of each
Falcon 9's doing the roll program.
on Starliner.
You see the very nose of Starliner right there in the window. It is dark where the space station is right now.
We're now T plus 43 seconds into flight. Falcon 9 has cleared the tower.
Power
and
telemetry nominal.
we're currently throttling down those M1D engines.
Stand by for Starliner undock. There's the window on Starliner. You can see Rosie in
It'll
there.
take about a minute and a half for the hooks to completely.
Those that might be unfamiliar, max Q is when the vehicle
Because it doesn't always fly the same place, same way into space every time, Wes.
Aerodynamic pressure.
Sometimes Falcon 9 goes south, sometimes it goes east, sometimes it goes north. There's the undock. Look at that.
Q.
All right, there
right
we
as the
heard
call
that
for max
out
Q
for
happens.
max Q.
This undock.
Starliner is now undocked from the space
Stage one
station.
trajectory.
ISS
We
and
have
Starliner.
5 events coming up in quick succession, starting with MECO, or main
trajectory is nominal.
main
Expect
engine
OFT-1
cutoff. We just heard the call for
22
MVAC chill,
minutes at a range
meaning
of
the second stage is
170
now
meters.
preparing for its ignition. As I said, we start with MECO, stage separation,
Nuts, right?
and SES-1, second engine
Starliner's, once again, Starliner, the OFT-2 mission.
and boost back burn.
The OFT-2 mission is undocking from the space station here. You can see the RCS firing right there. And we also have a Falcon 9 going up into space, all at the same
A
time.
good separation as well. That separation time, right on time, 1:36 p.m. Central Time. The International Space Station and Starliner will run 257 statute miles over the northern border of Singapore.
Orbit. The first stage is going to, as I mentioned
Starliner
before,
already
make
6.5
its
meters
return back
away.
to
You see
from
the RCS on
Space
Starliner
Station,
firing here.
moving at about 1/10 of a meter per second.
Okay, slip over here real quick. Stand by for main engine cutoff. There's MECO. Stage separation.
Stage separation confirmed.
Okay. First stage is now turning around to go and land back at the launch site. That Falcon 9 is coming right back down to Cape Canaveral. Ooh.
Starliner flying free.
Ooh.
pretty amazing view there.
You can
of
look
our
right up the
second
business
stage.
end of the nozzle.
ISS
We can
thrusters are
see
enabled.
on the left.
Please go back to that.
First stage performing its flip maneuver.
You see that? Please go back to that.
The flip, of course, is required. in
Starliner's
order to
RCS is
reorient
firing over
the
there.
first stage.
View you're
so
seeing
that it
here is
actually
from
flies
the
back
ISS as they
toward
track the
Florida.
Starliner moving
You can
away.
think of it
Starliner
kind of like
already
a giant U-turn.
12 meters away from the International Space Station, heading out to a position of
Hey,
about
Slavic, what's going on?
170 meters, 170 meters when the outbound.
Everything continues to look nominal with the second stage. Beautiful glow from the MVAC engine there on the right-hand side of your screen.
Stage 1 boost back shutdown.
Okay, boost
All
back
right,
burn
that
on the
boost
first
back
stage
burn
is
has
done here. The
been
first stage is now going to
completed.
flip
That is the
over.
first of 3 burns that
Begin
the
at
first stage will
18
perform
minutes and
today.
45 seconds. That
Coming up next,
will push Starliner. That will push
we will
Starliner
have
up and
fairing
over
deployment.
the International
Expecting that
Space
Stand
Station.
by for the fairing deploy.
Putting it on a course for a landing later today at White Sands Space
Deployment of the
Harbor in
grid
New
fins there
Mexico.
on the
That
first
landing
stage
set
on the
for
left-hand side of your screen.
5:49 p.m. Central Time.
Bearing separation confirmed.
There's your fairing separation. Boop.
There's our first
See?
view of some of our payloads.
All right, see all the little small satellites attached?
Fairing halves have
Cool.
been separated, fallen away from the vehicle.
Starliner thruster.
There you go, Slavic. That's
Closing
good.
the 59
Continuing to,
spacecraft to the vacuum of
Help the
space.
spacecraft pick up the pace
Today's
as it
mission
moves
marks
away
the
from that
second
forward
flight
port of
for
the
both of
International
those fairing
Space
halves,
Station.
and we will be attempting to recover them from the water once they fall back to Earth.
All right, so what you guys are seeing here side by side, Starliner is undocking for the OFT-2 mission from the ISS. It's an uncrewed flight test for Boeing's new Starliner capsule, the CST-100. And then also on the left, you have SpaceX with their Transporter 5 mission. Starliner did undock basically while Falcon 9 was going up, which is pretty insane. Now Starliner is undocked, and it's gonna move out of the approach corridor, basically outside of the keep out sphere, which should happen here momentarily. But I'm gonna switch us over here for SpaceX to see this first stage
Part
come
of
back
the
down and
Earth
land.
atmosphere.
I will keep the audio for Starliner
Without
up in the
this burn,
background in case I
relying
hear
on the
anything.
atmosphere alone to slow down Falcon 9
The
would
lights you're seeing
put
there on the
unnecessary
screen,
strain
that's
on
looking from the perspective of space station,
Because
of the
All right,
space
maybe
station
we're to
crew,
call out
and those
that
lights are.
There's
have
Cape Canaveral right there.
direction
See it?
and orbital.
The landing zone is right where my mouse cursor
As
is.
I
Falcon
mentioned
9 will be
earlier,
right there in a
Transporter 5
second.
is
A bit
our
more.
5th dedicated small-sat rideshare program mission.
You could still see the
And our
contrail from the
22nd
launch.
mission
See
of
those two clouds right
2022.
there? that was the trail that it made from
Targeting at
ascent.
least 3 dedicated ride-share flights to sun-synchronous orbit per
Once
year.
again,
And we
right
also
there is
offer
where we're heading.
opportunities for a ride to orbit on our Starlink missions, which launch
And at this
every
pace,
Actually,
it'll
it's
be about
pretty much right
16
there.
minutes.
That's 39A, that's 39B.
Space on SpaceX's Falcon 9,
I think.
Falcon
It's hard
Heavy,
to see it.
and Starship.
No.
In the
No, it is right there. That's right.
We're about 1 minute away
There's the
from
landing zone. You can
Falcon
actually
9.
see it. It's that dot right
As you
there.
can see on the left-hand side of your screen, we have deployed the grid fins. Falcon 9 has 4 of those.
See that patch right there? That's where we're going.
And its sensors looking good,
And
doing
it's
what
using
they're
nothing but
supposed
those
to.
grid fins
They're
for
not
steering
performing
as
any
it makes
demos
its
on
There's
the way
Cocoa
up,
Beach. Satellite Beach is right there.
like the center engine.
Titusville, all right there. There's the
Also
Banana
shows
River,
some white
which
spots
means
here and there.
VAB is like
Those
right here
are
somewhere.
cold
Best of being
nitrogen
the
gas
system on
bursts,
board the
which
Starliner
help with
spacecraft.
attitude control.
Optical guidance, navigation, and control equipment looking at the space station, providing views
To
to
put
here in Mission
deceleration
Control
into
Houston. This
perspective,
view,
Yeah, right
around
there.
60
being
seconds
from
away
the
from
station
landing,
side,
the
looking
first
at
stage is moving
Starliner.
about
Look at this.
40,000 miles per hour.
Those systems looking
Then,
good.
in less than a minute,
We're
we
even
rapidly
getting some
reduce the speed in order
visuals
to
from the
prepare
station
for landing.
cameras showing some
First
of
stage
the
slows down
Almost
to
there.
about 90 miles per hour
enabling
when the landing
Stage 2
is
ITS
right.
is safe.
have a slow
Flight termination
about
system on the
90
first,
miles
on the
per
second
hour
stage is
from
saved
the
here.
station itself.
And
Getting
that's
right
it.
for
They
Missile Row.
present a suite of different
Right, there we heard the
sensors, just
call
as you
out that
mentioned.
the
They're
entry
dairy
burn
that stands
Thanks,
has
Scott
for
Star.
begun. You can see that on the
vision-based
left-hand side of your
electro-optical
screen.
Supersonic
sensor
retro propulsion.
and
Again, this is
tracking
the second of 2
assembly.
maneuvers
That's
performed
quite a
by the
mouthful.
first.
Falcon 9, what it's doing right there is it's using its own engines to push away the re-entry heating, enclosing it in a nice cool column of gas. Now, rocket engine exhaust is not cool, but it's cooler than re-entry heating. And there it is. You saw it in heat shield form. There it was from the business end.
So
Bounty.
1.
International Space Station.
Here we go. Grid fins are going to take control here. They're going to steer it right in.
Burn, and that begins just before touchdown and provides the booster.
There's the VAB right there.
Stage 1 FTS is safe.
Shuttle landing facility right there. The SLF. Long 15,000 foot runway. 3 mile long runway.
Have a pretty clear view of the space
Should
coast
be flying through here. You
with
should be able to see Cape
our
Canaveral Space
targeted
Force Station.
destination.
There it is. There's the skid strip. There's
Falcon 9
36.
has 4
We're aiming
landing
right
legs
there.
made of carbon fiber with aluminum
Landing zone 1 right there. So this thing should take a huge turn over there in a moment.
symmetrically around the base of the rocket, and they deploy.
It's aiming for right where my mouse cursor is, behind that grid fin.
Stage 1 landing burn.
All right,
Landing
you can
burn.
see that
There we
the
go.
landing
It's
burn
lined
has
up.
begun.
Coming down.
Before Falcon 9
Continuing to see
lands, we're
some,
expecting the shutdown
Slick
of the
36
MVAC
right there.
Clear
second
images of
stage.
Starliner. But
Complex
Just
12,
after
Complex
landing, one of our
14,
59
going right for
spacecraft
13.
will
Here we
not-
go.
will not
Thrusters,
separate from the
reaction
vehicle,
control
will
system
activate,
thrusters, they
and you
produce
should hear
lift.
that call out over the nets.
Okay, stand by for
Let's
landing
listen
leg
in for these
deploy.
activities happening in quick sequential order.
Stage 1 landing burn.
Yeah!
MVAC shutdown.
Easy peasy.
Stage 1 landing confirmed.
Not bad.
Outpost Mars level 1, experiment activation confirmed. Tapping out orbital insertion.
That's so ridiculous.
All right, as you just heard,
Still
we
cool.
have nominal orbit insertions. We've got a good.
So, fellas,
orbit.
I want to be very clear. You see underneath that rocket right there? Like here, watch it come down one more time here. You see underneath that rocket? Right there, once the smoke and everything clears, you'll see looks like there's a little bit of space underneath between where the engines are and where the ground is, right? You and I can walk under there. The distance from the motors, from the bottom of the rocket engines to the ground is about 2 meters. It should give you, or about 6 feet. It should give you a pretty good perspective as to how big that thing is. Falcon 9 is not small. It's a pretty large vehicle. I'm going to fast forward over here, and I'm going to get us back into double box mode here. All right. Yeah, the music is fast forward. Bots are wild. I just got a headhunter from KSP2. Really? Giant wasp. Did you see the bees? All right. So we had a Falcon 9 landing. Transporter 5 mission is on the left. Starliner undocking on the right. They had a reacquisition of signal there. You see it skip. 20th landing on LZ-1 confirmed. What's the ETA on the OFT-2 landing? I can get you that information here momentarily. Keep out sphere exit from the ISS is scheduled in about 15 minutes. And then Starliner will do a series of burns to exit the approach ellipsoid on the ISS, do the deorbit burn. And we should have a touchdown at about 6:49 on the dot in White Sands Space Harbor. So Falcon 9 just went up going this way. Starliner's going to come back in going this way and land right there, basically right where my mouse cursor is. That should be in a couple of hours, though. Right now we have the double box here.
Thruster firings to keep the Boeing Starliner on a steady course straight out from its where it was docked for the past 5 days to the International Space Station. You can see at the top left.
You covered the landing? Wish I'm going to be here for the duration, buddy. Oh, yeah.
We're heading to about 175.
I like space. I don't know what gave it away.
On the outer edge of the keep out sphere, and we'll perform that outbound fly-around maneuver to swing above the International Space Station, hugging that keep-out sphere, just about 175 to 200 meter marker around the space station until we get essentially right above it.
Yeah, the Great Falcon broomstick, right? Boomerang.
Straight through the International
What's
Space
your thoughts on my building plan?
We'll go right to that point. You can see on this graphic to about the number 4.
Architect, I haven't checked. You've literally been watching me cover this the entire time since you asked to check the building plan.
Letting you know that everything is still looking really good.
I haven't checked yet, bud. You want me? Here, I'll look at your building plan right now. Let me check it.
And that's great words from the International Space Station Flight Control Room. That's Capcom Ray Hayhurst relaying up to the crew, who is currently monitoring Starliner's departure from the International Space Station. This whole time, the key duo here for Starliner operations has been NASA astronauts Kjell Lindgren and Bob Hines. Hines, for the undock procedures, takes on the lead role.
What are you building there,
departure
Architect?
monitoring with Kjell backing him up. They had reversed roles for the ride uphill, but good reports from the teams here in Mission Control Houston. Everything continues to look good. Starliner is about 74 meters.
You gotta tell me what you want to build there. No, that plot is kind of claimed already, but no one's been there in months, so.
Departing from the space station.
But I'll be honest, Architect.
Just about 175.
I'll be honest, dude. You're gonna have to give me some time, dude. There's so much stuff going on. I don't really want to do this right now. I want to do space stuff. Century Link HQ in Omaha. All right. Hold on, okay? I think the building plan needs more cowbell. Okay. I got you. I got you with the cowbell front. I saw it, Thomas, but yeah.
Discovery, go at throttle up.
We sat there in 25th century AD. We sat there and looked at the rockets from Mars, and you just boggled the mind.
I'm going to give the SpaceX cast a little bit of a fast forward there because we rewound. You still have that thing? Of course I do. So yeah, Architect, just give me some time. Give me some time on it. It should be good, but I have to just check. I have to check to see when that player's last bid because that lot's technically already claimed. So I might have you build it in a slightly different spot, but yeah, I'll check that kind of after this whole thing's going on. Okie dokie. All right, let's unmute here. All right, thank you. Sorry to bug you. No problem, dude. It's just like, yeah, if you didn't see me check it, then I haven't checked it, man. There's not two of me. You know what I mean? I mean, that would be... Actually, you guys don't know that. I do stream enough to where I bet you I could make a pretty compelling argument that I have an identical twin, but... I left something in the aerospace channel. Okay, cool. Good to know. Nice, Thomas. It's your lizard clone? No, it's not. What are you talking about? Yeah, Architect. No, I hear you. So once again, everybody, what you're seeing on the left is the trajectory for the Transporter 5 mission. SpaceX just launched that out of the Cape. They did have a first stage return to launch.
Things continue to look good.
First stage return to launch site. And then on the right monitor here, you have Starliner undock from the ISS here. Those lights up there, close encounters lights. Those are the docking lights on Starliner. Should have a good picture here of Starliner in a moment when they get past the Terminator line on the ISS.
Later this afternoon, we're targeting for Mountain Time. It's 4:49 p.m. 5:49 p.m. Central Time, East Coast.
Yeah, that's not my desktop, fellas. To be honest with you, this is that's not my mouse cursor. That's my mouse cursor. That's them.
Moves away, and they received the command was sent and received by the spacecraft. Turned off those docking lights, and now we see a little bit more of the navigation lights.
Jeb is coming home.
Starliner's coming up on 100 meters.
That'd be pretty cool, Animal.
Away from the International Space
So what did I
Station.
miss prior to this coverage? Started messing with some stuff in KSP.
Continuing at pace, just as it's supposed to.
Proving out hybrid tech, dude.
Starliner flying free for.
All right, there's the Terminator. They're coming up to it here.
Rendezvous reporting. Just Starliner just cleared 100 meters. It's heading out to a point.
It's gonna get bright here in a second.
Meters from the space station when it'll begin that outbound fly-around maneuver. Starliner's been flying.
Can you talk through all the info on the screen, please?
17 minutes now.
What info do you want to? What do you want here? So, okay, Starliner's right there. There's the Terminator line, which means the ISS and Starliner are coming into daylight. The Starliner is about 100 meters away from the space station. It should be exiting the space station's keep-out sphere, which is like kind of the restricted airspace around the ISS. It should be getting out of there in a moment. After that, it needs to get out of the AE, the approach ellipsoid, which is like the... if the keep-out sphere is the no-fly zone around the ISS, the approach ellipsoid is the airspace around the ISS. It works kind of like an airport. Basically, you have the area that's like over the runways where nobody flies except for things that are coming in to land or dock in this case, right? And then you have the approach ellipsoid. The approach ellipsoid is basically the airspace around the airport, so to speak, where where spacecraft will come in and they'll line themselves up for a docking port, or, well, like if it was an airport, it'd be a runway, right? Starliner should be coming into daylight here in a moment. Now, in the meantime, you have SpaceX here. Transporter 5 is going down the west coast of South America here along the coast of Chile. Well, little ways off the coast there. Transporter 5 is a rideshare mission with a bunch of small satellites on board. It's launched on a Falcon 9, but instead of Falcon 9 moving one big satellite, it's moving a bunch of small ones that are stacked on top of each other. Actually, it's on like a centralized payload attachment fitting, and all the satellites are attached on the sides around it. Think like a big Christmas tree, but space Christmas tree. Some tangible appreciation for your passion and knowledge of space. Thanks, Tech. I appreciate it. So, here, let me unmute the audios here, and we'll see what's good. Space Christmas tree, best Christmas tree. So right now, Falcon 9 is in a parking orbit. It's just in an initial orbit at around 200 kilometers here. And they're going to pulse the engine to get the thing into a higher orbit. You can see because Falcon 9 is going south relative to the west coast of South America right there, that this is a polar orbit for these satellites. Is this faster, slightly faster than the usual ISS undocking, or is it just me? Seems pretty right to me.
Sensors that are on the nose of Starliner. This is Starliner's look at the International Space Station. You can see there the SpaceX Crew Dragon at the top, the signature.
How big is the ellipsoid?
The solar is on the ISS. And then looking basically clockwise, the Japanese experiment module.
I think it's 200 by 100. I think, and then the keep out sphere is like 100 by 100, I think.
And then the European laboratory, Columbus. So that is exactly how Starliner is looking at the space station as it departs after.
Starliner's optical relative navigation system is imaging the ISS there, so Starliner can figure out where it is in relation to it. Starliner actually has cameras on board that physically look for the space station, similar to how, like, if you were sitting in the pilot seat of Starliner, right, and you were looking out the window for the space station, be like, okay, there's the dog modules, that's where I need to go. Starliner's cameras do that. It's called Vesta. It's a relative navigation system, meaning the computer uses cameras to physically look for the target, which is actually really freaking cool. Ironically, there's a system that is employed on cars in real life on Teslas that use something very similar. Tesla Autopilot is a relative navigation system. There's literally cameras on the car that are looking for things. Straight up.
In the horizon there,
oh, what a shot.
Is 270
Crew 4 Dragon up there.
Just south.
Starliner right there.
Of New Zealand at this point.
Hey Torbs, what's up? Long time no see, how are you?
Is the Boeing Starliner.
Why are the ISS docking ports slanted at an angle and not just a straight cylinder?
International Space Station where
well, good question.
183 meters still within the range that we were targeting for the outbound fly around 1.
The reason why is that they're tilted because they were designed for a slightly different launch vehicle.
In view at the same time.
They're tilted so you could see the docking port from the vehicle that you were docking from, because certain past vehicles that have docked to the ISS were manually docked.
Targeting coordinates for
here, you want to see why it's bent?
This
will tell you.
Have been set.
Does that make sense?
Sent, rather, to the Boeing Starliner spacecraft. That's gonna.
There's Endeavour literally docked to the same exact port, almost, with an adapter, albeit with an adapter that Starliner was docked to. See? Where do you dock? Well, on the space shuttle, you dock from the flight deck. The docking panel is right here. And then you have windows that look this way, and then you have windows that look that way. You need to be able to see where the docking port is, but the docking port can't be outside. It can't be outside. The shuttle carried it inside of its payload bay. So they bent the docking port down so they could look out in front of them, but they could also look down at the docking port and see what they were physically doing. That's why those pressurized mating adapters are bent. They were designed for the shuttle. Now, they're still using them. Starliner was just docked to this pressurized mating adapter, but it had the IDA attached to the side, the International Docking Adapter, which was an adapter that adapted the shuttle's docking port, which is APAS 95, to the International Docking System Standard, or NDS docking port. International Docking System Standard, or the NASA docking port. NASA Docking System is what it's called. Yeah. Starliner and Dragon use the same system. They use the same type of docking port, so they can dock to the same ports. Now, once again, there's an adapter on the end of PMA2 right here to adapt from the shuttle's docking port to Starliner's docking port, which is interesting. Pretty cool.
Round 2, OF1 burn was nominal. The vehicle has exited the keep out sphere. This concludes your monitoring for 1.602.
Can you link that image? Sure. It's pretty awesome. When the shuttle would dock, guys, it was pretty damn impressive for what it was. I'm not gonna lie to you. There's a reason why I'm still a big shuttle fanboy after all these years, because there was nothing like it, man. It was unreal seeing that thing come in. Felt like you were watching something out of 2001.
Astronaut Bob Hines.
Yes,
giving, giving some words from the ISS crew as they watch Starliner depart the Keep Out sphere and begin its departure from the International Space Station. Sad to see
Starliner's
it go.
that dot that's out there.
Godspeed, Starliner.
Once again, the Crew Dragon is still docked there. That's Crew 4's Dragon. That's docked to the Zenith port there, and that also has a shuttle docking adapter here, but they never used that one for shuttle docking adapters. That was a spare. This thing right here, that's Pressurized Mating Adapter 3. Pressurized Mating Adapter 3 is attached to the International Docking Adapter 3. Yeah. PMA2 is attached to IDA2.
We just heard from the
IDA2 is the adapter that adapts the shuttle APAS docking port to the IDSS, or you could call it NDS, either one. Dragon, with its NDS, is docked to IDA3, which is docked to PMA3, which is docked to Node 2. Starliner just undocked from the forward port on Node 2, which is this basically six-axis ISS module here. That has IDA2 and PMA2. Now I know what you're going to ask. Where's IDA1 and where's PMA1? Well, Pressurized Mating Adapter 1 is on the back of the ISS. It's what links, that is the adapter that links the Russian modules to the international modules. Because, trivia question, or trivia time actually, because the shuttle flew its entire career with a Russian docking port. Not a lot of people know that. The space shuttle, Shuttle Mir, ISS, flew with a Russian docking port. So it was easier to manufacture one type of adapter because the Russian modules, Zarya and Zvezda, have APAS on them. They have the same docking port as the shuttle. So if you make one type of adapter, you can dock the shuttle or you can dock Russian and American modules together, which is exactly what they did on STS-88, where they docked PMA-1 to Zarya and started the International Space Station. True story. Now I know what you're going to ask now. Well, where's IDA-1? IDA-1 is at the bottom of the ocean. Yeah, that rocket didn't rocket. Yeah, if you really want to know. True story. King Kitten, 74 months. Woo! 5 years being an internet-friendly EJ. Thanks, man. I appreciate it. Yep. Do Starliner and Dragon operate the NASA docking ring themselves, or does NASA personnel overview it since it's their port system? They operate it themselves, but it's a NASA design, Finn. Yep.
Into a co-elliptic orbit before the deorbit burn takes place, and we see service module separation from that crew module.
I don't hate that picture.
Eventually landing in White Sands, New Mexico.
So once again, left monitor, you have the SpaceX's Transporter 5 mission.
Things are still looking good over here in the International Space Station Flight Control Room, just right across the hall from the Starliner control room that you see on screen.
CRS-7, Zay.
Teams here in the Space Station Flight Control Room will continue to monitor the vehicle as it...
yep, there it goes.
And you can see it
Starliner
moving up and over the space station now. But teams here in the Space Station Control Room will continue monitoring the vehicle as it moves toward the approach ellipsoid
3 orbits, yep.
And through its exit.
Actually, two orbits.
And once we reach that point, joint operations will
orbits.
Cease, but teams will still be watching and cheering for Starliner as it targets its landing.
What's the inner diameter of those ports? About 1 meter. Zay, IDA-1 is at the bottom of the ocean because it was on the ill-fated CRS-7 mission, which was a Falcon 9 mission where a strut failed inside of the second stage and caused one of the COPVs inside of it to bounce around. The strut, in SpaceX's defense, the strut failed at 10% of what it was rated for, so it was a manufacturing defect somewhere. Yeah. So it's at the bottom of the ocean with that Dragon capsule somewhere. When splash, Sugar, 2 things. Starliner does not land in water. It lands on land. It's going to land at White Sands Missile Range in New Mexico. And when that's going to happen is in about 3 hour 45 from now. It was a contracted strut design, Sebi, yes. Mm-hmm. Now, John, we need more IDAs to be made. Well, yeah, I agree. NASA's looking at ways to do that. I don't know, Laser Drifter. I forget the details. It was a long time ago. It was in 2015. So we should be getting up here in about another 15 minutes. SpaceX will fire their rocket engine, the rocket engine on Falcon 9 second stage to boost it up to the orbits that it's needed to deploy the satellites here. Should be about a 30-second burn, give or take. And then that's on the left monitor. Should be happening in about 15. On the right monitor here, you have OFT-2 Starliner. The Boeing Starliner capsule did just undock from the ISS and is now executing a burn to basically get behind the space station. Once again, what they're going to do here with Starliner is they're using differential eccentricity to basically get Starliner to go out and behind the space station before it does its deorbit burns. You don't want to do a deorbit burn in front of the space station because then the space station is going to catch you if you slow down. So what they're doing is they're getting Starliner out kind of behind the station. How they do that for the least amount of delta V is using a orbital mechanic kind of function, I guess, called differential eccentricity. Basically, there's Dragon. There's Dragon Crew 4 Dragon right there with Starliner in the background. Not a bad picture, if I do say so myself. Of course, they framed it where I'm basically in the way. Thank you. That's a pretty sweet picture. So what they're going to do, what they did with Starliner is when it backed away from the ISS, it actually sped up because it's docked to the very front of the ISS. So backing away is actually going to make Starliner speed up. It's going to actually raise what's called its apogee. Now, an apogee raise, right? Apogee raise requires a prograde burn. And since Starliner was facing backwards and it backed up off the space station, that is a prograde burn, or basically burning in the direction that you're going. You burn in the direction that you're going, the highest point in your orbit is going to start to differentiate from the lowest point in your orbit. Now, the highest point is called an apogee and the lowest point is called perigee. Because Starliner backed up, it raised its apogee a little bit because it accelerated. So now it's in an orbit that's slightly egg-shaped. And that slightly eccentric orbit is going to make Starliner look like it's going up and over the ISS, when in reality it's just following its orbital path. Now, Starliner is going to use its thrusters, its rotational rate thrusters, to basically stay pointed towards the ISS, but it'll basically, if this is the ISS and this is Starliner, it undocked, and now it's going to look like it's going to go over and then behind. Because once again, you don't want to do a deorbit burn with the ISS behind you, because if you're slowing down for your deorbit burn, because you need to slow down to lower your perigee so you come back down, so Earth's gravity will pull you in, right? If you slow down, well, the ISS is not slowing down. It's going to speed up, and you're going to run the risk of crossing each other. You don't want to do that. That's why when Starliner backed off, they're basically making it go up and over, and it's going to get behind the space station so it can do its deorbit burn. That should be in about two orbits, which is about 3 hours away, give or take. But either way, you want to make sure you're behind the dang station. That's probably a good idea. Doesn't Dream Chaser have a PMA to IDSS thing on the Shooting Star? It could, Sebi. I'm not sure if it does. That was just a theory of mine. So right now, Starliner is going up and over the space station, or at least it looks like it's basically taxiing around the ISS, so to speak, and going into the back. You can see a really nice shot of Dragon here with Starliner in the background. Those are the two commercial crew capsules. Those are the two U.S. capsules that are designed to move people. There's a shot of both of them right there, which is pretty cool. In conclusion, orbital mechanics is pretty much in the same category as how printers work. Black magic. Yep. Now on the left screen over there, you see Transporter 5. The second stage on Transporter 5 is currently over basically the South Pole, because it is in a polar orbit. So in orbital mechanics, a polar orbit is an orbit that has an inclination of 90 degrees. And it flies over the North and South Pole. Because polar orbit. I know. Very interesting. Allow myself to introduce myself. Does this mean that Starliner would start to approach the ISS once they are halfway around Earth? They're going to do a correction burn once they get behind the ISS. But yeah, it would come back, but it would come back near the ISS, but it would be behind it still. Because you got to remember, Wish, you increased your apogee. When you increase your apogee with that prograde burn, right, from undocking, Starliner's actually slowing down. So the ISS is actually going to go past it. Starliner isn't so much maneuvering around the ISS so much as it's actually slowing down because it increased its apogee. Apogee is by definition the slowest point in your orbit around apoapsis is the slowest point around the orbit. Periapsis is the fastest, and when they coincide, your eccentricity is 0 and you're in a circular orbit. Starliner is just following its natural orbital path from when it undocked, and that's gonna make it fly up and over. But it's not so much flying around the space station as the space station is just accelerating away from it. Yeah. Weird, right? Now, theoretically, Starliner could come back to the ISS, like after one orbit, it'll get near it. But if it just stayed in this orbit, it'll get near it again. But not only when you have differential eccentricity, you also have differential orbital period. So Starliner, when it did that burn, once again, changed the amount of time it takes to do one orbit because its orbit is slightly egg-shaped and the ISS is perfectly circular. It changed the orbital period by increasing eccentricity. So now Starliner's orbit takes like 91 minutes and the ISS orbit takes 90 minutes, right? Because you have that slight difference in orbital period, Starliner will come back up to the altitude that the space station is at eventually. But the space station, since it's staying at a more constant speed and Starliner's slowing down and speeding up and slowing down and speeding up and slowing down and speeding up, it'll actually be out and behind it. And then the next orbit, it'll be behind it even more. And the next orbit, it'll be behind it even more. So basically, NASA and Boeing got all that from one undocking burn, which is really cool. That's really maximizing your delta V. That's really using the most of orbital mechanics to get the capsule where you want. Least amount of burn, most amount of gain. That's really, really, really good, well, what's called GNC, Guidance, Navigation, and Control. Is apoapsis and apogee two names for the same thing? Yes and no. Every orbit around a celestial body has an AP and a PE, an apoapsis and periapsis. Now, to denote what celestial body you're orbiting around, right, the name changes. Apogee, perigee, means an orbit around Earth. Okay? Now, can anybody guess what aphelion and perihelion are? Think about it. Perihelion, aphelion. Emphasis on helion. That's the sun, because the Greek word for the sun is helios. So aphelion and perihelion, right? Here's a harder one. Apocynthion. Apocynthion and pericynthion. What's that? That's the moon. Once again, it comes from the Greek word for the moon, which is Cynthian, I think. I forget. I'd have to go back and look at the classics. Why do they drop the O, though? Aphelion instead of aphelion. I don't know. Because screw you. You could also call around the moon, you could call it apolune or perilune, because the moon's technical name is Luna. So you could say apolune or perilune. You could say either one. I've heard apocyline. I forget what apocyline is and pericyline. I think that's Mars, Nordic, but I'm probably wrong. That's not right, Ark, but alright. Selene is the moon too? Yeah. Mars is Parawatney and Appawatney. I see what you did there. Are you going to be able to see Starliner re-entry from the west coast? Gaff, it'd be low on the horizon due southeast. Depends on where you are. This is a shot from the top of the ISS looking basically up off into space. Starliner is somewhere in that picture. I think it's in the top right, that bright white thing at the top of the screen. But yeah, apoapsis and periapsis change depending on what celestial body you're orbiting around. But the funny thing is that inclination, eccentricity, those names don't change. It's just AP and PE. They named it that way because math or something. I don't know. I don't know the reason. I'm sure there's a good one though. Either that or there isn't, and it's like English where it just doesn't make sense, but those are the rules anyway. Could be that too.
Initiation or approach ellipsoid marker, it'll really be up to the teams in the Starliner flight control room to bring the spacecraft home.
It's possible, John, sure. And if so, when will we get the demo? I don't know why. That's not really in the mission profile for the capsules, John. That's like saying, hey, you know, can a submarine dock in China? Yeah, sure. Why couldn't it? Would you do that, though? No. That's not really part of the mission now, is it? No. No, it can't. I mean, you could, but once again, you do what you set out to do in the mission profile, and how accurate you do it. How accurate your actual mission goes to the mission profile is the determination for success. See above, Mars is Ares. Apsis on other planets.
Flight Director Mike Lammers reports entry cover
Cool.
closed and latched. Putting Starliner in its configuration for departing the vicinity of the International Space Station. It is on a path to exit the approach ellipsoid in just under 19 minutes from now.
Okay, Starliner, what that means in plain English is that Starliner is going to leave ISS airspace here in a second. Airspace being the operative word. There's no air up there. I mean, actually, if you really want to be technical, there absolutely is, but it's not at a pressure where you can do this. Yeah, don't take your helmet off up there. But there is air, believe it or not. Even up at 400 kilometers or 270 miles that way, there is atmosphere up there. It's just not a lot. Not enough to breathe, that's for sure. Thanks for the link, Blue. That's cool. I mean, we got Apollo Soyuz. I'd like to see a mission demonstration of the ability. Yeah, I mean, yeah. And I want the space shuttle to still be flying. What's your point? My point is that you and I ain't NASA. If they don't deem it as something that they need to do, it's not something they need to do, considering both those capsules were made to go to the ISS. But a standardization fitting could mean that they could theoretically dock to each other. But as far as I know, there's really no plans to ever do that. Just sniff harder. Isn't it mostly hydrogen up that high? It's all kinds of stuff, Pezzy. It's not like it's uniform. There's all kinds of gases floating around up there. Greenhouse gases, there's CO2, there's hydrogen. I mean, hydrogen would theoretically be the highest one, but the other thing at the same time is that, dude, there's traces of Earth's atmosphere all the way out at the moon. The atmosphere exponentially fall offs over time. The further and further you go away, the less of perturbing force it has on well, whatever spacecraft you're orbiting in.
Departure initiation burn. Starliner outside the keep-out sphere, as mentioned, heading towards the approach ellipsoid, so it is moving further away from the International Space Station. Right now we're looking at about 480 meters and counting. The rate has increased significantly from when it was much closer to the space station. We were tracking 0.1 and 0.2 meters per second. We're at about 0.85 meters per second.
That differential eccentricity is doing that. It's getting Starliner out and behind the space station, so when they go to deorbit, the space station doesn't get near them when they outgas the vehicle.
The Starliner itself still has...
Now, don't get me wrong. You know, don't get me wrong. I say that like it's going to do a burn in front of the ISS, right? Like the ISS will crash into it. No, that's not really the problem. The reality is they don't want the spacecraft outgassing near the ISS. Because if you think about Starliner shooting off its thrusters, right? Think about Starliner shooting off its thrusters, that gas is just going to keep going. And if that's anywhere near the ISS, well, guess what? Those big solar panels that are on the International Space Station, those work like sails. They're basically paper thin because they don't need to be structural because you're in space, right? You do not want a spacecraft outgassing near the ISS, basically firing big thrusters near it. The reason is because that gas will eventually find the solar panels, and the solar panels will flap around in the wind. The thing about that is that if the solar panels are flopping around in the wind, it does this to the ISS. It bends it. And anybody that's ever played Kerbal knows that if your space station is doing this, you got a big problem. You got a big problem if your space station's weeble wobbling around. NASA doesn't want that. The Russians don't want that. Europeans don't want that. We don't want that. So, part of that is getting Starliner out and behind the space station and a little bit away, so when it goes to deorbit, that gas doesn't get anywhere near the ISS. Why is the deployment so late for Transporter? Does a few minutes, hours really mean that much for a small payload positioning? Yeah, absolutely. Even a second off on the burn, Bauxy, at the right time could mean the satellite never gets near its target, ever, actually. Yeah. Think to that Ariane 5 mission, VA-219. The VA-219 mission launched, and it missed its target. It missed by... Well, actually, that's not a good example. VA-219 flew in the wrong direction. Think of the Atlas V mission where the RD-180 shut down probably, I don't know, 2 to 3 seconds before it should have. The RD-180 missed its burn time by probably, I don't know, like 2 to 3 seconds. The Centaur upper stage had to do a compensation burn for about 2 to 3 minutes to make up for those 2 to 3 seconds. That's how much it matters. It absolutely makes a difference. That Centaur didn't have enough fuel to deorbit, did it? I don't think so. No. Yeah, it's down to the second. It absolutely matters. He asked about deployment after the burn. Point still stands. Orbital mechanics doesn't change just because it's the upper stage versus a small sat. If anything, it has to be way more precise. Those small satellites don't have a lot of thrusters, or they might have no thrusters. So yeah, pinpoint insertion really does make a difference. Yeah, the more accurate you can get, basically the more faithful that you stay to your original mission profile, the better. Now don't get me wrong. Not everything is going to be exactly 100% spot on. There's too many perturbing forces up there. There's the gravitational pull of Earth. There's the gravitational pull of the Moon. There's the gravitational pull of the Sun. There's the gravitational pull of Mars, Venus, Mercury, Jupiter, Neptune, Saturn. They're all pulling in different directions. Slightly, but they are. So you're never going to get it exact, but you can get it down to like a 1 or 2% profile. 1 or 2% of deviation on your mission profile is pretty dang good. That's called a nominal deviation. That's why nominal is used so much in spaceflight, because you're never going to be exactly 100% accurate. That would be like if you take a boat, right? And you were in New York City and you pointed that boat towards London and you hit the go button. What's going to happen? The currents will move it off. Winds will move it in different directions. It's never going to be totally accurate. Spaceflight is like that. There's all kinds of crap up there that's going to pull you in different directions. Like the gas giants, the asteroid belt, even Pluto. Pluto is perturbing every spacecraft that's up there, even just a little bit. But it is. Ceres is doing that. Mars is doing that. All the moons around Jupiter are all doing that. The sun obviously has the most gravitational pull aside from your mom. But the sun is what has the most gravitational pull, so everything's revolving around it. Does that make sense? Yeah, it absolutely matters. What? 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 Nothing? Yeah, that's right, nothing. Nothing at all. I'm telling on you. You can't tell on me, I'm the teacher. I saw nothing. I know nothing. Yeah, Pigzig. Yeah, that's right, James. And then on top of all the gravitational pull, there are other perturbing forces like galactic cosmic waves and solar winds. Basically, the sun is a gigantic power plant, and like every other power plant, it has an exhaust. Picture a power plant in your mind. It's billowing out steam, right? Well, actually, yeah, basically steam. It's heated up water from the cooling loop for whatever they're using to heat water. The sun is just another fusion power plant, and it has exhaust, just like anything else does. The exhaust from the sun comes from the byproduct of a fusion reaction in the form of ionic radiation. Now, every once in a while, you have a coronal mass ejection, or a CME. Basically, the sun, it's like the sun has a little bit of a backfire. It pops, you get a little bit of a backfire, and the resulting release of energy is enough to eject mass out of the sun. A mass ejection, okay? The cameras on Starliner are going a little wacky right now. Hold on. Yeah, basically the sun burps every once in a while. And that ejecta has perturbing forces. It's called solar wind for a reason, because it blows things around in space, even the ISS. Hold on. Starliner is turning. I don't know if it's supposed to do. I can't tell if that's the camera or not. Is it supposed to be doing that? Oh yeah, Glidrub. Yeah, it's pretty cool. Basically, that mass ejection means that the mass was shot out with such force that it escapes the sun's gravwell, which is pretty insane. That's a really high velocity to escape the sun's gravwell. That's why we have space meteorologists. Space weather is absolutely a thing, Blue. Mm-hmm. They were testing the thrusters. I have the NASA stream queued up here. What a janky UI for that capsule. Well, at least we get pictures. This right here, guys, is what a pilot would be seeing sitting inside. This is what Rosie is seeing on her multifunction display. This is what the screens in Starliner are showing. This one right here, which is actually really freaking cool. That's right, Shaunathon. You got it, buddy. Yeah, Bloody, I think we're okay. They just did a hot burn test. Thanks, Sean.
All right, everything's looking good for Starliner's departure. We're coming up in that departure.
Hadn't planned on it, John.
Burn in about 10 seconds.
Okay. Departure burn here should be... Okay, that was a thruster test firing. Okay, I see what you guys are saying. It was a thruster test firing to make sure that they work for the burn here. Now, once again, on the left, you have SpaceX's Transporter 5 mission, which is in a parking orbit, which should be doing an insertion orbit to start deploying satellites here in a second. They do have a reacquisition of signal, hence the onboard view. And over here, we have Starliner. Starliner is about to exit the ISS's approach ellipsoid. The approach ellipsoid for the ISS is basically the airspace around the ISS. Like an airport would have airspace around it, you know? And the center for the pilots would be mission control, if you really want to know. Starliner is departing the local airspace around the ISS. And once again, I use the airspace term very loosely because there's no air up there because it is space.
Burn milestone. Flight controllers, the rendezvous officer, very happy with the trajectory of Starliner as it makes its way towards exiting the approach ellipsoid. Things looking good for Starliner's departure from the International Space Station. We're still tracking an exit of that approach ellipsoid in about 6 minutes or so.
We've had a nominal mission so far with an on-time liftoff at 2:35 p.m. Eastern. Currently, we're awaiting the relight of our MVAC engine. It will be a quick 3-second burn starting in just a couple of seconds.
And you know, we talk, as we mentioned a lot.
MVAC ignition.
Here we go.
A lot about the space.
Should be a 30.
Shutdown.
I thought it was supposed to be a little bit longer than that, but they reported shutdown.
Like
so.
I said, super quick,
Okay.
3-second burn there.
3-second burn, got it.
Now, for those that have recently joined, this is the Transporter 5 mission, our 5th dedicated rideshare mission. It's very faint, but we did hear confirmation of good orbit there after that quick relight of the second stage engine. This is our 5th dedicated rideshare mission and SpaceX's 22nd mission of 2022. Falcon 9 lifted off at 2:35 p.m. Eastern from Cape Canaveral Space Force Station and had a successful stage separation, landing of the first stage at LZ-1, which marked
Just a
our
typo, Thomas?
115th recovery of a Falcon 9 first stage booster. We also successfully completed 2 second stage burns, the most recent one you just saw. For those of you who might not be familiar with our transporter missions, SpaceX is targeting at least 3 dedicated rideshare flights to sun-synchronous orbit per year, and we also offer opportunities for a ride to orbit on our Starlink missions, which launch every couple of weeks. Small sats can ride to space on our Falcon 9, Falcon Heavy, and in the not-too-distant future, Starship as well. On this flight are 59 spacecraft, including CubeSats, microsats, and orbital transfer vehicles carrying spacecraft to be deployed at a later time. Like I mentioned earlier in the webcast, there are some really neat payloads flying today, including spacecraft designed to improve communications and GPS mapping, help monitor weather, environmental changes, and greenhouse gas emissions, and even demonstrate new in-space technologies to further space exploration and travel in the future. These payloads are awesome examples of how even the smallest of satellites can
Starship,
make meaningful contributions.
Getaway Special is
to
back
our
on the
care
menu,
for
boys.
our own planet,
And
as
girls.
well as our efforts to visit others. For the 59 spacecraft on board, there will be a total of 39 deployments, which begin around the T+59 minute mark, and they will last for approximately 15 minutes.
You guys got to think. Starship doing a transporter mission could literally bring up space station modules on top of small sats. That's what I mean by the Getaway Special program. The Getaway Special program was the rideshare program for the space shuttle. If the space shuttle was, say, deploying a satellite, it would bring up a bunch of small satellites like this. This was an idea that was pioneered during the shuttle program. They used the aggregate payload space because the space shuttle always could launch 25 tons and 7 people into orbit every time. If you had a 10-ton payload, that's 15 tons of extra payload space, so they just filled it up with satellites. Starship's going to do that, but you got to remember, the space shuttle can move 25 tons. Falcon 9 can move 22 tons. Starship can move 100 tons. It could ride-share space station modules. You could ride-share transfer vehicles to other planets. You could ride-share whole ISSs in one shot, man. It's going to be amazing. It's going to be so legit, dude.
As deployment sequence is about to
All
begin.
right, here we go. Let's get up on deployment here. Watch, these things are going to start detaching.
Geo optics, Cicero 2, vehicle.
There it goes.
Separation
See ya.
confirmed.
See ya. Yeet.
Shared sat, 2141, separation confirmed.
Ready? Boop. Where is it? Where is it?
NASA Pathfinder Technology Demonstrator 3,
Bye-bye.
separation confirmed.
Bye-bye.
Following the undocking operations,
I don't know, Ilya.
some of the telemetry
Lemur 2,
Whoa!
Karen
See ya.
separation
That thing went out of there crazy. See that thing?
from the International Space
Yeah, imagining the noob tube sound. Bonk.
Your
There it
tornado,
goes.
Separation confirmed.
We're watching satellites deploying off of a rocket in real time.
Geo optics, Cicero 2, vehicle
Being
1,
streamed to your
separation
computer.
confirmed.
You're literally watching satellites be deployed on a spacecraft in space right now.
Lemur 2,
You know what?
entries, separation confirmed.
That's pretty neat. That's pretty neat.
with the International Space
Boom.
Station flight.
You're right.
Starliner
How are they pushed off? Springs?
Spark 2, separation confirmed.
Springs.
United States. It's about a little more than 3 hours
Springs.
from the time we exit that yellow sphere.
Do the sats have their own thrusters? Some of them do, some of them don't.
Land in the western United States.
I know, Denny. Isn't this great?
That exits,
How many? 39.
Lemur 2, Tennessee,
3.
Sun Lily, separation
9.
confirmed.
From the teams that the Starliner has, of course, exited the approach ellipsoid. is at this point more than a kilometer away from the station. We're tracking about 1,100 meters.
Yeah, you go with what you know, dude. Literally a spring. Timeline was supposed to be 32 seconds. Looks like another typo from SpaceX. Okay, Thomas.
GHG set, C4, penny separation
There it
confirmed.
goes. Bye-bye. And here, let me double box you. Got a picture.
And about 30 seconds left before Starliner.
Planetum 1 and spin 1, separation confirmed.
So now, it's interesting, fellas. Look. Now Starliner is below the ISS. It went up and over.
Beamer 2, Handcom 1,
And now
separation confirmed.
it's below the thing. See that? It was up. It was where they were looking at it before was looking up off the space station. Now they're looking down at it at Earth. Differential eccentricity, man.
GHG set, C3 Luca,
So in that
separation
comms
confirmed.
loop, kind of blackout for a second. The Starliner went out over the back of the space station and down, and now it's underneath it.
Not another commercial crew vehicle, but a commercial cargo vehicle.
That's the solar panels from Cygnus. That's what the guy's saying
NASA
right there.
CubeSat proximity operations demonstration, separation confirmed.
CubeSat proximity operations. Nice. Meant this one. Starship rideshare deployment leak.
About 20 seconds away from it.
Connecta T1.1,
Yep.
separation confirmed.
Entry cover closed.
Look at that.
attached.
Watching a spacecraft leave the ISS and satellites being deployed
Beamer 2,
all at
Amy,
once.
1307, separation confirmed.
Of course, zooming in.
Come on.
GHG set,
Oh,
C5,
bye-bye.
Diaco, separation confirmed.
Yeah, you'd be so Sile, you'd be surprised how simple it is. It's just a spring. They just spring load it, and it's just a bolt that comes undone, and then the spring decompresses, and boop, see ya. It's usually something that small, that easy. You go with what works.
Station Houston, space to ground 2 for Starliner. Starliner has exited the approach ellipsoid and is on a 24-hour safe free drift trajectory. We're beginning C2V2 deactivation. This is your last Starliner status call until the deorbit burn.
Okay, so what did that mean in plain English? So they deactivated the C2V2. That's the ISS communication system with incoming vehicles. And then the second one there was a 24-hour free drift, meaning that Starliner is in the type of orb. Starliner adjusted with its thrusters a little bit after it left the approach ellipsoid to make it so it will not get near the ISS for 24 hours. It could just basically sit there and do nothing, and it won't get near the ISS again. That's called a free drift.
So that 24-hour free drift safe trajectory is really just as a precautionary thing, just in case Starliner needed to. It would be able to stay in an orbit for 24 hours with in a safe trajectory, not with any contact with the International Space Station.
That's what I just said, Gary.
Any risk of contact. So that is a standard free drift trajectory that it's on.
Gary's
but with that
stealing my
confirmation,
vibe.
Centauri 5,
that is the end
separation
of joint
confirmed.
operations, and that of course has been relayed up to the International Space Station crew. They're relieved of their duties for monitoring.
Yeah, basically because they shut down C2V2 communications. Basically, they closed.
CNCE V4 and CNCE V5 separation confirmed.
They shut the link off between the ISS and Starliner because Starliner is outside of the ISS's airspace, right? Airspace, quotes, no air. They don't need to communicate with it anymore. So Starliner's basically just communicating with mission control right now. That's it. So that was the command to the astronauts, to the commander of the space station, Kjell Lindgren, to basically just, yeah, you don't need to do anything else. We'll tell you when it's deorbiting, and then, yeah, you could just watch. Get the popcorn out.
Departing the approach ellipsoid a little bit more than an hour later.
Wouldn't it be space?
Everything looking
Yeah, but
sure,
saying
but
space
AC-14
is very
operation
confusing.
confirmed.
Oh,
Everything
that's a
looking really
big
good
chunker
for
of a
Starliner.
satellite that just left. You
Across
see
the
that?
hall, we're going to check in one more time with Leah Cheshire, who's been looking at the ISS perspective, and that flight control team, as they have watched just as eagerly as the Starliner control team, as the Boeing Starliner spacecraft has left the vicinity, the immediate vicinity, I should say, of the International Space Station. Leah?
Absolutely, Steve, and thanks so much. Of course, since the Starliner vehicles out of
Expected
the
loss of
approach
signal,
ellipsoid,
Monday.
joint operations have now ceased between the two teams. Of course, International Space Station flight controllers here are still monitoring all of the systems aboard the station itself, and they'll continue to watch
Mike
the
Fink's
rest of
sitting in mission
Starliner's
control
journey
right
home.
there. That's the guy
But
that's
as they
chilling like
relayed up
this
to
with
the
the
crew,
lanyard.
any actions
Set
are
1C, separation
now
confirmed.
complete on their part and are all in the hands
He's
of the
trained on
Starliner team
Starliner.
across the hall.
That's why they have him in mission
And
control.
with that successful departure from the approach ellipsoid, that's our final checkpoint from the Space
AMS
Station team
separation
today.
confirmed.
Thank you so much for having us and allowing us to be part of the mission. We're excited to see Starliner back again in the future. Thanks, and back over to you, Steve and Gary.
All right, thanks, Leah.
Gary?
That's right. That ends joint operations with the International Space Station teams. But of course, the mission is not over. We'll soon be wrapping up our coverage of the Starliner's
Broncos have one
undocking and
separation
departure
confirmed.
from the International Space Station. But our coverage will continue to follow the Starliner for a landing in the western United States. That coverage will begin 5:45 p.m. Eastern Time. That's 4:45 p.m. Central. If you're
2 hours.
out near the desert, near the landing site in White Sands Space Harbor, New Mexico, that'll be 3:45 p.m. Mountain Time. But Steve, it's been a pleasure to follow this mission through its undocking and exit the approach ellipsoid. It was a very successful undocking and exit, and so we'll be looking forward to seeing the Starliner very soon coming home.
Boeing Starliner spacecraft has been performing very well throughout this orbital flight test 2 mission. You know, it's been
That
put through
confirms
a
our
lot
first set of
different paces, just as
deployments
you're supposed
today.
to do with the flight
All
test.
26
And,
have
so
been
far,
verified
working
as separated.
very well.
We're now
Everything's
entering
going
that blackout
well.
period
Can't
that
wait
I
to see
mentioned.
this
This loss
landing.
of signal will last
Starliner
until around the
to
T+1 hour and 15-minute mark. We'll be back just before then to get confirmation of the final 13 deployments set to happen during that time. For now, sit back and enjoy the space jams.
White Sands Space Harbor, where our teams, both from Boeing and from NASA,
First
are
round of
standing by to
satellites
welcome it
deploying
back to
was
Earth
nominal
after,
from Kate
after
there.
what's been about a 6-day mission.
That's right. And of course, tune in for our coverage of those events. But for the teams here in the Starliner Flight Control Room and the International Space Station Flight Control Room, that'll wrap up our coverage for now. Stay tuned for the landing coverage coming up in just a couple of hours. With that, this is Mission Control Houston.
All right. We can go back to single boxing here. The SpaceX Transporter mission is still going, but NASA coverage for OFT is not suspended for the time being until Starliner is ready to deorbit. Everything is looking good, both ways around. Gamer. First stage.
30, separation
Oh,
confirmed.
there we go. There we go. It was behind me there. Yeah, everything looks good. SpaceX is deploying a couple more satellites here. Oh, they had a loss of signal there. So they're basically... Yeah, they're basically over Russia. SpaceX doesn't...
ISI, separation confirmed.
SpaceX doesn't have any...
Expected loss of signal, Bangalore.
Yep, they had a loss of signal through the Bangalore tracking station. The next expected acquisition of signals should be once it goes over the hill here. Basically out over the North Pole. They should have an acquisition of signal through Newfoundland. Should. Could be wrong. So we don't have visual comms here. Another easy way to see that they have a loss of signal is if you look at those numbers over there. They're not moving. Not these ones. The ones on the far right. See 27605 540. They ain't moving. That's not how orbital mechanics works. You're always going to have a little bit of deviation in your speed and altitude, unless you're in a perfectly circular orbit. And we know that Falcon 9 is not in a perfectly circular orbit because it did a burn about 30 minutes ago. Well, not about 30, more like 10. But we know it's not in a circularized orbit. So that means it's in communication blackout. Now keep in mind, that doesn't mean that the timer has stopped. That's your elapsed timer right there. So this mission has been going for an hour and 10 minutes, give or take. Honey Piston, 37-month resub. Thank you. Do you think SpaceX could eventually make Starlink work as a TDRS for its own operations? Yes. And NASA wants to use it. Signer, true story. they speed up and boost up to the orbit that they need to get into, Lunchbox. Starlink satellites have ionic propulsion in the form of krypton thrusters. No, that's not sci-fi. They basically take inert gas and ionize it in a combustion chamber by arcing electricity through it. That's how the thrusters work. That's called electric propulsion. It absolutely is a thing. The Starlink has, not Starliner. Starlink has these little tiny thrusters that are about maybe the size of a golf ball, and that's what it uses for RCS. And it just uses electrical power and krypton gas. When it runs out of krypton gas, the satellite will basically tumble out of orbit. It needs those thrusters to basically stay in position. Starlink satellites are lower than that thing right there. They're about 100 kilometers, or about 60 miles lower than stage 2 right there. So they're still very much hitting the atmosphere of Earth. So when Starlink satellites hit their end of life, or they run out of thruster, they just fall back down. Yeah, they got a contract for it. Yeah, what Phil said. Here's the presser near the beginning from the OFT mission if you need some space news till deorbit. I actually kind of wanted to go play Kerbal, but I want to watch the Transporter mission too. So right now, stage 2 is making its way over the Ural Mountains here. Well, it's kind of east of the Urals right now. It'll make its way over in a moment. Kind of near, what is that around? Novosibirsk? Somewhere around there.
Discovery, go and throttle.
Hey, buddy. 16-month resub. Yo, any word on that thing? Did you talk to the guy? Talk to the guy? Not much progress as of right now. Got it. Stand by for confirmation of another satellite deploy here. Oh, yeah, we won't get confirmation of deploy until they have a reacquisition of signal. Sorry, that's what I was just saying. Just kind of in a holding pattern here. Yeah, Buck, no news is good news. Why does the whole Russia look so frozen? Because it's cold there, Mycon. It doesn't look frozen. It is. Also, that just could be the graphics. It's not frozen right now. Lots of Russia actually gets pretty damn warm in the summer, dudes. Space liquid system. I like it, T-Man. I'm a Finn, it's not that frozen right now. Yeah, we know from my summer car, right? It doesn't really get that frozen now, does it? Plus 15. Radisov? What's that word, Ilya? I don't know that word. Gradusov. Got it. Degrees. Got it. Sweet, sweet. It's 15? Eh, that ain't bad. That's about how warm it is here. Yeah, Elvis, right? Thoughts?
Welcome back to the webcast for Transporter 5, SpaceX's 5th dedicated small-sat rideshare program mission. We had a successful liftoff at 2:35 p.m. Eastern from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida.
What's up, dude?
So far today, we've had 26 confirmed separation events and are currently waiting to hear the callouts for another 13, which occurred during a blackout period where we had no access to ground station coverage. For a full list of deployments, head over to SpaceX.com. Also worth mentioning that because many of the spacecraft are being deployed in groups or quick succession, we may not be able to confirm every deployment in real time, and we expect we might need a couple extra minutes to confirm the last deployment in this final set. Let's listen in.
Yes, let's. 39, I think, was on this one, Echo. I think. Could be more. Thomas.
4 ISI separations confirmed.
Okay, see how the numbers updated?
Separation confirmed. Umbra, separation confirmed. Vigoride, separation confirmed.
59. Thank you.
Ion, SCV, 006, Thrilling, Thomas, separation confirmed.
Okay, that sounds good. $59, Jim. Okay, we're up off the north coast of Russia here. A little ways east to the Kola Peninsula. Moving out into the North Pole here. Yeah, it would have been pretty nice, Drifter, huh? And approaching the northern coast of Greenland here in a moment. Stage 2 making its way out near the North Pole. Well, we don't have tracking stations in northern Russia? Nah, I don't think they'd allow that. I don't think they like Elon very much right now. Not that they ever did, but no word on them right now, Jim.
So far, we've heard call-outs for 10 of the 13 final deployments. As I mentioned earlier, we're expecting to need a little bit of extra time to verify those final 3. While we wait, sit back and enjoy the space tunes.
I will. Thank you. Heck, I missed it. Vazia, we had Starliner undock while Falcon was launching. It was a little nuts, man. Just waiting here for final confirmation. It's landing in White Sands, New Mexico, Jim. And landing should be in about 3 hour 40, give or take. It would be 3:49 p.m. for you. Does SpaceX actually have their tents for sale, or were you thinking something similar? Bagel, I don't know if those tents are actually for sale. I know they're going to eventually get rid of them. What I was thinking is maybe see if we can go talk to some people at SpaceX and see if they'll donate them, you know? It's not Tentology. I forget which one they use, but I forget which brand they use, but how cool would it be, dude, to have an exhibit of all that space hardware inside one of those tents when the tent itself was used to make space hardware. I think that's a cool idea, but I just don't know who we need to talk to get it done. But we should. I might know a couple of people. I'll see what I can ask. Oh, nice. We'll see. I don't know about a petition. Petitions don't really do anything. Actions take. We'll see. We got some live shots here. You can see outgassing from SpaceX's nitrogen and attitude control thrusters here. Oh, nice onboard shot. Look at that. Well, that's pretty neat. You can see all the solid nitrogen that's built up on the outside of the engine right there. What is that? Actually, it could be solid helium too. Not entirely sure. Basically what that is, actually it could be solid oxygen as well. They basically, every time they fire that Merlin engine, right, the M1D vac, they have to purge it out because it's filled with liquid oxidizer technically when they shut it off. Oh, there's the other satellites that it deployed. Think about it like if you have a garden hose and you shut the garden hose off. Does that mean there's still water in the line, right? And even when you're raveling up the hose, water goes everywhere. Rocket engine plumbing is kind of like that. But the thing is that the liquid oxygen that's inside of the engine when the engine shuts down is super freaking corrosive. So they have to purge the engine out. They have to shoot inert gas through the plumbing, right, to get it all to come out. And that's what all that big snowflake thing that's attached to the side of the engine is for. Or not what it's for, that's what happens. It shoots all that liquid oxygen out. The liquid oxygen hits the vacuum, pressure drops to zero, and it freezes. And it just kind of accumulates everywhere. Company they use is Sprung Structures. Thank you, Easy. Yeah, that's it. Okay, Zay. Sprunk Structures, indeed. Okay, we're off the north coast of Greenland here. Hey Sim, I gotta hop in a meeting, but I wanted to say hi. What's going on, man? How you doing? Sim, you streaming late tonight, right? Hey, the Northern Passage is open. Yep. Looks like the stage is heading on a trajectory that'll go across Hudson Bay. Doing okay, thanks for asking. Y'all be streaming later tonight? What's on the menu over there, dude? What's the special? And what's the soup? What did that guy have? He had the special. That's what I ordered! I want the soup. Check, please. I got something you're going to like.
Hawkeye satellite separation confirmed.
Oh, very nice. Very nice. Okay, you had a good confirmation on deployment there. Meeting time, I'll be lurking. I have no clue yet. All right, man. Well, I'll see you. Have fun in your meeting, dude.
That second and final set of deployments.
Some of the solid oxygen came off there.
To 39 deployments. A full listing of today's payloads can be found over at SpaceX.com. We'd like to thank you all and to all of our rideshare customers for their support on today's mission. Continue to follow us at SpaceX.com, Twitter, and Instagram for updates on future missions and milestones. And if you're excited by what you saw today and want to join our team, visit SpaceX.com/careers to learn more.
I'll clean the floors.
Thank you to all of our viewers for your continued support.
All payload separations confirmed.
And have a great rest of your day.
Oh, I will. No, you, Kate. You have a great rest of your day. My day is already good because of this. Damn. I'd clean the floors to be honest. No, I'd be right there with you. It'd be the damn cleanest floors you've ever seen. It'd be clean enough to eat off of. It'd be clean enough to eat off of. All right, guys. Well, we're in a little bit of a holding pattern here for about another hour 45. Because Starliner coverage will pick up, yeah, actually at 5:45 p.m. Eastern. So that's an hour 45 away from now. So we could go back into messing with stuff in KSP. We were checking out the hybrid hinges, or we could do space news. It's really up to you guys. I think I want to, you know what? Let's do space news now. And then on the other side of Starliner landing, that's when we'll go play Kerbal. Learn how to reuse a proper commercial made drop above it so I'd mount the floors. I just can't get transport across the Indian River to the barrier island. Yeah, what's that about? Oh, yeah. Looks like John got some, John Krause got some really nice pictures. Falcon Centaur. Yeah, I don't hate that. Alright, here. I'm going to switch this over. So, Transporter 5 launch coverage. Good. So, EJ's space and rocket review. And then, OFT-2 Re-entry coverage. So check this out, fellas. John Krause had a really good picture of Falcon 9 coming back. Look at that. There's your supersonic retro propulsion. Ooh. You could physically see where the gases are getting compressed against the re-entry heating right there. See that? That's pretty neat. You can see the top of Falcon 9 right there. That's pretty neat. You can even see what looks like a little trace of some grid fins right there. Nuts, huh? Great picture from John Krause. He's a fantastic photographer. John is actually a photographer for the Polaris program, which is just absolutely bananas. He gets some insanely good pictures. What about Jenny? Did Jenny get some pictures as well? Yeah, she did. Yeah, she did. Going up and coming down. Going up, coming down, going up, coming down. They're missing the top pieces. I saw some snippets of the launch. How was it? Anything specifically newsworthy? Falcon 9 was hitting max Q and Starliner was undocking from the space station, which is pretty cool. Nice, Maverick. There you go. All right. So, yeah, we have about an hour 45 until we pick up the mission coverage again here. So, in the meantime, let's see what's going on elsewhere in the spaceflight industry. Let me just transfer some links over. You guys already got me a plethora of links. Jefe, what is a plethora? I do not know. If you did not know what a plethora means, then why would you say that I have a plethora if you in fact do not know what plethora means? Sorry. Actually, you know what I should do? I should probably take a break. 4 o'clock is usually when I take 5. But don't worry, I'm not going anywhere. Let's see what we got. Is it the orbit or the wind or maybe both that decide whether the first stage lands on a drone ship or a landing site? Orbit. It's delta V more than anything, dude. Now, don't get me wrong. Windage is a condition that they have to consider. But it's more having the fuel to land than anything. Falcon 9 doesn't fly very well if it doesn't have any fuel to land. Well, that's not exactly true. It'll fly just fine until it goes to land. And then it won't fly because it'll find that sudden increase in kinetic energy on the bottom of the vehicle causes very, very bad compression load, i.e. hitting the ground. It will Falcon Heavy center core. Yep. Sudden shock compression loading on the bottom of the vehicle. Yeah. Okay, let's see. Let me see if I can find us something here. I'm gonna take 15 and I will be right back. Let's see if we can find something. Find some STEM stuff here. I know this is the best part of the stream, right? I'm trying to find something good. Something good. I try to make sure that we're looking at stuff that's public resource here. Ah, here we go. Let's see what we can find in here. We've watched all those already. No. I'll find us something here in a moment. Chair stream soon. Yeah, something like that. Lovely amount of dead air. Ah, man, there's too much stuff in here. Okay, here. How about that RL-10 assembly video? Link me. I gotta be careful about the videos that I show, guys. It has to be public resource because I don't need anybody getting up my tail about showing their video, you know what I mean? This, and then this. Von Braun Space Station. Yeah. The Von Braun Space Station video, Lenprod, is, I can't really show that. The reason why I can't show that is because that was shown on Disney. Disney owns the rights to that footage. And, yeah, that's what I mean about, not showing that. Oh, the RL-10 footage jam, we could absolutely put that on. I'm going to have to put it on loop, though. I'll put it on loop a couple times, and we'll see what we can do. I'll be back in a moment.
The RL-10 rocket engine, power plant for the Centaur and Saturn, is the result of years of research and development. The highest performance engine built in the free world using safe, reliable, and dependable hydrogen. To maintain the high degree of reliability of the RL-10, vital parts are assembled under stringent laboratory conditions. Following a typical engine through its paces, the thrust chamber tubes are installed. After the assembly is placed over a mandrel, the manifolds and bands can be attached. Silver wire is laid in for furnace brazing. Placed in a retort, the chamber is readied for the furnace. Once brazed, the chamber undergoes testing to assure trouble-free operation. Liquid nitrogen is forced through the chamber to perform thermal shock tests. Pressurized with gaseous nitrogen, the chamber is checked for leaks. The inspected subassembly is dried out in a special oven. Final chamber assembly is completed with the installation of the injector. A special jig is lowered to accurately align the injector. Then the chamber goes for final machining prior to assembly of the complete engine. On the assembly floor, all parts come together. Fuel lines, valves, turbo pumps are brought from clean rooms, assembled, installed, and inspected. Multiple inspections of each component and subassembly assures maximum reliability. Ready for action, the completed engine must undergo the test of firing. The RL-10 is made ready for transport to the test site. The operating principle of the RL-10 can best be shown by this simple diagram. Hydrogen at 37 degrees Rankine, minus 423 degrees Fahrenheit, enters through the inlet shutoff valve, passes through the first stage pump into the second stage pump, where it is discharged at 1,000 pounds per square inch. Then it passes through the cooling jacket manifold, through half of the tubes, through the turnaround manifold, back through the long tubes, to the exit manifold, and through the venturi into the turbine. At this point, the hydrogen is now gas at 850 pounds per square inch and 350 degrees Rankine, minus 110 degrees Fahrenheit, and provides the power to drive the hydrogen and oxygen pumps. It then goes through the main shutoff valve into the injector and to the combustion chamber. Drawn in through the single-stage oxygen pump, oxygen flows through the inlet valve directly through the mixture ratio control valve into the injector to combine with the hydrogen in the chamber. The engine itself is as simple as the diagram. To demonstrate, hydrogen enters at this point, flows through the first stage pump into the second stage pump, passes through the cooling jacket manifold, down through half the tubes, to the turnaround manifold, up the long tubes, collected at the exit manifold, through the venturi into the turbine, There it provides the power to drive the hydrogen and oxygen pumps. Then around the large line, through the main fuel shutoff valve, into the injector, and then to the combustion chamber. On the oxygen side, oxygen flows through the inlet valve through a single-stage pump, directly through the mixture ratio control valve into the injector. Arriving at one of the vertical test stands, the RL-10 is installed and made ready for test firing.
19, 18,
Space firing conditions will be simulated.
15, 14, 15, 12,
A steam injector system lowers the pressure to the near vacuum of space.
7, 6,
Cameras on. Timing
4,
on.
3, 2,
Engine is good. Head shell is good.
0.
On completion of this test firing, the engine will be returned to the manufacturing area for complete disassembly, inspection, and reassembly. Years of experience, research, and development have gone into the design and manufacture of the Pratt & Whitney aircraft RL-10 rocket engine.
Pressure 320. Temperature on your user is 175.
Shorten that micro switch.
The RL-10 has also undergone space condition testing at the NASA Lewis Research Center, where special viewing ports permit continual visual check of space condition firing. Pratt & Whitney Aircraft's around-the-clock development program is helping accelerate the United States space effort.
Flashing across California desert skies, the airplanes you see here are writing new chapters in the story of man-made flight. There she goes.
This is my first opportunity to greet you as Deputy Administrator of the National Aeronautics and Space Administration.
Together, you and I must make our new agency
the most unusual place.
An organization that can challenge conventional wisdom.
We can engineer anything we can write the requirements for.
We're going to make your idea work. This particular idea is quite disruptive.
A typical flight, of course, starts under the wing of the B-52 mothership.
This sleek, high-speed machine would have made Rube Goldberg proud.
The manner in which we fly re-entry from space on the space shuttle was pioneered on the X-15.
The X-31 pretty much wrote the book on thrust vectoring, along with its sister program, the F-18 HAR.
An observation of an occultation is one of the more challenging missions that Sophia can do.
Right now, we are looking at the dawn of a new era of aviation.
I am speed.
Your Air Force is continually developing new and more astonishing aircraft.
We have the air, we have the power.
The development of new power in the air has brought about terrific speed.
The diving of subsonic airplanes at speeds for which they were never designed could be a hazardous business.
Knowledgeable men were seriously wondering whether man could ever fly faster than the speed of sound.
It remains for the high-speed flight program to attack these problems. with scientific facilities of a new kind.
Rifle and artillery shells had been traveling supersonically for many years. The XS-1 was indeed shaped like a 50 caliber bullet.
Through the sound barrier, the first time ever in level flight.
Blazing through sound barriers and now heat barriers, the Bell X-2 reaches the unheard-of speed of 1,900 miles per hour.
The D-558 was the first American aircraft to use swept-back wings and stall fences. The primary mission of the X-3 was thin wing research. The X-4 was its lack of a horizontal tail. The X-5 could sweep its wings in flight.
Pilots achieved a 7-1 record over the MiG. The United States Air Force played a vital role in holding the line against communist aggression.
Step by step, these different aircraft helped nibble away at the unknown until the frontiers of manned flight had been advanced from speeds of 500 miles an hour to Mach 3.
It was long before Sputnik that we decided to build the X-15. This was a logical step in the research aircraft program, the first hypersonic aircraft.
What is to be man's role in space travel?
Hypersonic, that guy.
Aircraft out of the Earth's atmosphere, fly it in space, then re-enter the atmosphere and bring it back to a safe landing on Earth.
Designed to investigate the problems of manned flight in a near-space environment. There were many unknowns to be discovered, many problems to be overcome. Hypersonic flow of air would heat the leading edges of the plane to 1,300 degrees Fahrenheit. How could the pilot control the aircraft in air so thin that normal aerodynamic control would be impossible? No engine like this had ever existed before.
The 50,000 pounds of thrust in its single chamber had to be controllable at the pilot's discretion.
The X-15 pilots flew to study the physiological aspects of high-speed and high-altitude flight. The data gathered proved to be invaluable to follow-on missions beyond the Earth's atmosphere and high-altitude flight. The data gathered...
Anybody know who that guy is? Anyone know who that one is? That guy? That X-15 pilot? Thomas Jefferson? How'd you know? Is that Tom Hanks' character? No, that's Neil Armstrong.
Proved to be invaluable to follow-on missions beyond the Earth's atmosphere.
They have dramatized the potential of piloted high-performance aircraft in a space environment at a time when much of the world's gaze was turned toward orbital flight.
The aeroplane has become an important means of commercial transportation and a decisive weapon of war. Air transportation helps our economy.
The United States is only about 5 hours wide.
Research programs investigate
5 hours wide, yes.
At ever greater speed as time and distance shrink.
A supersonic transport must be durable, and it cannot itself cost too much. The controversial XB-70 gathers valuable data.
It's nice.
YF-12s with a whole lot of supersonic, high-temperature type research, and the F-111 TAC airplane, which contributed greatly to the knowledge of the transonic machine.
A cross-country flight that would take you minutes instead of hours.
The X-43 is a revolutionary new kind of airplane. What we want to do with this is prove that hypersonic flight with an air-breathing engine is possible.
Through Mach 3.
Though the technology exists for aircraft to fly at speeds faster than the speed of sound, today's aircraft don't.
If an aircraft is flying from New York to Los Angeles, the sonic boom will be heard consistently across the country. We're talking about commercial operations. You're having, 40 in a day.
Would be breaking windows or at least annoying a lot of people.
People can't be
We
annoyed.
can in fact shape the airplane in such a way that we can shape the sonic boom and it sound different.
This project is looking to put instrumentation for the air crew to see where the airplane is booming the ground at. It's a real-time map display overlaid with the boom showing where it's hitting the ground.
Supersonic.
It's that pullout
that looks like
that
fun.
puts the quiet boom out on the area of interest.
Foxtrot, bird thump thump. Spike 3, thump thump.
The end goal is to create a quiet supersonic aircraft.
With the F-59 program,
We're going to be gathering a series of data from communities around the U.S.
relating
people's response to the noise to the sonic bumps. We're hoping that the data that we gather with X-59 will convince the regulatory agencies to change the no supersonic overland flight rule.
That would be nice. Cool. That was a little promo vid from NASA Armstrong, which is actually pretty neat. There's a lot of cool planes in there. All right, guys, let's jump into some space news. We got about an hour and 20 minutes until Starliner coverage picks up again here, so let's see what we got. So let me get rid of the starting soon thing. I haven't flown it in Flight Simulator, Alzer, but I know what it is. I almost applied for an internship with the X-59, but it was all remote. Oof. All right, so Jim Free is saying, Artemis is more than going to the moon. Jim Free is the guy, he's the Associate Administrator for NASA's Exploration Systems Development, ESD for short. Basically, Jim Free is in charge of all the research and development that gets done for future human spaceflight endeavors. Let's see, what is he saying? Artemis is more than going to the moon. We're learning to live and work on another world so we can explore more of the solar system, and we need your help. We're extending the deadline to June 3rd to get your feedback on NASA's draft Moon to Mars objectives. This is basically a solicitation to have people look over what their goals are for going back to the moon and Mars. Pretty cool. See, the part that I'm like, about is, you know, we're extending the deadline to get your feedback. Like, what? I don't... Can I, like, go give feedback or something? They extended the deadline, Hell Hydra. That's the news. What's going on with your search bar? Is that Africa? I don't know. It's... I don't know. It's Africa Day. Africa Day? It's Africa Day. There's an Africa Day? Are you having an Africa Day party? No. This is a space stream, and Africa is in fact not in space. It's on the ground. So, I mean, you can post your comments on it here. Ah. Cool. All right. Yeah, I'll have to check that out. Anyway, that's cool that they're updating it. That's cool that they extended the deadline. I'm considering it. I'll write something. Figure out what it is. Anyway, so okay, somebody linked this. What is this about? This is coming from David Nagy on Twitter. Let's see, what is David saying? Going through old photo albums and found this. Seems like a good idea. Oh. 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 AR-1s, huh? With the J2. Wow. This is an old concept, guys. There's no way that would be getting done. This is more likely what we're gonna get, but that though. Double J2X upper stage. Oh. Oh. You don't like Nagy? He said, I don't want to pay for millennials' poor financial decisions after bragging about how his parents pay for his expensive engineering school. Ooh. Twitter. Not even once. Not even once, JM. David's alright. I have no problems with the dude. But yeah, that's kind of... Okay. I mean, give me that paper, though. Yeah, here. I'll link up the picture. I see it. I want it. Tozzle, probably. I mean, Tozzle probably does want that for what it's worth. I mean, that actually would be a good idea, but that's a heck of a lot of re-engineering, guys. That if you gave NASA Apollo funds, it would still take about 5 years to get that done. But it could be done, sure. Any engineering is possible. It's really you could attach a shuttle to the side of that if you really wanted to. NASA could engineer that, no problem. It's just why. It really depends on what your criteria is. Yeah, JM. Yeah, I don't know, man. I mean, how old's David? How old's that dude? He's still just a kid. He'll figure it out eventually. They all do. Look at me. I was about as arrogant as they come 10 years ago. You figure it out eventually, man. It's really when you start paying taxes and stuff, you get out of school. That's what it's like. Oh, this sucks. You know? Am I right or am I right? Make it a block 3, perfect time skill. Yep. I was cringy as frick when I was a high schooler, that's for sure. And you figure it out. You figure out to be a little less uncouth as you get older, huh? It is what it is. With that being said, JM, something that I've just talking about me for a second. I refuse to let my parents touch my student loans. Nope. Could they? Yeah, maybe. I don't know. Never bothered to ask. I paid for all of it myself. Paid down about half of it. A little bit more. Actually, yeah, it's a little... it's about half. Yeah. Oh, well. But, yeah, that's interesting. But either way, dude, yeah. Don't go Twitter on people, right? Like, they'll get it eventually, dude. That's what I like to do, dude. I find that, like, telling people, like, no, you're doing this wrong, they're stubborn. Just like I'm stubborn. People say, hey, Jay, you should do this. And I'm like, yeah. They'll figure it out over time, The way I survive Twitter is with a very liberal use of the block button. JM, my rule with Twitter is this. Twitter is a zoo. It's a zoo. You can go to the zoo and you can enjoy the exhibits. You can even make nice comments about the exhibits. Do not jump into the lion's den. It's a waste of time. It's a frivolous endeavor. Even if you argue with somebody on Twitter, no, you're wrong, no, you're wrong, no, you're wrong. What did I just say about trying to tell people? Try to tell people, hey, you're doing something wrong. Now, people like figuring it out for themselves. They'll figure it out eventually. Convincing them on Twitter certainly ain't going to help. Like, trying to convince them on Twitter certainly ain't going to do anything. So don't jump into the lion's den. They'll figure it out eventually, Do not go gently into the good night. My account got suspended after I told somebody I would... Yeah. Okay. I see you like jumping into the lion's den. That's fine if you want to do that. Yeah, Maverick, that's right. You get Twitter with some popcorn. You get some popcorn, browse Twitter for a little bit. Don't become part of the exhibits. You don't go into the elephant exhibit and be like, I'm an elephant. I'm better than you. The elephant will get startled and will promptly turn you into some nice fine red paste on the ground, right? Not worth it. It's not worth it. You want to get trampled by an elephant? That hurts. Those things are heavy. It's like getting hit by a bus. I see Twitter as more of a petri dish. Sure, lots of things are happening, but none of the things really concern you. though. Yeah, I just make comments about stuff from time to time. Hey, look at this. Hey, look at this. You guys might like this. I think this is cool. That's it. I don't join the zoo. Hell no. Nah, I'm good. I'm good. Like, see? See, here. We can comment. See, this is a nice picture from Derek, from Vulcan. Here. Great picture, buddy. Yeah, we don't need to capitalize, buddy. You're not my buddy, friend. See? There you go. Great picture, buddy. Done. Easy peasy. That's my extent of Twitter use. What the heck are you doing over there, Zay? Are you drunk? Are you, is that a... That's Kistler on top of Titan. What is this? What? That's on top... Okay. Enjoy the zoo. Don't become part of it. Yep, okay. I didn't need that in my life today. What about this? Oh, yeah. Yeah, we saw that one yesterday. That's just... Okay. Okay. I'm just going to pretend that none of those exist. It's probably for the better. Mini RS-25s. Nice. How would those even work? Does that thing even have enough thrust? I don't think it has enough thrust. Those engines would need to make a lot of power. Alright, what else do we got? So, speaking of SLS and heavy lift rockets here, this is coming from over at NASA. While the Artemis 1 team prepares for its upcoming mission, NASA and contractor teams are already building the rockets to support future Artemis missions. In ULA's factory in Decatur, Alabama, major components have been completed for Artemis 3's interim cryogenic propulsion stage, the ICPS, that will provide the power to send astronauts to the moon. The ICPS, which is built by ULA under a collaborative partnership with Boeing, provides in-space propulsion for the Orion spacecraft after the solid rocket boosters and SLS core stage put it into Earth orbit. Nice. We got parts. Hey, that looks like a hydrogen tank to me with spray-on foam insulation. And then there's the it's technically an inner tank, but it's a hollow inner tank with COPVs, and then the LOX tank bolts down here. Cool. Sweet. The ICPS is, of course, a Delta IV derived upper stage. Oh, there's the pictures that aren't on a slider that David posted here. That's messed up. Yep. LH2 tank, inner tank, and potentially the LOX tank for the ICPS. Let me see. Yep. That was from Vulcan footage. But yeah, see the Vulcan core right here when they were painting it? Oh, there you go. Yep. Nice. Very nice. Looks great except for that flag graffiti. Smell that, guys? It smells like jealousy to me. Ah. Smell that? It smells like jealousy to me. All right, so little bit of bad news coming from the Psyche mission. The Psyche mission is the mission to one of two NASA's leading missions out to asteroids. Well, to the Psyche asteroid. We did cover this briefly yesterday, but I'll cover it again. The mission to Psyche is nearing its final stages of preparations and launch, and the team is working to ensure all hardware and software systems are operating correctly. To allow more time for this work, the launch period is now no earlier than September 20th. Psyche was supposed to launch in August, but it looks like they're having some trouble getting the payload configured here. This payload will be going out to the asteroid Psyche to survey it, which is a potentially $1 trillion asteroid with a lot of rare earth metals on it. That's where it's going to go out to. This will be launched on a Falcon Heavy, now net September 20th of this year. So, a little bit of a delay on NASA's Psyche mission, but not that big of a deal. A month delay is nothing in the scheme of things, guys. It's nothing. I thought there was a software problem on Psyche. Well, that article didn't say that it is or it isn't, I don't think. But, yeah. Seems... The team is working to ensure that all hardware and software systems are operating correctly. So, it's something wrong with the discombobulator that's aligned with the encabulator turbine, which is placed in panendermic semi-boloid slots of the stator. Every seventh conductor features a non-reversible Tremie pipe to the differential girdle spring on the up end of the Grammys. The turbo encabulator is now reaching a high level of development and is being successfully used in the operation of no for trunnions. Moreover, when a fluorescent score motion is required, it may also be employed with a drawn reciprocating dingle arm to reduce sinusoidal repleneration. It's not cheap, but I'm sure the government will buy it. Oh, JM, you don't need to post the copy pasta. I got you. I got you.
For a number of years now, work has been proceeding in order to bring perfection to the crudely conceived idea of a transmission that would not only supply inverse reactive current for use in unilateral phase detractors, but would also be capable of automatically synchronizing cardinal grammeters. Such an instrument is the turbo encabulator. Now, basically, the only new principle involved is that instead of power being generated by the relative motion of conductors and fluxes, it is produced by the modial interaction of magneto-reluctance and capacitive diractance. The original machine had a base plate of prefamulated amulite surmounted by a malleable logarithmic casing in such a way that the two spurving bearings were in a direct line with a panametric fam. The latter consisted simply of 6 hydrocoptic Marsal vanes so fitted to the ambifacient lunar wane shaft that side fumbling was effectively prevented. The main winding was of the normal Lotus O-delta type placed in panendermic semi-boloid slots of the stator, every 7th conductor being connected by a non-reversible Tremie pipe to the differential girdle spring on the up end of the Grammys. The turbo encabulator has now reached a high level of development, and it's being successfully used in the operation of no for trunnions. Moreover, whenever a fluorescent score motion is required, it may also be employed in conjunction with a drawn reciprocation dingle arm to reduce sinusoidal repleneration. It's not cheap, but I'm sure the government will buy it.
See? I looked at a deadpan at the camera the whole time. I don't have any lines here. What? I'll take one McGriddle, please. Sir, this is a Wendy's. That's one of my favorites, man. I want the 2 hydrocoptic Marsal waves and 1 dingle arm, please. Okay, all right, new plan. We start a restaurant where all the things on the menu are just items from the turbo encabulator. Good call. Well, there's your problem. The Dingelharm and the Furtrunians are too close. Yeah. That's why they're designed to reduce sinusoidal repleneration, because they get close and far away from each other very quickly. It's no good. I want marzel veins with cheese, please. I'm okay with this restaurant. Can you imagine? Yeah, I'll take 1 hydrocoptic marzel vein, and I'll take 3 dingle arms, please, with a side of repleneration. All right, that'll be $3.95. Would you like extra girdle spring with that? Oh, yes. Oh, my God. That'd be awesome. That would make my day. That'd be so funny, man. Dingle arms. Wings. Yeah. $3.95 in this economy. Well, yeah, it's like little bits. Little bits. Oh, man. We got tiny food. We got tiny hamburgers and, tiny hot dogs. Little bits. Oh, shoot. We even got tiny people. Little bits. Yeah, little bits. Just come on down the little bits. Okay, next news. Thanks for the food truck ideas. You're welcome. You're welcome. So, Jeff Faust over at Space News, the actual Space News, not just our pokey Twitch stream over here. Hey, Pearly, what's going on? Probably Dunpeel. There are fast food restaurants over here that have secret menus that aren't on, like, you walk in and then there's a bunch of stuff on the menu, but there's things that aren't on the menu that you can order that are on the menu, but they don't show them. There's secret menus at some restaurants. It's actually pretty cool. I'll take a double animal style with a Neapolitan shake. Thank you very much. Hey, Mac, what's going on? Burn it and let it swim. We serve food here, sir. Yep. The Roadkill Cafe. Where, Orion? Which Roadkill Cafe? Well done. Animal fries are good. Animal fries are good. Yeah. So, does one advertise such dishes? Nope. Nope. In-N-Out, as far as I'm concerned, has never advertised their secret menu. It is entirely by word of mouth, which is actually really freaking cool. Yep. The other thing about In-N-Out, Dunpeel, is that their burgers are a la carte technically. So if you want a burger that's 5 patties, you could order a 5x5 animal style with a Neapolitan shake, and that will give you a hamburger with 5 patties on it. With animal style as the special sauce. It's basically an everything burger. Yep. Goover! Secret menu, you say? Yep. Yep. In-N-Out's dope, man. It's really good. I get it. Everybody likes In-N-Out, and now the trendy thing to do is to say, well, I think In-N-Out is overrated. I like this restaurant that's near my house that nobody knows about. Yep. Yeah, that's the trendy thing to do now. I still like In-N-Out. I think it's good. 5x5, wouldn't that be 25 patties? No. 5 patties, 5 cheese, dude. Yeah, no. If you could order a 25 patty burger if you really want to. You just 25 by 25. That's the cool thing. You could go up to 100. You could order a 100 patty burger at In-N-Out. That is part of their menu, but their menu is exponential. It's actually really cool, man. I think it's really neat. Sonic has a slap yo mama slush. Okay. I'll have a double triple bossy deluxe 4x4 animal style on a raft, extra singles with a shimmy and a squeeze, light axle grease, make it cry, burn it and let it swim. We serve food here, sir. Yeah, it's delicious. It will also give you a heart attack down the way, but that's tomorrow's problem. Yeah, because people eat fast food to be healthy, Dunpeel. Yeah. The heart attack grill at Vegas. Yeah. God's making me want that beef burger when I'm allergic to beef. Oof. I'll take 2 number 9s, a number 9 large, number 7, number 6 with extra dip, 2 Colt 45s. Nice. Just ask for salad? Dude, don't go to In-N-Out for salad. Why? Why would you do that? Do they even have salad? I don't think they serve salad. Anyway, moving on. If you're on a diet, but you could get better salads at other places. I'll have 4 fried chickens and a Coke and some dry white toast. Anyway, so Jeff Faust is the guy that runs Space News here, and he's over at the Space Tech Expo, and he took a picture of a slide that includes upgrades to Virgin Orbit's launch system, shown by Jim Simpson. Let's see what we got here on this. Are those side boosters on Launcher 1? Launch stage fully reusable, evaluating potential stage 1 recovery and refurbishment. Launcher 2 on the back of the holy shnikes. That's an updated version of this from last year. Oh. Wait, no, frick all this. What's that? Well, that's pretty neat. You know, before people say, huh? You can mount stuff on the back. You can mount rockets on the back of a 747. That's totally doable. They did that once. Multiple times. That's pretty neat. Cool. So, it looks like Virgin Orbit is looking at some stage 1 reuse. I don't hate that. That's pretty cool, man. How are you going to launch that without frying the tail? You let it go and let it glide, hence the wings, and then you fire the engine when the 747 is not near it, just like how it does now? Looks like a glorified cruise missile. No. No, it doesn't. Alright, anyway, so we still got a little bit of time here. Let's go see what's going on down in Boca Chica from our buddies over at NASA Spaceflight. Looks like we got 2 videos to watch today. So let's take a look-see and see what we can see. The missile does know where it is. Yep. Is such a system not like the Concorde? It looks cool and goes fast, but once one crashes, it's all over. You just compared a supersonic transporter, a supersonic passenger liner, to a converted 747 that launches things into space. Dunfield, those things are so ridiculously far away from each other. You just compared a smart car to a tugboat. No, it's fine. 2 way different things. No, it'll be good. In fact, Virgin Orbit has already launched 2 things into space. The first one didn't work; it already failed, and then they launched another one, and it didn't. So, yeah, no, 2 different things. You're fine. I mean, using a 747 from a rocket. No, I know what you meant. Yep, point still stands. You're a duck. You need to be educated correctly. Nah, I don't know about launching off the back, but so Dunfield, okay, a little bit of a history lesson here. They've launched stuff off the back of a 747. It's been done before. And in fact, it's been done with something that's way bigger than that. You guys think I'm going to miss an opportunity to talk about the shuttle? Hell no. Hell nah. Check this out. To test out and validate the shuttle's aerodynamics at subsonic speeds in the 70s, NASA did this. That's a little bit bigger than the other thing, isn't it? Oh, it works. It works just fine. You just got to get it to go away. Now, don't get me wrong. The shuttle didn't fire its rocket engines. They were using it to test the shuttle gliding back down, right? But the same idea still stands. Dunpeel, I've talked to the guy that's flying the shuttle in this picture. I've shook the guy's hand. If you guys know Apollo 13, well, it was Fred Hayes. The guy that was on Apollo 13, I've talked to him face to face, shook the guy's hand. The key here with the 747 to get it to do that is to stall it. You stall the 747 underneath the space shuttle. And then right when the 747 stalls, that's when you let the space shuttle go, and the 747 drops away from the space shuttle. That's exactly how they did it during the approach and landing tests. They didn't so much jettison the space shuttle off of the 747, but they stalled the 747 and then let the shuttle go, and it falls away. If you look, the shuttle is flying straight here. The 747 is falling. Interesting, huh? Pretty cool. Yeah, that's not what I think. That is right from the guy that's literally flying it in that picture. The guy that's at the helm of Enterprise right there is the guy that told me that. That's right from his mouth. I got it on video too. You stall the 747 and then jettison the shuttle. I probably think they're going to do something similar because you don't. What happens if you're just flying and you jettison it? The shuttle's going to go back and obliterate the tail, like what you're talking about, right? Yeah, you have to get it to not do that. That's Edwards Air Force Base right there. I think that's 1836, I think, on that runway. I forget. But yeah, they'll probably stall the 747 underneath it if it's jettisoning off the top. Yep, here it goes. Oh, 17. That was 17, not 18. But yeah, they did this in the 70s with the approach and landing test. You can absolutely jettison something off the back of a 7.4. It's been done before. That's probably why they're considering it. They'll probably go and raid NASA's technical resources when they jettison that to figure out the right way to do it. Also, that's nice. For a brick, it flies pretty good. I thought that there would be turbulent air. I swear I watched a video recently that explains why planes have to wait during takeoff and landing. Turbulent air where? There's always turbulent air. Oh, look. There's Fred Hayes right there. And that's Gordon Fullerton, I think. But yeah, it wouldn't be the first time that they've jettisoned stuff off the back of the 7.4. Does that make sense? I get somewhat the technique behind it, but what if one crashes? Public opinion about doing rockets on airplanes will not be so good, won't it? Yeah, Dunpeel, but the same could be said about any medium of getting anything into space. I mean, I got to watch a shuttle on the 747 flying around Houston before they sent it off to California. Nice, engineer. That's cool. That's cool, man. I miss the space shuttle. I miss it a lot. We can bring it back, right? We could. That'd be cool. Could we? Okay, guys, new plan. Find a way to make like $30 billion or something. Yes, billion with a B. That's what we're going to need. That's what we'd need to bring the shuttle program back. Find a way to make $30 billion, and then we'll do it. We need to make new shuttles, though. That's the rule. Got to make new shuttles. Crowdfund shuttle program? I mean, Joey, the first one was crowdfunded. What do you think paying taxes is? That was a terrible joke. Do it, JM. How would we do it? Kidnap Elon? Well, I mean, he's already kind of making Space Shuttle 2.0, so we probably wouldn't want to do that exactly, right? Like, yeah, he's already building rockets. We don't want to disturb that. Just let the Elon do rocket things, okay? We'll do this separately from that. Enhanced Dream Chaser? Dream Chaser, you guys know that meme, we have this at home? Mommy, I want a space shuttle. No, Timmy, you can't get it. We have Space Shuttle at home. You already have a Space Shuttle. We have Space Shuttle at home. Space Shuttle at home. Dream Chaser is cool. Don't get me wrong, but it's like when you get Mega Blocks for your birthday when you wanted Legos.
Discovery.
Mega Blocks are cool. I'm not hating by any means, but they're not Legos. Hey, Lig, what's going on, man? Dream Chaser. Oof. 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 Damn. Nah, Mega Blocks suck. I prefer Legos, yeah. You know, it's not the same, man. It ain't the same. Gotta find a way to bring it back. We gotta find a way to bring it back. Wouldn't that be sick? I don't know how I would do that. I'm not smart enough to do that. We don't need a shuttle replacement. Just ask any Hollywood executive. I'm not sure I get that joke, but all right. Just take the X-37 and install some seats on it. No, that's the same thing. Oh, I want a space shuttle. We have Space Shuttle at home. Space Shuttle at home, X-37C. No. I will not compromise. If we're going to bring the shuttle back, we're going to bring the shuttle back, okay? Jeez. When your mom mixes the Lego and the Mega Blocks. Oh, that was so infuriating. Even 20 years ago when I did that, that's still infuriating. No, the Mega Blocks need to stay separate. Keep them away from the Legos. You don't play with Legos and Mega Blocks at the same time, all right? That's what crazy people do, okay? Crazy people do that, all right? Crazy. What would you change on the shuttle? What would I change? Right, Aldezard? It's just messed up. It's wrong. I like Mega Blocks for kids that actually use them. I have terrible fine motor skills and can't put Legos together. Yeah, I think the Tough Rock tiles would be better. The Tough Rock tiles and then interchangeable tiles on top of that. Yeah, that's what I would do. You know, a lot of the shuttles kind of Achilles heel from the program was the thermal protection system. If we're using Tough Rock tiles, they're lighter and they're stronger. They can withstand higher temperatures. Basically, shuttle with the tiles that Starship is using. Now, what's Tough Rock compared to the shuttle tiles? The shuttle tiles are a silicate-based tile. They're basically porous rock. They basically glued a bunch of rocks to the bottom of the space shuttle. Tough Rock is the tough and unifibrous, reinforced, oxidation-resistant, corrosion-resistant composite tile. It's like wound fiber instead of porous rock. Much more reliable. How do I know? How do I know that's a lot more reliable? Well, we were talking about the X-37B. The X-37B has a 100% reusable system. And if you look, the X-37B doesn't have any gray nose cones or gray leading edge wings. That's Tough Rock tiles. They'll straight up resist re-entry heating. You don't need any complicated thermal protection system. And I know that, once again, because the X-37 is literally a tiny space shuttle. Oh man, we even got tiny space shuttles. See? Same thing. Even uses shuttle-derived thrusters on it, but the Air Force won't tell you that. So yeah, a shuttle with tough rock tiles, tough rock interchangeable tiles probably would be a better solution. There's like a multitude of things that you should probably fix. Are the tiles heavy? They have the consistency of about styrofoam, Micon. The problem is when there's 37,000 of them, that styrofoam consistency does add up. Yeah, Nighthound, kind of, yeah. It's wound carbon instead of reinforced carbon. Yeah, that's what Starship and X-37B are using. They use a similar tile, but they're not the same. They're not interchangeable. Bringing back the shuttle is good, but consider Shuttle 2. I really don't like anything about this design, to be 100% honest with you. I really don't like the Shuttle 2. I'm not really that big of a fan at all. That is so ridiculously dangerous. Dude, I'd rather fly on a regular space shuttle than that. There's like 1,000 different things that can go wrong with that thing. And not to mention, you're literally bolted to the fuel tank. Like, you're riding with the fuel tank behind you, and it has no payload bay. Like, why would you use this? How do you jettison those tanks? I don't want this. What if the tank hits the wing? Then you're screwed. I don't want any part of this. I don't want. Yeah, no, I'm good. I don't need that. What about cargo? What's the point? Yeah, no, I think the shuttle is about as good as you can make a design where you want to make a partially reusable vehicle, i.e. like external tank and stuff. It doesn't get better than the shuttle. That's about as simple as you can make that idea. So you have an internalized hinge cargo bay attached to a thrust structure. And somehow people think that this wouldn't get this would kill less people than the actual space shuttle. Okay. Yeah, no, that thing's more of a death trap than the actual shuttle is. That thing's more of a death trap than the shuttle is. What are you, nuts? I wouldn't fly on that. What are you, crazy? It's fine. It has an abort system, though. I'll take my chances with the regular shuttle pigs. Are you kidding me? Yo, that's gonna get somebody. That's too complicated, man. It will kill fewer people because it will actually never fly. Yeah, I mean... Sure. I'd rather just remake the actual shuttle with just modern upgrades. That would be better. Modern manufacturing, modern upgrades. Be way easier. Anyway, let's get back into the Starship footage. Speaking of next generation space shuttles. This footage is coming from our buddies over at NASA Spaceflight. That abort system, though. Yeah, that... okay. Yeah, that abort system. Okay. Spoiler alert, Zay. That abort system that the Shuttle 2 has is about as useful as a car having ejection seats. True story. What is that gonna do? Get you away from the fuel tank that you're strapped to? What are you gonna do, launch forward? Nope. Ejectocito, cuz! It's coming from our buddies over at NASA Spaceflight. Go over there and give them a sub on YouTube here. They let me look over this footage of guys installing roofs all day. Here we go. High Bay 2 is almost done. Better known as the Wide Bay. Also known as the Wide Peepo Bay. Looks like they're putting the roof rafters up there. What's your preference? Wide Bay, High Bay 2, Mega Bay? I like Wide Peepo Bay. Thank you very much. Starliner re-entry path with viewing opportunities. As if I don't have that loaded up already, Sebi. SMH my head. I think the abort systems are a good idea. Okay, you guys missed the point. Listen, hear me out. The reason why I said using a car as like it's as useless as a car with ejector seats is because what is that going to do? What is a car with an ejector seat really going to do? Is it going to eject before you hit the wall? Maybe it ejects you when you hit the wall. Great. So now instead of hitting the wall, you're getting ejected out and away from the car. And you get thrown away from the car, but now you're up in the air and now you need to parachute down. What the heck is that going to do? That is actually more dangerous than just building a car that just absorbs the impact. Now, how does that analogy pertain to launch vehicles? Well, if you achieve a high frequency of flights with your reusable launch vehicle, like what Starship is trying to do, for instance, you don't need an abort system. Why? Why don't you need an abort system? Don't you think you should plan for the worst? Well, yeah, there's nothing wrong with having abort contingencies, and the shuttle did have abort contingencies, but the expectation with the shuttle is high frequency of flight. With high frequency of flight, ejector seats or some type of escape mechanism makes no sense. That ends up making it more expensive in the long run because you have to maintain those systems every day, and it has to be looked over every day. The idea is that if you design the vehicle to just go up into space, and well, which they didn't really do that. Well, they did it okay. Let's say they did it okay. The idea is that if you fly the shuttle more and more, you understand its behavior more and more, and you could prepare, and you get better at aborts over time. Now, don't get me wrong, they should have done that with the shuttle before they put anyone on it ever. Underfunding do be like that, though. I've talked about that many times. But the idea with the shuttle is that you don't have any type of abort system, and that was implemented into the design due to stakeholder expectations of high frequency of flight. Now, I know people are probably playing dumb and going, well, it still should have had an abort system, EJ. Okay, does an Airbus A320 have an abort system? Does a 747 have an abort system? Does the Concorde have an abort system? Nope. Why? Because they're designed to fly a lot. And if they fly it, you fly it a lot. That's the idea. You fly it a lot, you don't need those systems because the system becomes more reliable over time. Any system does. That was the idea with the space shuttle. So it's funny, you fly it a lot, and they should have flown it a lot without people, which is where Starship is going to make it work, because Starship's going to fly a lot without people before they ever put anybody on that thing during re-entry, which is a good idea. That's Elon's self-admission by himself in one of Tim's videos, right? One of the Everyday Astronauts interviews with him. He said the problem with the shuttle was that they couldn't test it with no people on board, so they couldn't rapidly prototype the thing, which is 100% accurate. I mean, Elon's after all trying to build Shuttle 2.0. I think it would probably be a good idea to go and research the shuttle program and why it didn't have a launch escape system, right? And now, if you're still not sold on the shuttle, I'll just talk about Starship then. Starship won't have an abort system because Starship is designed to work. But the difference between Starship and the space shuttle is that Starship is going to have thousands of hours under its belt flying before people even ever get near it. That makes sense? You know, it's not inherently that abort systems are a good or a bad idea. You can't just say engineering doesn't work this way. You can't just say, "Oh, I think that an abort system is a good idea." It depends. It depends on what you're doing. In some cases, an abort system can make your project more complicated, and that actually makes the project less safe. Now, don't get me wrong. There are case circumstances where that's the case circumstance, like a 747, for instance. They don't have parachutes. 747s don't have parachutes. They don't have ejector seats. There's no abort system. If you lose both engines, you're going down in the Hudson. Yeah, good reference, right? I think Tom Hanks did that once. See what I'm talking about? There's no abort. Planes are the same way. But how do we get around that? What makes planes so damn reliable? Trying to make the plane as simple as possible, i.e. less abort systems, because less abort systems make the plane more reliable, and the reliability makes it more safe. That, and we fly thousands of planes every day. That probably has something to do with it. The abort system on a 747 is the wings. I mean, I suppose those are only going to get you so far. But Jim, the same argument, JM, the same argument could be made about the space shuttle. The abort system is the wings, just RTLS. Am I right? Don't you think that comparing rockets to planes is not fair because planes are much simpler? Yeah, Tim, you missed the point entirely. The plane is simpler, isn't it? But there was a time when it wasn't. There was a time where jet engines were dangerous, where jet planes were dangerous and could get people killed. Read about compressor stall. Early jet engines, if you hit the throttle too fast, the engine blows up. True story. And, you know, your plane being on fire is not a good thing when you're flying. Plane being on fire at all is not a good thing. Because you know what? Aluminum burns really, really well. It makes great rocket fuel. Yeah, believe it or not. The SRBs on the shuttle burned aluminum for their fuel. Actually, it was aluminum flakes as a stabilizer, to be clear. But the reason why the plane is so simple is because the design is refined. It's been refined over time. Planes have been around a lot longer than spaceships have, man. See what I'm talking about? It's simpler because of the reasons that I'm talking about. And, you know, before you say, well, what a plane does and what a spacecraft does, two different things. Yeah, sure, I guess if you want to compare project to project, if you know, like going into space versus going into orbit are two different things. But also at the same time, they're just systems engineering projects. Implemented stakeholder goals in engineering projects, like in the confines of systems engineering, doesn't matter. Product maturity is absolutely a thing, regardless if you're building a Starship or you're building a 737. It's still the same ideas. It's the same implementation, more or less. Risk is retired over time, Bloody, by launching more. Once again, fellas, it's all about understanding what you made. We understand how planes work really well because we fly a lot of planes around. The same argument can be made for rockets. That's what I'm trying to tell you. And that's what they were trying to do with the shuttle program. The idea is that we're trying to normalize flying into space. And they're trying to normalize it with a orbiter, with a space plane, right? So the idea is that the shuttle didn't have an abort system because it would be flying into space every week. You'd get a lot of flights. You'd understand what you made. Problem is that they started launching the dang thing a lot. The shuttle was telling them, look, I have problems you need to fix. And then they just said, nah, it's fine. And then it blew up. Who knew when you ignore the behavior of the vehicle and the vehicle's doing something that you don't understand, ignoring that can cause people to get killed. Interesting concept. What do you think about warp drive faster than light communication for Elon's next projects? What? I've seen multiple movies where Air Force One has a working ejection pod. How accurate are those movies? It's a movie, Dunpeel. It's a movie. So, no. Anyway, let's get back to the Starship footage, guys. Hopefully that helps. Like, once again, I'm not trying to say that abort systems are good or bad. Don't get confused. It depends on what you're doing. That very much matters. Because a car with an ejector seat is pretty useless. You're more likely to get killed. Keep in mind, that's a very, very over-the-top analogy to try and get the idea into your heads. It's very over-the-top. A car with an ejector seat is just silly. But if a car did have an ejector seat, like you shoot out up into the air and you parachute down, that is way too complicated for an automobile and would most likely result in people getting killed. What if you're under a bridge and that happens, right? Like, see what I'm talking about? An escape system in that regard, in that construct of engineering, is actually less safe. That you're more likely to get hurt. See what I'm talking about? That was the idea with the shuttle. And once again, hindsight is 20/20. So, you know, if you guys say, well, Well, the shuttle still killed people. Yeah, well, you didn't... Where was that take in 1980 when before the shuttle started flying? You know? You won't know until you do it. Yeah, Blue, exactly. You know, everybody could say, oh, it needs to be safer. But if you're saying it needs to be safer in hindsight, that demonstrates a fundamental lack of how engineering works. Like, how do you know? What's safe? What's safe to you? Just because it got somebody hurt? Well, yeah, obviously. Where was this take before that happened? You know what I mean? That's like looking at the Mona Lisa and being like, wow, that's a really nice painting. You know, or looking at it when, you know, the painter drew the first stroke and saying it's going to be a good painting before that. Well, how do you know? If you say it before, then maybe you know because the guy's a good painter. But anybody can look at the Mona Lisa and say it's a good painting, right? Obviously. It's all about what you're trying to do. Engineering is application-based. What are you doing? Not why are you doing it. What are you doing? You ever see that? You ever see that old commercial? I'm gonna date myself here. What are you doing? What are you doing? So you, Pigzig, you want the Mona Lisa to have an ejector seat? Okay. Space travel only interests me if it's affordable. Okay. Good to know. Firmly believe flying cars are a terrible idea. We can't drive on the ground good. Yeah, no, yeah, there's a reasons why you need a different license to use something that works in 3 dimensions instead of 2. Am I right? I see this as an absolute win. Okay, Mona Lisa with ejector seat. That's the moral of the story today. Looks like they're reconfiguring the cranes here. That's weird on front. More roof rafters. Alright. Bruh. The Mona Lisa doesn't need ejection seats if you use it frequently, though. That is a very good point. Guys are putting crane segments together, or are they taking them apart? I'm gonna go with taking them apart. And there it goes. You're gonna hammer the pins out, and then you're gonna grab the next one. Yep, disjointed. Hammer out the top pins. There they go. Pins are hammered out, and Luft. Luft. Bye-bye. Bye-bye. Gonna cry? Take your crane apart, baby? Beautiful roof and sides. Love it. See ya. I love cranes, Queer. Cranes are cool, man. Who, Jackal? Love it. What's with the crane memes? They're not funny. They're not funny. Who? I don't know who that is, Jackal. I have no idea who you're talking about. They use cranes to build cranes. How was the first crane built? Well, a small crane is used to make a bigger crane, so you just started with a little tiny crane. Beautiful, beautiful crane and lift. Love it. See ya. Ba-boom. When does Starliner land? Loopy, we're looking at it's 6:49, dude. 6:49. So we're about an hour and 30 minutes out from Starliner touchdown. 6:49:07 on the dot. Is that going to be a mega bar? I don't know what they're going to put up there, dude. Yeah, Loopy, coverage should be beginning in about 20 minutes. The better question would have been lathes. You really need a lathe to build a lathe. That's a really good point for her. Look at DM on stream. What, you want me to play this? Jackal, I know what it's from. And yes, yes it is. Beautiful crane and lift. Love it. See ya. I know it's not appropriate for stream. Why do you think I'm saying beautiful crane? Beautiful crane and lifts. Love it. Did I hear EJ Monkey? Yes. Still funny. Must return to Monkey. One more time, just because it's funny. Ready? Still funny. I'm gonna need that for your soundboard? No. I can't make that noise again if I tried. I have the same question with software. We use software to build software. How was the first one coded? Well, your boy's been taking some CS50 classes. I can actually answer that question. Well, the first software was binary, right? Binary is what a computer understands even to this day. It's just 0 and 1s. Zeros and 1s because two options with a transistor, right? Am I right? Am I right? Yeah, I know. Computers speak in 0s and 1s. That's it. Different combinations of 0s and 1s will create different things. From there, they had to find a way to interpolate the 0s and 1s. So, at what is it? Base level logic, they went to assembly code, which is basically using it's kind of code, but it's kind of not. It's like assembly code for a computer is like, so if we speak English, and English is based off of German, and well, German is kind of, where does Germanic come from? Kind of Roman, I guess. Not really, maybe a little bit. Right? It's like the intermediary language. Even code that you write now, when you put it into a compiler, will get translated into assembly, which will get translated into binary. Yeah. So, I mean, I know it was a joke, Supercraft, but in case you were actually wondering, whenever you write code, right, and you compile that code, that's what compiling does. Compiling takes your code, moves it into assembly, and assembly is a really, really easy way for the computer to be able to take that code and translate it into binary so the computer can do computer things. Yeah, Germanic was a bad example. It would be like Italian to Latin to Greek. Kind of like that. Kind of. It doesn't really... It's like an intermediary between the code that we write on the computer and binary. The Saturn V had physical bytes that they would weave to process 1s and 0s. Oh, I know. Yeah. Yep. Yeah, Gagan. Something like that. Assembly is programming in mechanical terms. That's right, Potzer. Yep. Yeah, if you really want to know, the first software was binary, but binary is such a pain in the butt to use, they wrote assembly code. And then assembly, turns out, also is a pain in the butt to use. So they started figuring out better ways to do it, like C, for instance. And then there was C+, and then C++, and then there's C#, and then people in the 90s invented Java. We still don't know why. Yeah, we still don't know why they did that, but mistakes were made. Thank God you left 410 and ADA off that list. Keep in mind, it's a lot more complicated than that. But the first software was written in direct binary, and then somebody was like, "Wow!" Somebody did Supercraft. Somebody did what most programmers do. This is such a pain in the butt trying to tell this thing to do stuff with zeros and ones. That's stupid. I'm going to make an easier way to do this. And then they promptly spent an extra 5 years trying to figure that one out, right? And they spent a copious amount of years to come up with a new language that would help work with binary to make that 10-minute task that they were doing way easier. Because that's what programmers do. That's what they do. The best programmers are the lazy... Programmers are just a bunch of lazy mother truckers. Man, that takes too long. I'm going to write a script. How long does it take? It takes 20 minutes. I'm going to write a script for a week to get rid of this 20-minute process because I don't like doing it. Okay, cool. Done. Sweet. Good. I do assembly, and it's already a pain. Can't even imagine lower level. Dude, binary is... binary is... Yeah, that's about the lowest. Yeah, binary, it doesn't get... Is there any deeper logic than binary? I don't think so. I think that's the root, if I'm remembering right. This is taking too long. Screw this. This will take me 20 minutes. Nah. I can write a code. I can write a code that'll take it less. That'll just do it in 2 seconds instead of 20 minutes. Well, how long did it take you to write the code? A week. That's programming in a nutshell. It's literally just been that, rinse and repeat since the 70s. And they still do that today. This sucks. This task sucks. I'm going to make an easier way to do it. Spends 5 years making an easier way to do it. All right, this doesn't suck as much. And some other guy walks in. No, this sucks. Assembly code sucks. I'm going to write C instead. Screw you. That's what I'm learning. That's what Brimo and I... on our days off, Brimo and I watch Harvard CS50 classes, and we've been learning about how we got to this point. Yeah, it's it's literally somebody popping into the room. Hey, that idea sucks. I'm gonna find another way to do it. This way is gonna be way better. And then 10 years down the road, man, what was this guy thinking? This guy's an idiot. It's true. And then 10 years later, wow, this code sucks. I'm going to write a new code. I'm going to call it Java. All right, yeah, this is going to make everything easier. 10 years later, man, this Java really sucks. I'm going to write a better way to do this. Python, I'm going to call this code Python. It's going to be great. It just keeps happening over and over. It's just a recurring cycle. Yeah, Envy, yeah, we're taking CS50. That's what I noticed. It's just the pattern just keeps recurring. And then it's just code on code on code on code on code on code. Welcome to progress, indeed. I mean, this problem translates into aerospace engineering. Take Elon, for instance. Who is it? Who is a programmer? Because, man, this space shuttle sucks. Why would they do this way? This sucks. I'm going to make Falcon 9. That's way better. Click. It's true. It happens all the time. Did you just compare Python to Java? No, I said that Python was better than Java. I get the theory behind Java, right? Architectural agnostic, but it's Java. Yeah, dude, I don't even know that much about programming, Ted, and I'm still like, nah, Java, I'm good. I don't need that. No, I compared the Mona Lisa to an ejector seat, fellas. Jeez. This way sucks. I can do it better. Do you think we'll invent ourselves into obsolescence? Mm. But yeah, take my software engineering stuff at face value, guys. I know way more about aerospace than I do software. I'm getting there, though. I'm learning. Pro tip, every language sucks. Just like for humans, there's no best language, right? Truck. JAML, just another moron loose. I don't know what that means, Farah, but alright. Yeah, Mycon. Software nowadays is just software that's based on software that sucks, which is based off of software that sucks, which is based off of software that sucks, which is based off of assembly, which is based off of binary. And binary is a pretty crappy way for humans to communicate. But it's really good for the computer to communicate, and the computer can do it way faster than we can. KSP is written in C#. Fun fact. My knife is very C#. See my sharp knife? It's invisible too. It's stealth. Got it on sale. No, Jackal, I will not make out with you. Did you hear that? Jackal wants me to make out with him in the middle of the stream? I mean, we got Crane Man up there talking about God knows what. All Jackal's talking about is making out with me. I'm here to learn, everybody, not to make out with you. Go on with the Craneophil. Sorry, Jackal. Sorry, Jackal. Here, you get this. Gonna cry? Beautiful truck and pipes. Love it. Yeah, sure, Zay. Yep. Binary was first used to weave silk in the UK. Yeah, it's very weird. The origins of computing are very strange. So there's the suborbital pad, which it looks like they're converting that suborbital pad to a permanent testing fixture. See all the hydraulic jacks that they have on this thing? These are designed to simulate the upward thrust of the engines on the rocket when it's fueled. Well, I would say when it's fueled, but they have a Starship umbilical there that's similar to the quick disconnect, but there's no fuel lines. There's just holes. Sister, you are not Mr. Meeseeks. I am not looking at you. I'm Mr. Meeseeks. Look at me. You ever seen that movie Holes? No, I read the book back in the day, though. You know who is in that movie that I knew? Well, not that I knew of because of the movie, right? I don't know the guy. You know, Actual Cannibal, Shia LaBeouf. Yep. I'm working on the chopsticks up there. They installed more scaffolding, which scaffolding up here on the chopsticks tells me that whatever mechanism that they have up there, that's part of the catching mechanism. They may have redone it. I love that song. It is pretty good. Yeah, see, I could just do the arm thing and you know. Hey, Admit, what's going on? So the future of communicating will be Shia LaBeouf. Translate this. Net lag, that probably says NASA if I had to guess. Am I right? Nice. Your boy. Your boy. Your boy. Haha. It was a guess. I'm just kidding. That was a guess, but it seemed logical. No, guys, don't get me wrong. I'm not a software expert by any means. I've taken like 3 3 lectures. We've listened to 3 lectures of CS50. I have no idea what I'm talking about when it comes to software. The aerospace stuff, no, I understand that. That's fine. Well, debatable. Debatable. Also, okay, that's the quick disconnect hood there to protect the fuel line. See these guys right here? That's the methane and the oxygen fuel line. The small pipe is methane, the big one's oxygen. Now, I'll be honest with you. When the rocket does go off, this whole area is going to get a little hot. Yeah, you don't want to burn your fuel lines from the outside, so they're putting a big metal hood over it. Don't worry, people who work software don't understand software. Yep. Fair. That thing looks very freaking heavy. Been busy. You got house updates lately? No, I myself haven't gotten any house updates or not, and I'll tell you that's good. Because the bank appraisal is what's going on right now. As far as I'm concerned, while the bank is doing the appraisal, no news is good news. So, the less I hear about that whole thing this week, the better. And I've heard nothing thus far, so we are good. Hi guys, how's the Starship Orbital coming along? It's getting there, Airborne. What's up, buddy? How's classes going? Starliner landing coverage begins in 5 minutes. All right. Let's see them get that hood installed. Yeah, guy's using a industrial ratchet strap to pull that thing into place. Damn, dude. That thing is a tank. Splashdown is expected in about 1 hour and 15 minutes. Goof. Yep. Alright, so that's our NASA spaceflight footage for the day. I am going to switch us off of space news here, and then we're going to OFT-2 Starliner Re-entry coverage. I will tee up NASA TV here, and we'll watch a capsule re-enter. Hopefully. Please? Maybe if we ask nicely. There we go. That sucks, Airborne. Alright, well, hey, you'll be back. Yes, hello. I would like 1 capsule, please. In your opinion, which capsule is faster? What? Faster. What do you mean faster? They both go the same speed. They both go to the same destination. Starliner recovery team meetings from OFT-1. Ooh. Cool. I will put that over there. Here we go.
I feel the liftoff. The clock has started. Roger, 0G. I feel fine.
Godspeed, John Glenn.
Tranquility Base here. The Eagle has landed. Rocket Tranquility, we copy you on the ground.
New possibilities are opening up for scientific cooperation between countries.
1-0. Liftoff. Americans return to space as Discovery clears the tower.
Discovery, go and throttle up.
No, there you go, Airborne. That's good.
Everybody in the shuttle program, the crew is go for launch.
Rocket, nice to be in orbit.
We have followed in their footsteps to get us where we are today.
All right, here we go.
And Starliner has performed its final departure burns from the International Space Station, and it is on its way back to Earth. Good afternoon, and welcome to our live coverage of Starliner's return home. I'm Lauren Seabrook with Boeing.
And I'm Brandy Dean with NASA.
And Brandy and I are coming to you live from here in Mission Control in Houston, where we have just heard that we are goes across the board for our deorbit burn that will be coming up here shortly. And joining us in just a little bit, we have a team ready to go live from Starliner's landing zone in the western part of the United States.
Starliner's flight test began back on May 19th when it launched from Kennedy Space Center in Florida aboard an Atlas V rocket. There's a replay of that launch there. After completing a series of technical demonstrations and engine firings to adjust its course, Starliner arrived at the space station and docked with the orbiting lab the next day on May 20th. Starliner's return to Earth will mark the completion of this uncrewed flight test and another milestone for both Boeing and NASA's commercial program as we work toward increasing our capability to launch humans to the space station from the United States.
And earlier today, Starliner's incredible suite of systems powered up, and the spacecraft began its departure procedures
that's so
in preparation for its journey home.
We watched that while the Falcon 9 was launching.
In Houston, Florida, and New Mexico.
Depends on how well this re-entry goes, Genesis.
Autonomously undocked from the International Space Station this afternoon around 1:36 p.m. Central Time, and it was flying about 257 miles above Singapore. It then began a series of departure burns to move away from the station, and it was quite the sight.
That's really cool.
Great replay.
Jeb's coming home!
Following Starliner's launch on the 19th, the teams here on the ground did see some unexpected behavior from some of the spacecraft's orbital maneuvering and attitude control, or OMAC thrusters, as well as its reaction control system thrusters. Specifically, 2 of the OMAC thrusters shut down early during Starliner's orbital insertion burn, and later in the flight a couple of reaction control thrusters shut down early as well. However, Starliner has a total of 20 OMAC engines and 28 reaction control system jets, so there's plenty of redundancy to draw from.
Interesting.
And we still want to learn as much as we can about what caused those thrusters to shut down, however. So after the Starliner exited the ISS approach ellipsoid earlier today, we sent some extra engine commands to try and gather just a little bit more data on how those thrusters are behaving. The flight controllers had Starliner command both of the OMACs that shut off prematurely, as well as 6 of the reaction control system thrusters, including the 2 that stopped firing early on our first day in orbit.
After exiting the approach ellipsoid, each engine was commanded to fire individually, not all at once, starting with the OMACs. These thrusters are located on a service module, which we will be jettisoning shortly after today's deorbit burn. So the crew can then make its way back to the Earth alone. So this was our last chance to check those systems out before we got rid of the service module.
Well, I guess
and those engine
did anybody see if Jeb's actually inside of that capsule? I don't know if he is. But Potzer, they said that they commanded those things to actually fire, but did they fire? I'm wondering if they fired again. But yeah, I mean, that's what Aldous, your question a little bit earlier was, are we ready for cruise? Well, once again, fellas, we were talking about launch escape systems and stuff during Space News a second ago. This is what I mean about understanding what you made. That is a really, 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 really important thing to understand with spaceflight. You got to understand what you made. And the thing is that when you're sending something the size of a Mack truck up into space going 17,500 miles an hour, there's a lot of things there's a lot of perturbing force. A lot of things can go wrong. A lot of things can go right. But the point is, it doesn't matter if it goes wrong or goes right. You ideally want it to go right, but during a test mission, it's more important about understanding the behavior and making sure, well, actually, you want more things to go right. Some things might go wrong with the sensors, with the engines, but if the engines do have a problem, right, like what they tested, you're going to want to understand that behavior and understand why. So that doesn't happen in the future. Once again, these test flights are understanding the vehicle. You ideally don't want anything to go wrong, but it is space. Something will. Space flight is very, very susceptible to Murphy's Law. What can go wrong will absolutely go wrong. So it's important to learn and understand the behavior. And wait.
As Brainy just mentioned, because we had no astronauts on board, we had a little extra passengers, Jebediah Kerman, part of the Kerbal space program, which a lot of people were excited to see there as our gravity indicator, as well as Rosie, the Rocketeer, of course, named after Rosie the Riveter. She was our ATD device, and you may remember from our last flight, she had many sensors that were on her, and we were able to gather a lot of data about what the ride is like inside Starliner. And because we were able to get so much data from Rosie last time, we were actually able to move those sensors to other parts of the spacecraft this time. So now we'll have a better idea ahead of our crewed flight test how other passengers will ride in Starliner. Now, once we make the final burn to get out of orbit.
So that, like I said, it's about understanding what's going on here. And as long as you understand the behavior, that means you can correct it. It's like really, really hardcore IT work. That's what mission control is. It's just the original IT. It's just IT troubleshooting. But it's IT troubleshooting to the extreme. You don't just shut it off and turn it back on. You have to find root cause. That's not usually what IT people do. Right? Some IT people, I suppose. But that's what they're really that's what they really got to figure out. They got to figure out exactly what went wrong with those thrusters. But the part of that is that you're not getting your service module back, so they only have a finite amount of time here to test it. But at the end of the day, it's understanding behavior, and how well they have understood the behavior of Starliner is very dependent on this mission going correctly, especially when this thing goes through entry, descent, and landing, or EDL for short. If it goes through EDL and there aren't many surprises, even at the end of the mission, you're still, they have to tally the total amount of surprises, or what Gene Kranz would call unknown unknowns. They tally the amount of unknown unknowns and see how many of those they actually figured out and understood why they were doing what they were doing. And if there's well and good understanding to perform corrective action for the problems that they had, then they'll certify it for crew flight. Because it's not what you know, it's what you can prove, Jake. No, the crew flight test is entirely dependent on how well this whole mission goes. There have been some unknown unknowns, like why did the thrusters stop firing? But as long as that behavior is well understood, documented, and then corrective action is implemented on the next mission to make sure that it doesn't happen, it could be something as simple as somebody not connecting a wire all the way. It could be that simple. Probably is. It's always something stupid. It's always something like that. Never fails. Ask anybody that works in the industry. It's always something dumb. Like you didn't tighten a bolt all the way, or something came untorqued after you torqued it down, like in the case of SLS. It's always something dumb like that. But as long as you understand that behavior, you should be good. Anyway, I'm going to let them talk for a little bit.
At White Sands today, it can be a little difficult to get a great signal depending on where they are in the desert. So we do have a team of 3 people who will be coming to us live. 2 folks from the Boeing side and 1 person from the NASA side who will be out there in those White Sands bringing us a look at what the convoy looks like. They are setting up the convoy, and actually I'm told now we do have them. So we are going to go out live to our colleagues Dan Hewitt from NASA Public Affairs and Rosa Bonuelos and Megan Gessner from Boeing. How's it going, guys?
All these flavors, you choose salty.
Hey, Lauren. It's great to be with you. We are currently, again, here at our landing site at White Sands, New Mexico. It's a really warm day out here, but The team is staying hydrated as we wait for Starliner to come back home during its orbital flight test 2 mission. As you mentioned, we are having a difficult time establishing a good connection, but as we continue to troubleshoot, we will come back to you. Hopefully.
Why is it landing on salt? Landing on land is easier. Don't need a boat.
We are establishing the different teams, and as soon as that crew module lands and all of its parachutes and all of the parts have jettisoned, we will begin the recovery operation.
Yeah, we have an initial staging point that we were actually out here on Monday, and we were able to do some practice runs with the teams as they just have continued.
Why doesn't Dragon land on land? Because it's not designed to.
We changed last night. It moved us about 8 kilometers further north from all of our gear, which was not able to move with us.
Think about it like this, guys. Why do some capsules land on land? Why do some capsules land on water? Well, there are some airplanes that can land on water and also land on land. There are some airplanes that only land on land. There are some airplanes that only land on water. Think about it like that. But they're all airplanes at the end of the day. It's just really how it was designed. Now, the better question to ask, the more pertinent question is, well, why does Boeing want to land here? Well, they want to land here because it means you don't even have to go get a boat. You don't have to go get a boat to go and grab the capsule. Literally just a couple of trucks and a crane. Really easy, and then you ship the capsule back to Florida. Much simpler. Much simpler than going and getting a recovery vessel. But they're two sides of the same coin. I mean, you guys got to remember that Boeing is trying to do this as simple as possible. That's why that's part of the reason why they're landing on land, because a recovery ship is expensive. Anybody that owns a boat knows exactly what I'm talking about. Is that a Hummer? That's a Hummer. Nice.
First to
nope,
be on
they
site
moved
there
and the
once
encoder
Starliner
promptly
makes
took a
its
dump.
landing there in New Mexico.
The only boat that doesn't that is absolutely worth it. The only boat that's absolutely worth it is this one right here. The only boat that isn't expensive to operate and is just absolutely amazing because it makes you look like a freaking rock star is that one. Okay, complete with fake marina behind it. It's my boat. It's my boat. See? It's a nice boat. Look at that boat. We could have looked like rock stars. Instead, we look like a bunch of boats, Gene. Anyway, moving on.
Very coordinated and synchronized sort of dance that Starliner does to move away from the International Space Station and start
that never
its journey
goes away.
home. Flight Director Mike Lammers and his team are expecting Starliner's orbital maneuvering attitude control.
All right. Preparing to fast forward. Preparing to fast forward. Fast forwarding, sir. What am I looking at? When does this happen in the mission? Now. You're looking at now, chat. Anything that you see now is happening now. Then you missed it just now. Soon. Soon. Is it coming west to east or east to west in White Sands? Okay, Jam, let's dust off the cobwebs. The ISS is 51.6 degrees inclined. 51 degree inclination indicates a prograde orbit, so we'd be going west to east, right? But 51 degrees inclined means you're not following the equator by any means, right? She's coming in from the southwest, going northeast. Actually, I have the approach trajectory here mapped out if you guys want to be able to see it. You can see Tidris, T046 west, T275 west right there. These denote longitudes, I think. Actually, no, that wouldn't be longitudes because west, 275 west, that's in the eastern hemisphere. It's coming in hot. Actually, yeah, see this orbit right here, Jim? The 1, that's where it's coming in. I have the visualization for it if you want to see it. I have the combination. There you go. So 17, 36, 37, 38, 39, 40, 41, 42, 43. We should have a touchdown here at 17:49. That's the plan here. So If you're in San Diego, you might be able to see it. If you're in Tucson, you absolutely can see this. Just look southeast. You'll definitely see it. It'll look like a candle going across the sky with a trail behind it. It'll look like a meteor. That's what it'll look like. Yeah, she's booking, Henry. This thing's hitting the atmosphere going 20,000 miles an hour. 20,000 miles an hour. So what's that in kph? It's about 32,000 kilometers an hour, somewhere in there. It's pretty fast. So touchdown is slated for 49 minutes from right now. 49 from right now, meaning that Starliner is going to be there in 36 minutes because it is the top of the hour.
Central Time, that's 4:49 there locally at White Sands. That is going to provide us one of what we hope will be several views of landing for you.
Kinetic energy increases. You're falling on a steeper trajectory.
On the ground, also
hits EI at about 20,000.
Is in a good configuration for the deorbit burn. Still 3.
If that thing veers off just a little bit in the red towards the end, they're flying right over you. Well, it's funny that you guys mentioned that. A lot of people think that capsules move on what's called a ballistic trajectory. Basically, no thrusters. It's dead stick and just go, right? That's not exactly true. Capsules are actually capsules do have cross-range capability. They can actually turn during re-entry. How do they do that? Well, how would you do that? Well, long story short, and this was something that was figured out during the Apollo program, if the capsule's center of gravity is just a little bit off of its center line, so see that red line? That's an imaginary line that goes through the long axis of the vehicle. If the center of mass is slightly offset up and down on that blue line relative to that red line, well, the capsule, when it's re-entering, if it rotates, if it turns or rolls in different directions, you're changing the angle of attack on the heat shield. They figured this out during the Apollo program because they needed to find a way to skip off of the atmosphere. But you also needed to be able to steer to come down in the ocean in a spot where, the Navy could come and pick you up. So they came up with the idea of making a capsule with an offset center of mass. And if you play Kerbal, you can do this. This is absolutely a thing that you can do. That way, because if you're coming in like this, you can't exactly pitch and you can't exactly yaw either because the capsule is short and stubby. There's no moment. There's no lever arm to be able to do something like that. But if you roll the capsule with an offset center of mass, you can basically change the angle of attack of the heat shield. And that can actually make it so you could steer the capsule in. Because if you turn the capsule 90 degrees to one side, it's going to try to fly sideways, right? And you'll generate more lift in one direction or the other. You can absolutely do this in KSP. That's totally doable. And that's what Starliner does. To be honest, that's what Dragon does too. When Dragon splashes down and it goes into the water, it's always tilted. It's always bobbing to the side. The Apollo capsule does the exact same thing, to the point where they had to put floats on the top of the Apollo capsule to prevent it from tipping over and going right side or upside down into the water. So every capsule uses an offset center of mass for what's called cross-range capability. So Starliner's onboard computers can actually roll the capsule, and they can use that to steer it and pinpoint its trajectory right into the middle of White Sands. They could get it down to couple meters, give or take. You can get that accurate with it. Now, that couple meter deviation depends on how windy it is at White Sands. But yeah, you can absolutely steer these suckers. No problem. And that's doable in Kerbal if people want to test it. Definitely a thing. The reason why I bring up Kerbal Space Program, 1, because Jeb's on board, obviously. 2, if you don't know me, I'm a big Kerbal player. I love that game. That's my main game. I play that the most. 60 seconds until our deorbit burn. All right, let's see. I'm going to shut up for a second. Only for a second, though. It's my job to talk as a streamer, okay? Don't judge me. Don't judge me. Shh. No. Don't come back. No, they're gone. Oh, well. Shut up, Ian. I mean, hi. Also, just for the people that are anal about this stuff, that's not my desktop. That's their desktop.
10 seconds to the deorbit burn.
Okay. 10 seconds. You'll see the thrusters firing here.
3, 2, 1.
Momac ignition. Oh, there they go.
The team here on the ground reporting that the orbital maneuvering and attitude control thrusters are firing, slowing Starliner down as the capsule begins its journey back to Earth. Again,
not all of them are
this
firing.
lasts for 58 seconds and slows Starliner down by 285 miles per hour.
Not all of them are firing. Starliner's RCS is correcting. But that was already known behavior. So you are a fan of Java. Oh, look, Java apps. That's not me! It's not me!
You can see here on this graphic those thruster firings being
so,
depicted.
There's your Delta V right there for the Kerbal players. That is how much velocity that you need to burn in all 3 different directions.
Left.
This is the heading and altitude of the vehicle. The vehicle is upside down relative to the horizon right now. So Rosie and Jeb are flying upside down. 9 meters a second left on the burn. 5, 2, flame out. Okay.
And confirmed engine cutoff here on the ground. Flight controllers here in the room are reporting a good deorbit burn. Starliner is on its way home.
Okay. For the people that want to know, for the Kerbal players, because Boeing is actually cool enough to actually tell us this, not that SpaceX isn't, but Boeing actually mentioned it. It was a 58-second burn there at 127.4 meters a second there. That is enough to take the perigee of Starliner's orbit and get it suborbital. So basically now, Starliner slowed down enough that the Earth's grav well is going to pull it back in. And then when it lands, Will Smith is going to show up and be like, welcome to Earth.
Starliner is going to be moving into the correct attitude for the service module separation next. For the deorbit burn, Starliner moved into an orientation that allowed its thrusters to fire against the direction of travel.
PMDG Starliner? That'd be pretty cool.
Now that that's done, it's adjusting so that its thrusters will be pushing it further along the direction of travel and helping the crew module move quickly away from the service module once the
planet's
service
name
module
out
is
of your
jettisoned.
mouth.
That jettison is going to happen in just a couple minutes now, or about a minute.
Well, he didn't slap the alien in the movie, Velinoff. He punched
5:08 p.m. Central Time.
Yeah. Well, we don't know if Jeb is on board the capsule still. I wonder if they kept him on the space station or they brought him back down. I don't know for sure. I don't think anybody's playing Kerbal, but I'm pretty sure that man is playing Galaga. Yeah, I see you. I see you playing Galaga. He is on board? Good, 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 good. Boeing tweeted that he's on board. Sweet. Sorry, Blue. Can't help you. We got to bring back Jeb.
We are coming up on that service module separation.
That's right, Jackal. He did say that. All right. So SM jettison is scheduled at
Starliner moving into the right attitude.
8 minutes past the hour here. Now, Starliner, in order to not ever have to worry about jettisoning into the service module, is going to yaw 90 degrees to the right here. It's going to yaw 90 degrees to the right and jettison the capsule laterally relative to its prograde velocity. In Kerbal terms, that means pointing towards the angry triangle and jettisoning the service module. You don't want to jettison the service module up. You don't want to jettison it down. You don't want to jettison it forward or back. You jettison left to right, so the service module goes away from you.
Right now, that's why the text on the screen went green, but we expect to have the service module separated by the time we get it back.
They should grant it. Maybe. Okay, so it should be coming up on service module jettison here at 8 minutes 46 on the after the hour here. So we should have had jettison. There we go.
And we have service module separation. During disposal, that service module will re-enter over the Pacific Ocean while the crew capsule continues on its path to New Mexico, where our Boeing and NASA teams are waiting to recover it. Starliner is now angling itself and its heat shield for re-entry.
There was just a little bit of a data blackout. It took a second. It took a second to catch up, but it looked like the thing started spinning out of control. I was like, no, Jeb!
3,000 degrees. To protect Starliner from those heat loads, the spacecraft has what's called an ablative heat shield, meaning the outer surface of that shield heats up to a gas, which then carries the heat away from the crew module through convection.
You have disabled SAS.
And
That's
at entry
right,
interface,
that's right.
the heat shield will
cog
handle those temperatures of about 3,000 degrees. And I've heard engineers refer to this as a game of threes because as I said, that the heat shield will handle the 3,000 degrees, but then it will convert that heat to about 300 degrees with only 3 inches of ablator. So if there were any crew on board during this time, even the hottest part of re-entry, the astronauts would really not feel anything above about room temperature inside the spacecraft.
Yep.
When Starliner returned home from our first orbital flight test, the crew capsule landed with 2 black stripes up the side of it, and that just indicates that the heat was ablated as intended, so we do expect to see the same thing on the crew module again today. Also, since that flight, we've added a cover to our NASA docking system to protect through that re-entry so that we can use it over and over again on our reusable capsule.
Give me 1 second here, fellas. I need to take this, and then we need to take this and do that. There we go. Now we're good. But, hey, we just gotta... Perfect. Perfect!
While there's a few minutes of quiet, we are going to talk
there
to
we go.
teammates
We're
who
good.
are out in the New Mexico desert. We've got an update from
Danny.
them coming now. Dan, Rosa?
Hey, thanks, Brandy. Rosa and I here, we're happy to get a connection as, again, we had to do a little bit of rearranging, but we're out here. We're ready. The team's very excited. We've been following along. We heard the deorbit burn happen, and we're real excited to see Starliner. It's going to be coming in over the mountains just over there. Pretty soon we're going to be seeing it on the horizon.
That's right, Dan. As you can see, the team behind us is getting ready. Our individuals who will be wearing the hazmat suits are putting those on. Our gold team will actually be wearing these on as they approach the crew module. They are going to do a visual safety assessment to make sure there's no potential hydrazine leaks. They'll be using special devices to do a quick reading, and then they will let the rest of the team know that it is safe to proceed. The team has been out here for a few days preparing, setting up equipment. They've done a couple of mission dress rehearsals, and we are definitely ready to go. Again, once the crew module has landed and all those parts have jettisoned and landed, we will move up to the 500-foot mark and then proceed to 120 feet and then move on to the crew module.
Yeah, and as Rosa says, so gold team's first one in. We said everybody's color-coded. We've got a silver team. They're responsible for picking up parachutes, any other items like the forward heat shield that jettisons off. We've also got a red team. They've got all of our fire rescue. They've got the access platform for Starliner. They're also going to be the hatch open.
Dan, did you just get eaten by a squid?
Folks who are also on hand here.
Dan?
You know what, Dan, something I
Rosa?
want to point out, we're in a very historical location. 1982.
Dan, hello?
In the same location here at White Sands
they're back.
Space Harbor, and you know what, Starliner can now be part of that rich history. As again, we're bringing the Starliner home after being at the ISS, and again, we're all very excited here. It's warm, but you know that's not bothering us at all. We're ready to recover Starliner.
I prefer this immensely to last time when it was about 19 degrees out here, so this is a lot more manageable. But so we're going to get into our cars very
minus
quickly.
19F is
and the
well
team's
below
gonna,
0 centigrade.
Again, we're going to hang out here.
Or
We're kind of
19F
at
is
the
well below
outside
0.
of a big
negative.
circle that's
into the
cleared
negatives in
here at White
Celsius.
Sands prior to...
Way into the negatives. Okay. Yep.
That was Dan
Welcome back.
Hewitt,
All right.
out in the New Mexico desert, giving us an update on the activities that the landing and recovery teams are going through to get ready for today's 5:49 p.m. Central Time or 4:49 p.m. Mountain Time landing. As you can see, a little bit of technical difficulties, but we do hope to hear more from them before the day is over.
Yeah, we will just hang with them a little bit, go in and out when we can. Just that signal can be difficult out there in the desert where there's not much around. So when we do have a healthy signal, we'll go out to them, and if we need to take a phone interview from them, we can do that as well. We have some options there.
The ISS is on GMT.
Also want to mention, you may have noticed they had on sunglasses. Besides the fact that it just
they're going to land at White Sands.
They are actually wearing those for safety today.
That's where Starliner comes down. Starliner has a bunch of airbags
out there.
Yeah,
It can actually do some damage to your
right on the
eyes, so
bed.
it's important that they have on sunglasses while they're out there.
It's desolate
and you
out
can
there.
see some more of our crew there setting up alongside the convoy and waiting to recover the spacecraft.
Yeah, see, it is a Humvee. Oh, wait. Here, we'll see if we can put it in GIF form.
While we continue to see some of the shots from the landing and recovery team out in the desert, I wanted to give you kind of a rundown of what to expect coming up between now and that 5:49 p.m. landing. We mentioned earlier that the next big milestone was going to be entry interface. That's when Starliner will begin to feel the effects of the atmosphere. That is still about 17 minutes away. Should happen around 5:33 p.m. And then the plasma should start to build up around 5:35 p.m. We'll be through it by 5:40 or so, and then after that, 5:44, just 5 minutes before landing, we'll see Starliner jettison its forward heat shield around that has been protecting the parachutes from the intense temperatures of re-entry. Then when Starliner is still about 30,000 feet above the ground, the spacecraft's parachute sequence will begin. 2 drogue parachutes will begin slowing Starliner down.
That one sucks.
And then they'll detach and make way for the main show, the 3 massive parachutes that will take Starliner all the way through landing. While they continue slowing Starliner down, when the spacecraft is just 3,000 feet off the ground, the base heat shield will jettison and expose Starliner's airbags. At touchdown, those airbags absorb the initial force of landing, cushioning the spacecraft for a soft, safe return to Earth. Starliner has been engineered to be a reusable spacecraft with a turnaround time from landing to launch of about 6 months, and this landing on land capability will help Boeing stay on that timeline.
And Brandy, besides that turnaround time, another major benefit of a ground landing is that our team has the ability to get crew out of Starliner within really 30 minutes of touchdown, and they can also get the cargo out of there within 2 hours. So from a science perspective, that means that we can get experiments from the space station down to researchers in record time.
I'm sure there are a lot of scientists who are standing by just waiting for that.
Absolutely. Again, of course, no crew on board today.
He's on
but you will see our crews doing a lot of things to prepare. It's great practice on this test flight to get us ready for crewed flight next.
Got another shot out there at White Sands. Do you have any tips for even back? Bring a heat shield. Bring a heat shield for when you go out there. You got to be careful not to skim the atmosphere too hard, or else you will you'll have a very bad day. When is it expected to land? About 30 minutes. Hired, you got something? Nah, that's not good enough. Yeah, no, that'll suck. We really don't have a good one. We'll find something. Okay. Yeah, look at that. Look at that, man. It's out in the middle of nowhere. I'm surprised they even can get a connection out there. Okay, so, you know what? Instead of trying to get that GIF, I'll get you guys updated on the timeline. We should have entry interface here at 33 past the hour. So, in about 14 minutes, Starliner will start it'll start hitting the atmosphere, and gases will start compressing up against that heat shield, and the compressing gases Remember, per the ideal gas law, if you want to go back to high school science class, when a gas compresses, it gets really, really hot. The gas on Starliner gets so freaking hot that it basically rips it in half. The compression forces get to be so high that the gas actually ionizes and turns to plasma. That plasma has a lot of energy, let's say. So
Starliner continuing to make its way back toward
it burns
Earth
off the heat
following,
shield.
Today's 5:05 p.m. Central Time.
That should be happening in about 13 minutes.
Going nice and smoothly so far. Starliner is currently about 201 miles above the Earth, moving
that will work, Thomas.
At about relative velocity of about 24 Machs, about 17,000 miles per hour still, but it's going to be slowing down quickly at this from here on out as we head towards the entry interface point. That's when Starliner will begin filling the Earth's atmosphere for the first time since its May 19th
that's what I just
launch.
said.
That's coming up still about 12 minutes away now.
Thomas, thank you for the quick edit.
Starliner will be bringing back with it about 600 pounds of cargo from the ISS, including 3 nitrogen-oxygen recharge systems, or also called NORS tanks, and hardware supporting tissue engineering research. These are those tanks they'll be bringing back for NASA, as well as many other things that we sent up in cargo, some commemorative items that will be headed back to historically black colleges and universities across the country. And ahead of the hatch closure, the astronauts on the ISS actually showed us the American flag that they're keeping up there. It's something we sent up on Starliner, and they will keep it there safely in a secure spot until astronauts return on Starliner's crewed flight and are able to retrieve it.
Cheers. It has a transparent background if you save it. Here, let's get rid of that one. Go here. Yeah, that alpha channel didn't pick up, dude. Whatever, we'll just go with that one. That one's fine. It'll work just fine.
Discovery, go at throttle up.
A little bit garbled. 42 from Umbroso, it was the answer. Yeah, Potster, me too. WB57 is over White Sands here. Once again, about 11 minutes here until entry interface.
Before Starliner does begin to fill the Earth's atmosphere. As we have a few minutes, though, we're going to give you a good look at what to expect in the next few minutes in this package.
We're receiving a package? Cool. Oh, nice, Python, so that's good. Amazon orbital. No, this isn't Amazon, it's Boeing.
Now it's time to safely bring our reusable spacecraft back home. At this point, Starliner is flying with its solar arrays pointing toward the sun, recharging the internal batteries and keeping its systems powered through the minutes before touchdown. Starliner's orbital maneuvering and attitude control thrusters fire for 57 seconds. This maneuver, called the deorbit burn, slows the spacecraft down from orbital velocities.
So we've already seen that. We're good, Thomas. Yeah, they gotta turn it. Next step is the entry interface. That's the next step in the flight here. EI is scheduled for 33 past the hour here. Yep, Motor Kid, it's a test flight. Pilot parachutes, pull the main chute out here. Feet. Yes. Yep. It's got a little carry handle. It's got a little carry handle.
That was a graphical depiction of what we hope to see live here in just the next few minutes.
This is
We're
the
about 22 minutes
WB-57
away from Starliner's landing today, and you're seeing here a view from NASA's WB-57 aircraft. They'll be hopefully providing us live views of Starliner's return to Earth. They took off from Ellington Airport here in Houston just before 3 p.m. Central to make their way to White Sands. They've attended many landings now and often get us some great videos, so we're hoping to get some good stuff there. We are still about 6 minutes away from entry interface, and Starliner is currently about 140 miles above the Earth and dropping steadily just as it's supposed to.
Nah, Forlorn, I don't even know what this thing is looking at.
That shot will be the very first time we will see Starliner as it makes its re-entry into Earth's atmosphere.
Of course it will hit.
And before we are able to take some of those live views from our crews there in White Sands, New Mexico. I can tell you some of the information we've been able to learn about the inside of the cabin right now is that the temperature is a nearly perfect 75 degrees. As I mentioned earlier, pretty much room temperature. So if we did have astronauts on board, that's what they would be feeling.
Couple miles away, Dent.
They would be able to adjust the temperature themselves, anywhere between 65 to 80 degrees Fahrenheit based on crew preference.
That's
and
like
whoever wins their choice of
what is that, like 18 to 25 C, something like that? After OFT-2, what is the next steps for Boeing with Starliner? Crew flight test would technically be the next step, Dave, but the first and foremost immediate thing would be to assess the data from this flight and make sure Starliner did everything that they wanted to do in terms of test objectives. It has to make, you have to make sure that it works, right?
We've still got about 5 minutes to go before we hit entry interface, and after that it'll be another 5 minutes
before we see that. The camera on this thing's
that
no joke, Hellfish, but I don't think that's the capsule.
That we talked
I don't think that's
about
it. I
earlier.
think it's looking at the ground.
Expecting that to happen around 5:40 and last about 5 minutes itself.
And after entry interface,
it might
will
be,
start
dude. I don't know. I
just a
can't
little
really
bit
tell.
quicker, and the closer we get to the ground, the more things will happen.
We have the longitude and latitude of the plane up there, and then we have the altimeter right there as well.
Everything is about a minute apart. It's a little hard to keep up with at that point, but it should be a good show.
Okay, we got our telemetry view here. Starliner's currently out over the Pacific Ocean right now, crossing the equator here momentarily on its final ascending node here as it's aiming for a landing at White Sands, New Mexico. You can see the trajectory is going southwest to northeast here because this line right here, relative to the equator, indicates an inclined orbit, which is where it came back from because the ISS is in a very similar orbit because Starliner came from the ISS.
Earlier,
I know. Great logic, right? But you can really see
a lot of
right
test
there,
objectives that have been met during this flight test over the last few days. Another one, the vision-based electro-optical sensor and tracking assembly. You may have heard it referred to as VESTA.
What's TIG?
And flight data files transferred from the Starliner to ISS.
Not 100%.
we really had the opportunity to retrieve data while still there on the ISS instead of having to wait for return, but this time
That's
with
a
images that were
WB-57
taken by our
Sun
Vesta
Temple.
system. And some of the flight controllers that I've talked to really say that the Vesta system is one of the most interesting parts for them of Starliner, just the way that it is able to be the eyes of Starliner and really see it as if we would see it with our own eyes approaching the International Space Station. It is able to see markings on the space station and the shape of the space station.
Well, I mean, you guys can say, oh, all this stuff look bad, but the crazy thing about this is these are the screens that are inside of the capsule. Honestly, this is what you'd be seeing on your multifunction display if you were sitting commander seat right here. Yeah, these are the screens that you would see. That's what makes this cool. I don't mind that this is just a view of the displays. See? PFD, Primary Flight Display Viewer. These are just the views that all the screens inside of the capsule are looking at. I don't care about I don't care if they show this view all day. This view is great because it's the actual view. This is just a viewer, like a team viewer of the capsule almost. That's the actual data from the capsule being streamed to us. I'll take that. That's fine with me. Yeah, no, we could do this. I'm cool with that. There's the ground track, like I said, 51 degrees inclined off the equator. Starliner's past the equator here. Should be getting to entry interface here in about 3 minutes. This is fine. We could do this all day. I love these views because they're the actual views. This is the actual data stream from the capsule. This is great. You can see the cross range is at 0 right now. If they rotate the capsule for an adjusted trajectory, you rotate the capsule, the cross range indicator will go up to the left and up to the right. That's how you can tell they're actually changing the angle of attack of the heat shield to be able to steer this thing in. Ideally, you don't need much cross range, but to dial it fine tune it, this should go left to right and the capsule should actually roll. How long till the fireball? 2 minutes. Oh, thank you very much, Hired. If you note, the capsule is slightly angled up here because of the heat shield. They want the heat shield to hit at an angle. You don't want to hit directly on the heat shield. You want to hit at a slight angle because that actually allows the capsule to be able to steer. Once again, if we do see some cross range working here, this bar will go to the left or go to the right.
To go now until entry interface.
And you should see a roll here. The capsule should look like it's rolling relative to the nav ball here. So 33:25. Okay, coming up on EI here. It lands in New Mexico, Jonas. It lands in the White Sands test range, so dry lake bed. So water but not water. Water but minus the water. The data should cut out for re-entry? It depends, dude. It depends on what frequency they're broadcasting at. We might be able to get it because they are using tree.
Starliner is now 400,000 feet above the planet and beginning to feel the effects of Earth's atmosphere for the first time since May 19th.
Okay.
Due to the compression and friction of the air,
there it goes.
It
rotated a little bit,
which creates the red-orange glow.
They got some cross range, so that should indicate a roll on the capsule.
Plasma buildup actually causes a momentary and expected communication drop with the vehicle as the plasma briefly gets in the way of satellite signals. That period of plasma buildup lasts about 5 minutes, and we should come out on the other side of it around 5:40
Jeff and Rosie look good.
And Starliner will enter Earth's atmosphere at 17 times the speed of sound, so that could actually create a sonic boom for any folks who are living in the area. It will then be slowed by parachutes to a speed you may experience, for example, while going down an elevator inside a skyscraper. If you can think of that feeling, that is what our astronauts would be feeling inside. The
Open loop external guidance right there.
Comfortable stop on landing.
Forward heat shield jettison, drogue deploy, main deploy.
And you can see in this
landing
view,
attitude, landing back deploy, landing, main shoot jettison.
An idea of what track it'll be taking as it comes into New Mexico.
So the white lines here is the ideal. That's what we want. As long as the green line traces the white line, we're good to go. So you have relative velocity versus latitude. You have altitude versus range, relative velocity versus range.
Or actually, probably just Mexico. Looks like it'll just miss Arizona, but it will be going over the Baja Peninsula and Mexico.
So if you're watching,
I love this. I'd prefer this over the cameras, Jake.
See Starliner come over.
Dead serious. You don't need to see where you're going with the spacecraft. I'd prefer the data. I think this is way cooler. I can use this to teach way more about spaceflight than just a picture of the capsule.
Hearing reports that the landing and recovery team is receiving data from Starliner at this point.
Got a good downlink.
We'll have a few.
I'll take both. Yeah,
things are still reasonably quiet, and then a lot is going to happen at once with the forward heat shield jets.
Adam, I'll take both.
Make way for
Ideally,
the parachutes to begin deploying.
Okay.
We're in the final stretch now, though, of the landing of Starliner's second orbital flight test, with landing now just 13 minutes away.
13 minutes out from the OFT-2 landing. Yeah, I'll take all views, but if I have to choose, I want this. Current latitude and longitude is here. The site is Site 3, White Sands Space Harbor. There's GMT, altitude above ground. And here, let me shut that off for a second. We got the altitude. Oh, radar altimeter is just clicked back on. Here, the WB-57 looks like we got a good image of it. I don't think they have the track yet. They're still looking at the ground. Can you explain what the relative velocity versus longitude is? I'd have to go look at it again, Brian. I love a Coke.
So there on your screen, you're taking a look at that shot from the WB-57. That's NASA's space plane that will give us a great shot.
76,000 meters on Starliner was the last reported thing here.
Starliner as it makes its re-entry.
Last reported telemetry downlink with a little bit of cross range tapped into it. So the capsule was rolled like 5 degrees to the right here. Actually, not that much. But if you notice, the numbers aren't updating here. None of the numbers are updating because they're in blackout.
12 minutes away from landing.
The plasma is disrupting all the downlinks.
Point of the flight where plasmas begin to build up around Starliner, that will last about 5 minutes. Should be out of it around 5:40. In the meantime, the flight control team had transferred to closed loop guidance initiation, letting Starliner have complete control.
Closed loop guidance is basically when Starliner's onboard accelerometers take the last known point of a connection and use that plus an accelerometer to basically figure out where it is. It uses acceleration, or in this case, deceleration, to plot its own trajectory, and the computer's just the computer's flying the whole thing. And once again, how that works is it basically takes the last known point where it had a connection, basically a reference point, and it uses that plus the deceleration to figure out where it is, so it knows where it isn't. True story. The missile knows where it is at all times. It knows this because it knows
shot
where
here
it isn't.
from ground trackers in New Mexico. This will be another one of the views we
This thing's
hope
gonna
will
come
show us
flying up over the
Starliner
mountains
as it comes
here.
in for its landing in about 10
That's
minutes
a bug.
now.
Like an IMU on an airplane. Literally the same thing, Aqua. Yep.
And this,
That's a shot of someone's pants.
Just a view of the desert, and this is where
Nice shoes.
the landing and recovery teams have been getting ready to deploy out to the landing site once the Starliner
Thanks,
does
Laser.
touch down.
Those pants are pretty cog. All right, cool. So, yep, you can see the green line is intermittent because they had a signal blackout. It had a connection for a second. The numbers started to update, but now we don't have anything. When the numbers start updating, that'll
And on Starliner's last flight,
indicate a
we landed
reestablished
at night
connection
in
here.
the darkness. So this will really be the first time we'll have daylight views of the spacecraft after it re-enters.
Should be about 2 more
under the
minutes of
canopy
communications
of its
blackout.
parachutes, so it'll be a real sight
The
for our
entry
teams
events are in
there
order.
and for folks across the country.
Closed loop guidance
our first
initiation
time
should have happened
really
during
to see
signal blackout.
Starliner
Bill. CLG
coming
in
down in
it.
broad
So
daylight.
CLG in it. It's weird. This is Kerbal. This is Kerbal 2. Portrillo. Yeah, we're getting a preview of Kerbal 2. Actually, this isn't Kerbal Space Program, man. I'll be honest with you. It's kind of
We also heard that
this
the
is
crew
Human
on board
Space
the International
Program.
Space Station is going to be
differences.
watching landing.
Human Space Program is part of that whole outside video game. I don't mess with that too much because that game's really difficult. It's a really hard game to play. I stick to Kerbal, man. I don't know. This is HSP. HSP is a lot more difficult than KSP. I'm just saying.
Hines, Jessica Watkins, and Samantha Cristoforetti.
Go touch some grass and rockets. Yeah, that whole outside game you play on permadeath, man. It's really, really difficult. HSP is too hardcore for EJ. These damn DLCs, man.
We're receiving data from the Starliner now that it's passed through that plasma buildup. Everything going well as it makes its way across this
we got number
track
updates
that you can see heading towards a landing in the
We got number updates. She's out of communications blackout. That's a good sign. We're getting telemetry. So
teams on the ground reporting good trajectory.
Relative velocity versus range. So relative velocity means it's relative to the ground. Excuse me. This is a shot from an airplane flying around at 30,000 feet.
And there are our very first shots of Starliner from the WD-57.
WB-57.
Starliner's still got about 8 minutes left in this flight and hasn't even begun deploying its heat shield yet.
FHS jettison is the next step in the
next few minutes. Still about 3 minutes away before the first parachutes begin to deploy, and of course before that we'll see the forward heat shield come off.
That's a spacecraft coming home, man. That's pretty cool.
Everything going well. Teams are on the ground.
That
good data
is really amazing.
And hopefully we'll get a better and better view as it gets closer.
Jeb, UHF comm check. So if you're wondering how they're doing this, the WB-57 has basically a gigantic next level point and PTZ camera on it.
And that shot there on the left side of your screen now from the ground tracker. So we have two views now of Starliner as it makes its final approach to its landing zone there in White Sands, New Mexico.
And the team here in Mission Control reporting that they've heard from the landing and recovery teams that they're also seeing the Starliner. They'll have, of course, the front row seats, but we'll try and piggyback on that with these views that we're getting.
So if you're wondering how they're imaging this, the front of the WB-57 has something like this. See that? It's got a gigantic next level point tilt and zoom camera attached to the front. That's what that shot is on the left. It's from the front of that plane. Anyway, I'll get you guys back up onto the big screen here. You're a telescope, Forlorn. Got him. So that one is from the ground. This one's from the plane. Looks like Starliner's made its way through most of the heating here. Next up is drogue deploy. Drogue deploy should be at 44 past here, so about 2 minutes. Forward heat shield jettison should be just before that, where Starliner basically jettisons the cover that's holding all the parachutes. How long does the plasma bit last, roughly? 5 minutes? Depends on how steep of a re-entry you're taking. Hey, Fractal, thanks for the 10 subs, man. Heck yeah. Thanks, dude. I think they said the forward heat shield's already gone. My mission profile tells me that the FHS jettison should be at 44 past the hour, which we're not exactly at yet, but maybe I heard it wrong. Okay, we got telemetry back from Starliner. It's 13,000 meters, or about 40,000 feet up.
Switching back to this graphic for just a moment as we wait for the forward heat shield deploy.
It was going about 400 or 500 miles an hour. There we go. We got a good image of it. You can see the whole capsule there.
We are starting to get a more clear view of Starliner now. We should be seeing the forward heat shield.
Stand by for FHS jettison here. Forward heat shield. It should be a ring that pops off the top here.
And the forward heat shield has now jettisoned. That heat shield protected the spacecraft through those thermal loads during re-entry. And drogues are out.
Drogues out.
Parachutes slowing Starliner's speed and drag.
FHS jettison, drogue deploy. All right, we're on our way.
Starliner down enough for the main chutes to deploy in less than a minute.
Main chute deployment is looking at 45:30 past the hour. So we're coming up on that, probably about 30 seconds. Yeah, Stegen.
Main parachute deploy just about 30 seconds away.
Okay, drogues are slowing him down. The drogues are basically designed to be deployed at a very high rate of speed to slow Starliner down basically enough to be able to deploy the main chutes. It slows it down to an acceptable speed for main chute deploy. If you tried to deploy the main chutes at high speed, the pressure inside of the parachute would rip it apart. So the drogue chutes are like pilot chutes to be able to slow you down. Because, yeah, once again, you try to deploy the main chutes, you're not going to have a good day. All right, we got an IR picture. Look at that. Oh, man, that's nice. That capsule is hot.
View here from the ground tracker.
Drogue chute deploy. There go the main chutes.
And mains are now
Pilots
out.
out.
We see 3 parachutes coming out here.
Okay, stand by for 3 inflating.
Starliner has another 8,000 feet toward the landing. Those 3 parachutes are starting to inflate now. You can see them right there on your screen.
Very nice.
And
That's
the main
correct,
parachute's reefing open right there. Continuous slowing Starliner down.
3 good main parachutes.
3 good
Looking
mains from Starliner Mission Control. 3 good jellyfish. Perfect. Now that carry handle should pop open to orient Starliner flat relative to the ground here in preparation for the airbag deploy.
Starliner will be drifting down for another 2.5 or so minutes before it makes its touchdown, but all going smoothly. And we didn't just hear the rotation handle was released. That will help level out the capsule before touchdown.
All right, capsule is level. There goes the
there
heat shield.
Big base heat shield right there in front of you. It just jettisoned. You can see it falling away from the spacecraft.
It's a little hot.
It will reveal the airbags that will cushion Starliner's landing.
Airbags have inflated.
And those airbags are now inflating. Starliner is 2 minutes, 40 seconds from landing. Actually closer to 2 minutes now. You could see those airbags right there on your screen, fully inflated, looking good.
Those will come in real handy when we have crew on board for the crew flight test of Starliner in a few months. Help ensure that the crew gets a nice, soft touchdown.
This is great, man.
And those bags are filled
I
with
can't get enough of
nitrogen
this.
as
I
they
don't care
guide
if anybody's in
Starliner
it.
safely back
It's
to the
still
desert
cool.
floor.
Nope, no need to explode at the ground like Soyuz does, Donald. Will just land on its airbags.
Flight controllers here in the room reporting good airbags.
Okay.
Everything going exactly how we want to hear it. We are just coming up on about 1 minute away from touchdown there in White Sands, New Mexico.
Exact touchdown time will vary a little bit depending on the winds at the landing site, but everything's going smoothly.
Touchdown is scheduled for 49
And I bet
past
the
the
teams
hour
there
here.
at the landing site are enjoying this view.
It's infrared airborne. All right, we're almost down. You muppet.
Continuing to see views from the ground trackers on site.
About another minute.
In New Mexico.
Oh, no, less than that.
Just seconds
you can
left.
see the mountains coming into frame there. We're getting very close to the ground. And touchdown, Starliner. We're touching down in the desert of New Mexico, marking the completion of Orbital Flight Test 2. Touchdown coming at 5:49 p.m.
Very
Central
nice.
Time, almost exactly 6
Very
days
nice.
into the mission. Just a beautiful touchdown in White Sands this evening.
Nice job.
Our landing recovery teams will now wait for clearance before making their way to the vehicle.
Okay, gotta get the sniffers out.
And we can hear some clapping and cheering in the other room.
Very nice. Jeb is back home, baby. That's pretty cool. All right, now we just got to basically review the data. And then, you know what's better than having one crew-capable spaceship? Having two. It's like my old man told me one time.
And we are going to go live to our team now.
Anything better than one crawfish dinner? It's 5 crawfish dinners.
And we have NASA's Dan Hewitt and Boeing's Rosa Banuelos. Guys, how does it look from the ground?
All right.
Thanks, Lauren. It's hard to describe the feeling that the team here is going through. Again, we just saw those beautiful red, white, and blue parachutes deploy. We were able to visually see the forward heat shield. The base heat shield also jettison and open those airbags, and obviously they filled with nitrogen. So we're on the move. We're in the blue team vehicle. Again, we're driving in parallel to the historical runway here for the Columbia shuttle landing. Again, where the first stop is going to be the 500-foot mark. We're driving slow here, about 25 miles along the white sand.
Those are suborbital. I'm talking about orbital spacecraft.
Once we get to that 500 mark, the first team will move.
Not to say that those aren't hard to do. We're talking about
120-foot mark will be the gold team, and then we'll do that.
Orbit.
They will do that first visual assessment.
Not uppy downy boys. Those are cool though. I like those too.
Approach the crew module. After that, we have the silver team who will groundly stabilize the vehicle. It will be Sante command to power down, and they will also recover the parachutes. They will also recover and save any frozen parts. And then after that team, we have our team that's again going to try to attempt to give you
looks okay, Finn. We'll go see in a second.
To the crew module, and then preceding that, we have the green team who will provide ground and cooling to the vehicle, which is really important to keep those crew tanks safe from overheating. And then we have the red team, who is mainly made out of the Boeing medical personnel. And then we have the hatch opening, and then any of the cargo removal. Again, we're driving slowly. We're heading to the
Ferg
and an upwind direction, and this is to keep the team safe.
The dang Ferg's out in front.
Hazards, as we approach, again, the crew module uses a hypergolic propellant that, when it does turn into vapor, it can be very toxic.
That is hey, nice shots.
Safety is the number one concern. And
we got us a convoy to the spacecraft, over.
So when the gold team does arrive, they will be monitoring that throughout the whole operation. Again, the first stop is the 500-foot mark, and again, if you hear the rush in my voice, it's definitely a sight to see. For all of the Boeing team here, it's definitely a proud moment.
And hey, I don't have a whole lot else to add. It was pretty surreal as Starliner just almost seemed to materialize in thin air directly above us. We were able to see it come down under both strokes, see those deploy, and see all 3 good mates. We were treated to what I believe was a sonic boom award. That may have been some of the pyro events, but that kind of announced Starliner's arrival to the desert here for us. And so as Rosa said, we're on our way.
Stop on the Columbia.
As we get closer, we're going to get closer also to a lot of our transmitting hardware, so we'll be able to bring you some views. Might even have an eye in the sky as the teams move in around Starliner. So we'll talk to you real soon as we get in closer. Great to have Starliner back on planet Earth. Can't wait to see it up close and get the teams. And it looks like it's coming right into view for us. So we are still about a kilometer or more.
I don't know, Forfa.
Continuing to close in.
A Jeb needs to be like in the Smithsonian or something. No, it needs to go to the moon. Put it on Artemis 1. Put Jeb on Artemis 1. He'll be a good test pilot.
Right ahead of us, we can visually see it, and it's definitely a great sight to see. So, Lauren, we'll toss it back to you, and we'll come back to you as soon as we can establish a speed again.
Somebody in chat mentioned the idea of giving it to Felipe.
That was Dan Hewitt and Rosa Banuelos from NASA and Boeing, respectively, giving us a report from the convoy currently making their way out to Starliner as we speak. You heard them say that they were able to hear the sonic booms as Starliner came in for its landing at 5:49 p.m. Central, and we are seeing some views from
I think that camera is on the rollout convoy.
Some of the same ones I think that gave us the views as it was coming down as well.
And here's a piece of information that I know a lot of people on our team will be really happy to hear. We are told that Starliner landed about 0.3 of a mile southeast of the landing site, which is basically a bullseye.
Perfect. 0.3 of a mile. That's about a...
You can see those airbags that we talked about
about
earlier
1,000
that
feet.
are
Intended
to give
about
crew
1,000
on board
feet,
when we
give or
have
take.
them a nice soft landing.
300 meters off, which is perfect. That's a bullseye considering you're coming back from space.
As planned, that's going to be one of the things the teams are checking on as they do arrive at the landing site. We've got, as you heard...
yeah, see, that camera's on the cars.
Dan and Rosa mentioning we've got a pretty big group of people who are making their way out there because it's a pretty big job to recover a spacecraft once it is touched down from space. And we're also hearing from here on the from here in Mission Control that the post-landing power down of Starliner is in work.
Yeah.
It's one of the key
scene
milestones and getting the Starliner ready for its recovery.
And our team just checked
nice,
the cabin
Ted,
temperature inside. It is 74 degrees right now.
I want to see the recovery.
Much more comfortable than our team out there in the desert.
This camera's on one of the recovery trucks that's driving out there.
And you may have noticed just a few seconds after Starliner made its touchdown, the main chutes fall away from the spacecraft, and that just keeps those chutes from catching any wind that could drag the capsule, which obviously makes things easier for the landing team as they begin to make their way toward the vehicle and start their procedures.
So one of the first thing that they're going to do is go sniff around the capsule for hydrazine with a detector. The reason why they're going to do that is because the type of propellants that stay liquid for the thrusters, the liquid fuel for the thrusters, and the oxidizer for the thrusters is a very weird chemical. The liquid fuel is monomethyl hydrazine, and the oxidizer is nitrogen tetroxide. You know, if you don't know what those mean, they're hypergolic. They're hypergolic propellants. Basically, when they touch each other, they explode. But part of the reason, they're actually really not good for you. You don't want to breathe it. It'll kill you. Yeah, you don't want to do that. So they're going to send out the sniffer to make sure there's no hydrazine leaks from the landing, right? Or NTO leaks from the landing. Now, if they're so bad, like why do we use them? Like they're bad for humans. Well, we use them because they stay liquids up in space. The chemical is stable up there for long periods of time. As opposed to the propellants that would be used on a first stage that could boil off or decay over time, etc., etc. The monomethyl hydrazine and nitrogen tetroxide are really good at staying liquids for really long periods of time. That's why most spacecraft flying use them nowadays.
And
but
of course, this is
still got to be careful because they're not good for you.
We plan to reuse it up to 10 times.
Yep. See how it's cooled off comparatively, Bill, to when it just came in during re-entry? It's already cool. That thing's fine. It's
we
just
place
the
a
sunlight.
great deal of emphasis on testing our systems on the ground and in space before our first crewed flight test, so our teams have learned a tremendous amount from this mission. We have also extensively tested our parachutes and airbags before this flight, so very happy to see them work nominally and as expected.
All right, the recovery convoy is moving out to the vehicle now. They're almost there. Jack Berman, I'm all right. Thanks for asking. Yeah, no problem. All right.
Starting to see some of the recovery teams arrive.
There we go. They gotta send out the sniffers here.
The very first vehicle that we will see on site is the command vehicle. They are at the front of the convoy, and where the recovery ops leader and recovery director, who are in charge of the entire operation, will wait to go in.
So EJ, ablating is essentially just let it burn off. The plasma heats up the heat shield potzer during re-entry, and it burns the heat shield off. The thing is that the heat shield, in order to get it to burn, it needs to be at a low temperature.
Is still going on, getting.
When the heat shield burns at a lower temperature, and it surrounds the spacecraft with a cool column of gas that keeps the spacecraft from melting. Basically, the heat shield burns cold, burns colder than the plasma. Cold enough, like, don't get me wrong, it still burns hot. It's burning. Most things that burn are generally kind of hot. But the idea is to get you a thermal medium between the capsule. So the heat shield's burning and it's giving off gas through ablation, and that gas envelops the capsule in a nice cool column of gas that prevents it, that basically provides a barrier from the plasma from heating up the capsule. That's the same exact idea as supersonic retropropulsion, which we saw happen today while this thing was undocking. When Falcon 9 comes back down, it uses the rocket engine to create the gas. Instead of a heat shield burning off, it burns propellants. And the propellants hold Falcon 9 or envelop it in a nice cool column of gas so it doesn't melt. Same idea, same thing. One's through ablation and the other one's through shooting copious amounts of fire at plasma. That's actually a thing. That's actually a thing that happened today. SpaceX shot a rocket engine at re-entry heat, at plasma, and it pushes it out of the way. That's what the ablative heat shield does. That gas that gets burned off from the heat shield pushes the plasma away. Supersonic retropropulsion. Stuff burns when hot. Noted. Yeah. It's pretty good.
Those hazmat suits are there to prevent exposure to hypergolic
But I'd have to think there's a more reusable way.
Hydrazine is used as a propellant.
Gotta start somewhere.
And if it turns into a
Does
vapor,
that work in
it can be
KSP
very
as well?
toxic.
Sure.
So they use special sensors to sniff for it. And then they're able to notify the rest of the convoy when it's safe.
You can do it in KSP, but it's not the exact same idea. But firing the rocket engine generally does cool it off in KSP.
That team will also check the wind to make sure that the entire landing and recovery team is staged uprange.
But that's more because you're slowing
The
down.
wind is blowing, just for an added.
Not necessarily
set of
SSRP, but
protection.
you can do it. You can fake it in KSP. It'll work. Paco, 55 months. Thank you. All right, they got to get the sniffing crews out. Once the sniffing crews give the all clear, then we should get the little Starliner trailer. They have a little trailer that they roll up, and it has a little staircase
We
on
also
it.
are starting to get some photos from the members of the recovery team. We've got one here to show from you from Bill Ingalls, NASA photographer, as Starliner was making its way down for that 5:49 p.m. Central Time.
I like
again as one of the
I like
photos
those heat
just
shields.
coming in from the recovery team. That's a good indication that they are getting set up and starting to get a good connection back to us. Hopefully, we'll get a few more updates from them as we go on through the recovery process.
And just a beautiful sight there to see those three
Red, white, and
blue
Love to see
parachutes
it.
fully open.
Oh, what was that?
It gives you a patriotic feeling to
Oh,
see that.
dude, that was a
there
drone.
And to think about really.
That was a drone to the recovery
fact
site.
that
Give me the
we
drone
now
footage.
have,
Come on.
A successful mission and just kind of, think about what this means for
I'll
our
tap
country.
back.
Absolutely.
They're clapping. So I'm clapping.
Maybe able to hear some clapping
know what
there
I'm
in the
clapping
room and
for.
mission control.
Bomb pop shoots.
Seems
Hell
to be
yeah.
feeling good about their
6-day
mission
dude.
they've been supporting, getting
Yes.
Starliner up to the International Space Station and then safely
I love how
back
they
with
just
its
kept the
landing
drone
in New
UI.
Mexico. Seeing
I
here a
don't care, it's
video,
fine.
a shot from a
It's
drone
fine,
on
who
site
cares?
with the recovery team.
Oh, that's so cool.
Much clearer than our other view. Very nice.
Yeah, we're getting now some close-up views of Starliner there on the ground.
And back with the recovery team now. Again, they are getting
There's the staircase trailer on the right with the flag.
We'll be taking control of the vehicle now.
Oh, this is cool. I really like this.
Like
This
we have
is
a
really
flight
neat.
director here in control. There's a recovery director on site there who will be leading operations.
There's a Humvee out there. They have an H2, I think, from what I could tell there, Bill. Yeah, the H2 is the camera vehicle. Moving screws up the encoder. Oh, look at that. We got Fords, we got Chevys, and we got Dodge. I'm okay with that. Is that a decontent that they just sent up there? I think so. No Rivian, SMH my head. Yeah, sorry, we use trucks that actually work here, Ian. Roasted. Nah, I like Rivian. Rivian's cool.
And as I mentioned earlier, when
Are bird
Starliner
strikes to heat
returned
shields
from
a
its first
danger?
flight,
No.
we did notice two black stripes
we
up
good.
the sides of the spacecraft. We've seen those as well on this time, and that just indicates that the heat was ablated as intended. We expected to see that. It's a good thing to see that. It means that ablative
It's bad
heat
for the
shield
bird,
did
yeah.
its job.
Yeah, if that's what you're asking.
Ablative heat shields wear away with the heat and take the heat with them rather than letting it transfer to the inside of the crew module where the crew needs to be protected.
You're reaching, Forlorn. You're
And
reaching.
you can
So
start
are
to
you,
see
Donald.
there some of the gold team making its way out of the vehicle.
Take
and
15.
will soon be coming over to the spacecraft to begin its checks.
Supersonic
and we're
natural
go live
selection.
now back to NASA's Dan Hewitt and Boeing's Rosa Benuelos, who are live on the scene.
No Florida Man Navy. Well, yeah, of course there's no Florida Man Navy. They're not in Florida. They're in New Mexico.
Hewitt coming to you guys live now. So we're just about 500
Use
feet
your brain
away,
next time.
And the convoy has paused. And as we talked about, so the gold team is in there right now. They do a sweep up close.
Forlorn, what are
around the
rocks good
capsule
for?
looking for
Rocks
any
are good for
hydrazine
being
fuel.
useless and sitting there and doing
Hydrazine,
nothing,
it's a
just like
hypergolic
Chevys. That's why
fuel.
Chevys are built like a rock.
Starliner capsule uses it for its reaction control thrusters, which are only used during that re-entry period to control yaw pitch roll. They go in, make sure there aren't any leaks, any fumes, anything like that, before the rest of the team start to make their way.
That's right, Dan. As you can see,
Pioneers
following your
used to
camera
ride
views,
those
they're
babies
dressed
for
in
miles.
hazmat suits, and they're going to do an initial sweep. They're doing that right now as they're walking around the
Is that a
module.
boulder?
You can see those airbags
It's
are
a rock.
inflated,
Yeah, these guys are
and
the
they're going to take
sniffers.
their time to do that. Obviously, it is. We want to keep the team safe, and once they do that, they're going to give the next team that go to proceed,
Oh, that's
which is going to
cool,
be the
man.
silver team. And
Stop
again, they're
moving
gonna
the
ground
drone.
stabilize the vehicle and make
Guy?
it safe
Damn.
for the crew to actually touch the crew module as well.
wish I was built like a rock,
So we're
but
going
I'm
to
built
continue
like
to
Danny
see this
DeVito.
live. As you can see, the parachutes are to our direction,
Hands
to the
up,
left
capsule.
here, and the team that will
Whitney!
be safing and recovering those parachutes will be
Oh, nice
the silver
shot.
team as well. So when it's their turn to come in, you'll see them working off to the side, gathering those parachutes, doing their assessment as well.
Oh, this
And
is
they're gonna be
cool,
collecting
man.
up that
This is
base
really cool. This is one of the cooler
actually
parts.
Landed, probably only about 200 feet
Math
off
Rose.
to our right, so that's
This
super
is the
close.
French raid.
If we were able to get some views of that on
So what you're
OFT-1,
telling me is
and
no
we'll
one's
do our
expecting
best
the
to get you
French
some views of that
Inquisition?
as well. So after Silver Team's able to do that,
Ah,
we're going to
bleu.
start to see a lot of the convoy moving
Mon
in.
Dieu.
We've got a green team, which I don't know if
What's
we've
going
touched
on, guys?
yet.
How are you?
But they're bringing a lot of equipment with them. They're going to put up an environmental enclosure.
Whitney, thank you for the raid.
It kind of looks
Much
like a bounce
appreciated.
house. It's just to go around Starliner, helps to provide it some extra cooling. And also just protect it from the
Starliner is alive, and so is Jeb.
The vehicle's going to be reused.
So is
Any
Jeb.
Steps we can take to just kind of isolate it from the environment will help in that refurbishment. And they're also going to be setting up an HVAC system, providing some active cooling to the capsule as once it's powered down.
When would crew
it's
get
not
out?
using
Well,
any
you
of
need
that
your
active
special,
cooling on board.
And I did just get
trailer
word that
stairs.
we are going to have the silver team move in to cut
Trailer
the riser,
stairs.
and that
Oh,
is
you'll see.
the
You'll see.
connection that
You'll
is
see,
still
Bill.
connected to the
It's cool.
parachute. So
You'll
will
like
probably
it.
see
Trust
that in
me.
your shot. It's practically like
Okay,
a
there's
string.
guys
They'll
with
be
escape
going in there
suits.
and doing that procedure as part of their recovering operations.
Because they're sniffing for hydrazine, like I said, guys, that stuff's bad for you. So these guys are in full, they're called escape suits, not space suits. They're basically designed to make sure that they don't come into contact with the hydrazine or the NTO, the fuels, if there is any. But it looks like everything is okay.
A map, a mobile access platform. It will look very similar to just a big yellow platform with some stairs.
Yes,
That's
yes,
what's
the
gonna
mobile
give
app,
them
mobile
direct
access
to
platform.
that
Literally
hatch.
a
Your
U-Haul
hatch lead
trailer
is
with
also
stairs on
the
it.
red team.
Yeah,
They're
that's why I
also
said you'll
going
like
to
it.
be driving up the medical truck. Obviously, we don't have any crew on board today, but we're going through all of the motions of this. To practice just for when we are flying crew, and so they'll back that.
Not that
truck
Jeb,
up,
Ian.
And that's what we're going to be using once we
Different
have crew
Jeb,
on
different
board.
Jeb.
That's going to be kind of their first steps
Does
out
it
of the
say
capsule
Bluth on
into
it?
there.
Maybe.
Also, the hazmat has been complete. Everything is nominal. Again, this team did that first initial assessment, and they're going to continue to monitor for any potential hypergolic leaks. Again,
What capsule is better, Ian? Dragon, Starliner? No. Jeb is the best capsule.
wearing sunglasses. It's really bright out here, and so we're protecting our eyes. We're keeping safe, drinking
medical.
lots of water
Nice.
as we again welcome Starliner home from its orbital flight test 2.
Oh wow, dude! Look dude! Look at the heat shield. That thing landed super close to the runway, huh? Wow, that's really freaking close. I didn't even notice that. Look at the heat shield. The heat shield landed dead
We're
center.
go ahead and toss it on back as they're completing that assessment. We're going to get back into our cars and be able to move in a little bit closer, and then we'll rejoin you very shortly.
Look at the heat shield. Oh, she's fine.
And you may have noticed there, as the drone flies over the boost heat shield,
That heat shield's
dropped
dead
away,
center.
not too far from where Starliner landed. You may have heard a lot of clapping in the background here. Boeing and NASA leadership have made their way into mission control, and there's quite a celebration going on in here.
Flight Director Mike Lammers congratulating his team on a successful flight and touchdown. Again, that came at 5:49 p.m. Central Time.
These hydrazine guys need to give the all clear. Looks like they did, though. Yep. All right. Here we go.
And you can see our team in the hazmat suits there as part of the gold team.
What time is it?
Again,
It's
they are making their way
time.
up to do the sniff test. A lot of times when you hear sniff test, you imagine they will actually be sniffing with their own nose, but that is not the case. There is a reason they are in hazmat suits. They have a device that actually performs that sniff test for them.
I'd take a big whiff. It'd be the last thing you ever do. You can see the rigging from the parachutes right there.
As Dan Hewitt mentioned, the ground team is now off and moving in closer with that sniff test coming through all clear.
Yeah. If you look closely, these guys with their proton packs are sniffing for paranormal activity. If they detect some paranormal activity, they're going to have to roll the traps out and use the proton packs. What?
So before anyone can touch the vehicle, they will ground and discharge it.
Saw a cockroach up on 12. That must be some cockroach. Bite your head off, man.
Just a great shot there. As
Light
I
is
mentioned
green.
earlier,
Trap is
during
green.
our last flight, we landed during the dark and in the middle of the night. And so this is the first time that we've been able to see
Who are
just
they
such
going to
clear
call?
pictures of
Capsule
Starliner's
busters.
crew capsule there in the desert of White Sands.
Are you troubled by
can see
re-entries
that
in the
black
middle of the
stripe I
night?
mentioned, which is just kind of
You
a badge of honor.
experience orbital perturbations on
lets
your
us
space
know
station.
that the engineering done to
In his
protect
universe?
that
No, no,
spacecraft
wrong
during
universe,
the
wrong
hottest
universe,
part of its
I think.
re-entry did its job.
Yeah, she's a little toasty, but the Nomex did just fine. Starliner actually uses a shuttle-derived thermal protection system,
Another
which is
photo
pretty
coming
cool. It's
in
got the
from
tiles
that,
on it.
I guess the blue team, which is the communications team that's on
Someone
site.
says you're
This
a
one
Kerbal,
again
you
from
say
Bill
yes!
Ingalls, a NASA photographer who was part of that the landing convoy, getting looks like a photo just seconds before touchdown there.
And a beautiful sight just to see Starliner there with the backdrop of the mountains.
Yeah, Nova, she good.
I have a feeling this is a picture that a lot of people will have up on their wall.
She good. That's correct, Synerd, yep.
We will stay with our team out on at the landing site until
That's pretty good,
the
man.
hatch is opened. That will be done by the red team, so that's the team we'll pay most attention to.
Yep, they're still sniffing,
They're
though.
mostly made up of fire rescue, Boeing's fire rescue. The mobile access platform will get backed up to the hatch on the crew module, and that's able
All right,
to
Sun
give the
Temple,
team
see you, buddy.
access there. If we did have astronauts on board today, this is the part when they
Probably
will
get
start
it
to
done in a couple
exit
of
and be
months,
taken
then, right?
directly into the medical truck for any post-landing medical checkups. But we still
Speaking of
have a few
astronauts who
teams
could be on board, I think Butch Wilmore is there with the team. He's one of the first up to fly on board Starliner,
I want that
getting a good
wagon.
look at
See that
what he
wagon?
could expect from a
Look at that
Starliner
wagon. That
touchdown.
thing looks cool. It looks like a moon rover. Look at the wagon!
Butch
Bro, I
telling
want a
us that
wagon
he
like
was
that.
very jealous of Rosie getting to ride in the commander's
Yeah,
seat
see that
today,
beach ride? See,
and,
Loopy? Yeah, dude, you get it.
I'm sure he will
thing's
have
cool, man.
some
I
more
want
words
one.
for her once he
Look at the
gets
freaking space
to
wagon.
get up close there to the spacecraft.
Oh, the drone died. Hello?
Definitely seeing some of those teams begin moving in closer now.
Most expensive radio flyer ever.
You may be able to tell some of the flags that are on each of those trucks that differentiate
yes.
which team we're
Starliner
talking about.
truck.
As we've mentioned
tell
many
it's a
times,
Starliner
they
truck
are
because of the way it is.
designated by color. And so that'll give you a good indication of which team's turn it is to come in and do
Gorilla
their part
carts.
to
Oh, those things
get
are
the
cool. I want
spacecraft
one.
ready for more folks to come in and eventually open that hatch.
Hell yeah. If hydrazine was present, what would be the procedure for decontaminating it? Well, you'd have to figure out where the leak comes from, Ted. It really depends on what's leaking hydrazine and what isn't. Oh, yes, really well. Hey, don't jinx it yet. So, if you
It's only been 26 minutes now since Starliner touchdown, so you can
They
get
stole
an
my
idea
lines.
of how quickly those that landing and recovery team can move in for a land recovery. Already
Mega
through that
blocks.
hydrazine sniff test that we've been talking about, and getting ready to move on to the Silver team's grounding electrical test.
Tire.
Team here in the room has
Oh, the
already
Starliner
handed
truck is a
control over
deuce.
to the recovery
Oh,
director
that's
who is on
awesome.
site, and now they've got responsibility.
Come on,
for
rotate the camera
Starliner.
again. Come on, you getting this camera, guy? Rotate it one more time. One more time. Whoop, no, wrong direction. No. One.
Spacecraft landed just
Come on.
0.3 of a
After the
mile
tire.
southeast
Do it.
of the landing
Do
site
it.
today,
Let me see
which
the
they
deuce.
consider pretty much a bullseye, exactly where we want to put her down.
That's a tire.
In the desert, of course, being so important that we're able to show that our autonomous
That is also a tire.
spacecraft
Nope.
can perform as we plan.
You're tired of this picture? I'm gonna let this one slide because it's white sands. I'm gonna let it slide, Pythos. This is a tire. Go to the. I want to see the Starliner truck. Dang it! I don't really care. It's just also that's a tire. Rim shot. Ba-doom. Oh! Almost. Yeah. American flag. I like it. No. Yeah. Yes. I like the flag. That's good. Come on. Go that way. Go Webb. Hey, what's up, Dave? How you doing? When you're playing split screen on N64, but you're looking at the wrong screen. Nice. Come on. Yeah, see, Corza, you know. What you got out for me there? What you got for me out there, Joey Ray? Okay. So, once again, the capsule did come down about a half hour ago. Crews are just making sure that it's not leaking any hazardous chemicals or anything, and then once they give the all clear, that's when they'll start opening the hatch and doing all the cool stuff. In the meantime, we're looking at a view of the flag, which is nice, with a CB radio antenna in the front. Yeah, it's with some mountains in the background. If you're wondering where they are, the capsule did touch down at White Sands Space Harbor, so that's out in New Mexico, out in the middle of nowhere in New Mexico. Capsule did pretty damn good landing at 49 past the hour. Everything looked real good. Now crews are just moving to recover. Not taping cardboard on the split screen. Rookies. Give us the deuce. They had a Starliner deuce and a half, man. Those trucks are cool. Wanted to see it, but I mean the flag's good too. I like the flag. They painted the deuce since last time. Let me see. Oh yeah. Interesting. It's a Zerglin, Lester. Smaller type of Zerg. But I don't know. Oh, shoot. I love you, Sarge. Good reference. Good reference. Risky click of the day, Scurvy. So the hydrazine guys are still kind of looking around, but there's people without the scape suits up next to the capsule. At least I think there is. Yep, Jeb's inside of the capsule there, guys, so that's pretty cool. Loopy, did Felipe say something? Holy crap. No words to... Felipe says no words to describe the feeling, but I need to share it with the Kerbal dev team and community. This is just insane. Oh, man. I'm happy Felipe's into it, man. That's really cool. The Starliner team should give that Kerbal to him. So guys, if you want to see that tweet here real quick, Felipe.
And we have confirmation now that the Silver team has been able to ground the vehicle.
He's the guy that invented
and ground
KSP.
Cooling has now been established.
He's the guy that invented KSP, talking about Starliner. This Starliner had a Jeb plushie in it, and that Jeb plushie flew into space. That Kerbal has gone to space and is inside of that capsule. If you haven't seen it, so. That's, oh man, that's pretty cool. That's pretty damn special. Yeah, Bon, yeah, I'm with you.
Our NASA and Boeing colleagues are still in a holding pattern right now as they wait to get the go-ahead that it is safe to move closer to the spacecraft. And once they do that and we establish a shot with them, we will go back out to them live to get an update on what they can see from their perspective.
I did say something lately. There we go. All right. So they should be setting up shop here in a second. We should get that drone cam back. I'm sure the KSP dev team is going nuts. It's pretty dang cool. Pretty dang cool. Looks like they're grounding out the capsule. Yeah, it's hard to tell what's going on, guys. I'm trying to kind of give you guys an update when I can, but that really just going off what the NASA footage, what the NASA people are saying, it's really, really hard to say. It looks like there's people near the capsule, which means that the scape guys are done sniffing for hydrazine. But then again, you see guys with the guys with the suits still up there. They're still up there, like they're the ones that are closest to the capsule. But then again, you see people without the scape suits on walking around as well. So it's really hard to say. Flag is still waving. We can assume the tire is still inflated. Yeah. You can kind of see the deuce in the top right cam. Oh yeah, just a little bit of it. I replied to Felipe in that Twitter thread. I was like, I don't know what to do with my hands. I don't know what to do with my hands. Oh, boy. Truck. There's the EMS. The EMS is moving away, so that's good. No, Handy's not. Felipe works for Float Point Interactive. They make Balsa. Balsa is a game where you build model planes. It's really cool and fly them around. It's a really good game. Did I miss the re-entry? Yeah, Ewok came down, but it was good. Came down real good. Man, look at how much hotter the front of the truck is on that IR strobe because of the motor. The front of the truck is toasty because of the engine. See that? That's really cool to see it on an IR strobe. Looks like they got the loading truck up behind him there. Oh, those pictures are pretty good, Thomas. I like those. Loopy, what did you link? All right. Yeah, no. Yeah, T-Man. Yeah, that's pretty good. Little surprise. Yeah. They're moving it around. Okay, we don't have much commentary here from the commentators, ironically, but yeah, they did land. I'm just waiting for them to get the welcome wagon out here. I do believe that good manners dictate that we should send out the welcome wagon. Oh, something's moving. Claps. All right, time to send people up on it. Rogue, let's review the data and make sure that the thing behaved exactly how we thought it did. It looks like everything is good, guys. This Starliner looks pretty much exactly like the OFT-1 capsule that came back down. It looks pretty much the same, minus the upgrades here and there. But it looks good. I don't think that EDL is even that much of a problem. Something interesting to note, though, on this IR camera. Look at how hot the capsule is compared to everything around it. Even the people. Right? Well, these guys have scape suits on, so it's hard to see that. But people that don't have the scape suits on are bright, right? Look at the capsule. Capsule's still a little toasty. It's mostly because of the sun, because it gets hot out there. But still carrying some residual heat. Imagine Jeb gets out of it. Yeah, maybe. Gold team is the scape suits for hydrazine. Silver team is the parachute recovery and power down. Green team managing the cooling loops. Red team is the medical teams. Cool. Is this FLIR? This is not FLIR. That's infrared, Clayton. Infrared. Infrared's in black and white. FLIR has color. So we don't... I'm not, like, muted, right? That's just... Okay. Yep. No, not muted. That's the order from what they mentioned earlier. Yep. They have gold, silver, blue, green, and red. Blue is video coverage too, by the way. Now, I must be confusing it with the thermal camera, fellas. But yeah. That's not a thermal, that's infrared. But then again, infrared tells... I thought you were talking about like the multicolored camera. A lot of camera experts in chat. Well, yeah, that's good to know, fellas. What's the giant joystick on the bottom right? That's a CB radio antenna, Ewok, and it's in front of the flag waving. The flag is on the welcome wagon, I call it. That's not what it's called. That's the see the railings, the yellow railings on the right? when they go to open the hatch, they'll back that trailer up with the flag on it up against Starliner, and then they can get in at the hatch and open it up. It's a little like raised gantry that's on a trailer. It's actually really cool. Oh, it looks like a giant joystick. Well, the CB radio antennas are on. It's on a spring, so it's designed to just move around with the truck. Oh, nice, Pythos. Sure we're supposed to know that? How long will the event take place? Otherwise, it's already very late. Well, we don't have really any audio update, and nobody's near the capsule. So I'm not 100% sure what's going on here. Oh.
And you may have noticed there that our teams have backed away from the spacecraft. They are doing so after detecting a very low amount of hydrazine.
Yep.
We're just giving it time to burn off. And then our teams will move back in when it's safe and begin those procedures. Again, Starliner landed at 5:49 Central, 4:49 Mountain Time today. Just about 41 minutes ago in the deserts of White Sands, New Mexico. We have several teams that will be moving in shortly to go through a list
Either that or
of
use the walkie-talkie,
procedures.
I don't know.
Starting with the gold team.
Wait a minute. Wait a minute. Wait a minute.
Team
That's a UCF logo. Guy has a UCF logo on his shirt. Hell yeah. UCF? Go Knights!
Hydrazine is used as a propellant.
That guy has a UCF logo.
It can be
Hell
very
yeah.
toxic, so
are you Golden Knight?
use
It's my
special
adopted
sensors
alumni,
to sniff
guys.
for it, and then they will know.
It's my adopted alumni because I went to the school down the street. And that school does not have a sports team. Yeah.
Uprange from those winds.
No, the other school down the street. Down University Boulevard. At the other end of University Boulevard.
Our team is a safe distance away from the spacecraft right now, and everyone that is near the spacecraft is wearing hazmat suits. That, of course, was the gold team that we did see wearing those hazmat suits.
Really, Potso?
We have a live look from the drone again up in the right-hand corner of your screen.
Screw for the chronically insane? Well, Baker, I mean, look at me.
Side.
Look at me. I'm a Twitch streamer. Of
And
course
you may
I'm
see
crazy.
an ambulance down there on the bottom of your screen. That is a normal part of the convoy. When we do have astronauts on board, they will be getting
Festival 07
medical
game day.
checkups
Dude, I'm
as soon
08
as they
computer
land.
animation. Holy crap, dude. We were at the school at the same time.
Is going into
That's cool,
this
man.
time,
I didn't
even though we don't have astronauts on board, there are a lot of things that our team is running through as if we do, so that they get some extra practice in before that crewed flight test.
That's where I went to school, man. That's why I know Florida so well, dude. I live there. It's the only other place I've ever lived aside from Massachusetts. Oh, a parachute ringing over there? What college did you go to? Full Sail. Full Sail. I'm a Full Sail grad.
After the sniff test is performed,
But UCF,
the silver
because
team will move in to ground.
Full Sail is not a... Full Sail doesn't have a sports team. They don't have a sports team. So UCF is that's my adopted alumni. So Golden Knights, baby. That's where I'm at. That's my college teams. All right. So I'd know that UCF logo anywhere. I also went to UCF a couple of times. I don't really remember what we did when we were there. If you're picking up what I'm laying down.
In here at Mission Control, where a lot of the NASA and Boeing team members and leadership have moved their way in to congratulate the flight controllers.
Yeah, that's right,
on the
Hell
mission.
Hydra, yep.
Flight Director
Bump to the
Matt
head, yes,
Lambers, you can see there, right in the bottom left-hand corner of the screen here, talking to Steve Stitch, the Commercial Crew Program Manager.
That's Steve Stitch right here.
Lammers has officially handed over control of the vehicle, so his part today is done. He's now enjoying handshakes around the room. The team has really
This is a
been
shot
happy
down
to
University
see
Boulevard.
Starliner safely home, all feeling good about the work they've done over the course of this mission.
Probably Novus, yeah.
Steve Stitch was asked the other day how he would describe the Starliner spacecraft, and he described it as patient, which I think we are all experiencing right now. We're practicing our patience as we wait for the crews to be able to safely move back toward the spacecraft and finish out some of those closing procedures before we see the red team open the hatch.
Yep. Yeah, they had a little bit of a hydrazine leak. So now I had a couple of people in chat, Donald, ask me, you know, what do you do in the event of a hydrazine leak? Well, hydrazine decays in the atmosphere, so they said they were letting it burn off. So
once our team is back on site and they do perform that sniff test once again to make sure that there's been time for
this does happen,
the gas
guys.
to burn off from
capsules
sometimes
have a little bit of a leak.
The green team will move.
Happened with Dragon.
And they will
happened
hook up
on DM2
the HVAC trailers
with
to the
people
crew
inside
module
the capsule
to get that ground.
Happened on Apollo 11. True story.
But their first job is to put an environmental enclosure on the crew module.
Didn't need to worry about it with the space shuttle.
Our team's talking about that earlier, that it kind of looks like a big inflatable or a big bounce house that goes up around the crew module there.
No, it usually doesn't leak inside the capsule.
They will wrap it around and get cool air into
That's cool, Clayton.
the module to make sure that the
Any
vehicle
chance to see
and
Jeb
its
today? Well, that's what I'm waiting for,
overheat
Zay.
there on the desert floor. Once again, we have a live view from our drone. Looking over the landing site, you can see the full convoy. You can see the parachutes that were cut away as soon as we landed.
You leave your flying
after a
brick
few
out
seconds.
of this?
And there, in the middle of that screen, you can see the base
Low Earth
shield
orbit access
that,
vehicle. Shuttle takes the cake.
was jettisoned and fell to the desert ground,
just mad.
not too far away from the spacecraft.
All right, once we see people walking back towards Starliner here, we should give the okay here. Once again, the gold teams, the guys with the gold scape suits, yay for drones. The guys with the gold scape suits we're sniffing for the hydrazine. The reaction control system fuel that Starliner uses is great for on-orbit maneuvers, right? Because it can stay as liquid for long periods of time up in the vacuum. However, it's really bad for humans. So if you do have some kind of leak, you really have to make sure that people aren't near it. So what they're doing now is they're waiting a second for the hydrazine to go away, and then the gold team will go in and do another sniff test. Once the gold team confirms that everything is all clear, silver team will come in and ground the vehicle, which I think they already did. The blue team is for video coverage, green team is for environmental control systems on the vehicle, and the red team is for crew and hatch operations. So they'll roll the trailer in here in a moment. Starliner can be reused 10 times. Yep. 10 times on each one, and I think Boeing has made 3 of them, if I'm remembering right.
This being a flight test, our teams have really learned a tremendous amount of vital information about Starliner as we had our first rendezvous.
Well, they
with the
landed on a dry
International
lake,
Space
then,
Station,
fellas.
and then docked with the International
So we
Space
made
Station.
2 for actual missions.
Spent a few days up there with the astronauts who were able to move in and take some of the cargo out and repack some of that cargo for us.
It's a dry lake bed, so they landed on a lake
Starliner
minus the
undocked
water.
a little bit earlier today.
The more
and made
you
its
know.
way back home to the desert in White Sands.
What does the Platinum team do? I want to make a joke. No, Patty J. I don't know what the Platinum team does. The capsule had no problems with the OFT-1 mission, Donald, and it was a software thing. That has nothing to do with the hardware. The hardware's just fine. Okay, gold team's moving back in.
And you can see the gold team there moving back toward the spacecraft.
Hey,
to
I just
perform
said
another
that.
Sniff test with that device. You can see them wearing their protective hazmat suits.
So Boeing made the capsule, Zin, and they run like kind of a hybrid model with Boeing and NASA operations. It's kind of cool because Boeing opted to have NASA much more involved with Starliner's like operations, which is actually pretty neat. I think that's cool. SpaceX opted to be more SpaceX, you know, also with NASA, but it's almost like Boeing is working with NASA. Like it seems like they're working a lot more with NASA. This feels a lot more like shuttle missions ending and stuff than the SpaceX missions do. Not to mess with SpaceX. I think they're both great. You know, one of the capsules is kind of go with what you know, and the other one is pushing the envelope. That's what Dragon's all about, right? Those Uggs are just orange-colored boots. I don't know, dude. Racer, I don't know, man. These guys are sniffing for more hydrazine again. You see the RCS right there. It could have a leak. If there is a leak, they're trying to figure out and pinpoint it. They're trying to figure out exactly where it is, because pinpointing that leak could lead to some clues as to, you know, where it's coming from. I'm good, Racer. Everything's good, dude. Look, you got a capsule back down, man. We watched the capsule come back today.
While we wait to hear the results of this latest sniff test, we're going to toss it back to Dan and Rosa, who are there on site, a safe distance away, to give us an update. Dan?
Hey, thanks, Brandy. Yeah, we're still at about the 500-foot point, and hopefully you guys can hear me right now. So we're still at 500 feet away.
200
as
meters,
you saw, everybody did back away from the capsule, and that was by design. So the gold team was in. They detected a faint trace of hydrazine.
Dan?
So this is something they train for. This is something they prepare for. They gave the go for everybody not wearing those kind of hazmat suits to back away from the capsule while they continue to troubleshoot.
And we just got word that we are detecting at 0 now, so everything looks like it's going in the right direction. Again, as you mentioned, this team has trained for many years as part of our procedures. Again, they're still going to continue to monitor those levels, but all is looking nominal now that we've gotten that read for 0. And you know, something great about this team is that this team is made up of many disciplines. We have.
So, how much more advanced than a Mercury capsule is this, dude? A Mercury capsule is analog. This thing's got a digital flight computer in it. Not that that's anything new. The Apollo capsule had a digital flight computer in it. However, Starliner is nuts, dude. This thing has a station or space relative navigation system. Actually, you should say station relative. That's the right way to say it. The Starliner, I mean, it makes a lot more sense why they had why software stuff went a little haywire with this thing. Starliner has one of the most advanced optical guidance systems I think I've ever seen. When I say relative navigation, when they got Starliner near the space station, the computer pointed the capsule, the onboard flight computer pointed the capsule at the space station, and Starliner used, relative navigation. It basically, the computer analyzed what the cameras were seeing, made out the orientation of the space station, turned, reoriented, and got into good alignment for the docking port, and then docked, all on optical infrared and laser systems. Starliner basically has something ironically similar to the full self-driving system that a Tesla has. You know, Teslas don't use like LiDAR or anything. They use cameras around the Tesla to look at the damn road, and that's how the thing drives around, right? Starliner literally has that, but for spaceships, which is interesting because Dragon uses LiDAR. But that makes it so Starliner can basically dock to a space station by literally looking for it. Think about if you were in this capsule, what would you do? Look out the window. Okay, where's the space station? Okay, it's over there. I gotta move towards it. Okay, we're moving towards it. Okay, look out the window again. Where is it? That's what Starliner does. It can look for a station with its own onboard cameras, which is really freaking cool. That is a pretty awesome capability, I will say. That's pretty impressive. That is a pretty impressive capability. You know, I gotta hand it to Boeing. That's pretty smart. Yeah, capsule's big, man. Gotta fit 4 people in there.
They
Orion's bigger than that. True story.
We're now told that they have a 0 reading. So we'll be giving the go-ahead for the rest of the teams to start making their way back over.
Should see the silver, blue, green, and red teams moving
that were
in.
able to be complete earlier.
It could hold up to 7 roundabout, 4 for NASA missions, though.
Meaning that they were
With
able
a jump
to make
seat,
sure that there was no residual electricity. You may have noticed the hazmat team was touching the vehicle. That is something they were able to safely do because that grounding did occur earlier.
Yeah, the vehicle is grounded, which means the silver team has done their job.
We will have the green team moving back in here shortly.
I know that sounds ridiculous. It doesn't sound like that is that complicated, but having an optical system where the computer interpolates an image and looks for the right spot on the space station to dock is pretty damn impressive. That is not an easy thing to do. It didn't take anybody up, Farm. No, it has an anthropomorphic test device, which basically is the same type of thing that they use in crash tests for cars. It's just a test dummy. Test dummy's called Rosie.
Next thing that we'll be seeing here shortly is the green team coming in to...
Farm, you will never guess who's riding right seat in this thing. You'll never guess who's riding right seat. Look who's riding right seat, dude. Can you believe that? Freaking Jeb is on board. I'm dead serious, dude. There's footage of Jeb just floating around when the capsule is up at the space station. Freaking Jeb's on board. That's the best part of this, man. That makes me so happy. I'm amazed it made it with that guy on board. He's a crazy melon farmer right there. How much radiation do the ships or whatever have from space when they come back? Nah, it's not too bad, PC Tekka. Yeah, not too bad. All right. Yeah, Jeb's riding right seat in the capsule. Unbelievable. I've seen everything now. Jeb have sensors? Well, Jeb is the sensor. He was the 0G sensor, 0G indicator. Jeb is why all the RCS fired at once. Yeah, he left RCS and SAS on, obviously. W, nice reference.
When Starliner landed around 5:49 Central, 4:49 Mountain Time today, it did land under 3 good main parachutes.
Note how they're putting covers on all the RCS.
As well as fully inflated airbags. And these capabilities are just something that help us turn the vehicle around in a much quicker time frame.
See the ground wire right there?
Of course, this is a reusable crew module. Can be used up to 10 times. With at least a 6-month turnaround time.
6-month turnaround on Starliner capsules. Interesting. Team, see they put FOD covers on the RCS there.
NDS cover at the top of the crew module. That is the NASA docking system cover.
That's this
and
thing.
That has been added to our vehicles since the last flight to further protect the NASA docking system during those hot loads as Starliner makes its way back down to Earth through entry interface.
Yeah, it's got a nice toasty marshmallow cover, indeed. All right. If these guys are giving the go that I think they're giving, they should the other team should be coming in here. What is Crew Dragon's turnaround time? About the same, Tipsy, give or take.
We do also see exactly what we expected to see with the crew module returning through that hot entry interface. You can see that black marking there on the left side of it. There's another one on the exact opposite side.
Interchangeable name, Donald.
And it's the same thing we saw after our last flight. These are just proof that the ablative material that is wrapping around Starliner is doing its job when it is able to protect the crew module as it comes back through.
All right. Looks like the guy's giving the thumbs up. They're putting the rest of the FOD covers over the RCS right there. So, Tipsy, Crew Dragon turnaround time is about the same. It's about the same time, but the thing is that that's not that Starliner or Crew Dragon couldn't be turned around faster. They absolutely could. They're turned around with a processing flow that supports the missions that they're flying. Meaning NASA only needs them to launch every 6 months. So the refurb time was set as 6 months, at least out of the box. You could optimize it and get better from there if you really wanted to.
49 p.m. Central touchdown.
There's no need to, though,
Starliner
unless
came
there's
in
more demand for the
landing
capsule.
across Baja Peninsula and the northwestern corner of Mexico before making it to New Mexico, and the team's there.
Why don't they use drones to sniff for hydrazine like the Boston Dynamics dog? Because those are expensive, and if you outfit hydrazine sensors on them, they're even more expensive than a guy with a scape suit. Scape suit is proven technology. That works.
The hatch on Starliner. Give Rosie some fresh air.
Alright. Yeah, Jock, they were very nice. Yeah, but a robotic dog is cool. But guy with scape suit in a wagon is cool too.
You can see the gold team now moving away from the spacecraft. Of course, when we spoke with Rosa and Dan just a short time ago, they did report that there was a 0 hydrazine on the meters, so a good sniff test. And we do expect to see them alert the other teams to start moving back into the spacecraft.
Here we go. Here we go.
And all the teams, looks like now getting that go-ahead to start moving in again. No hazmat suits necessary at this point. And they can keep working through those recovery steps.
Ah, these Minecraft filters. Really good. This is RTX off, by the way. Gotta flip RTX on here. Ah, there we go. RTX is on. Perfect.
So this is the silver team that has moved in now safely after that sniff test was done. They were able to ground the vehicle, which is part of their job. They did that a little bit earlier. And that's just to make sure that there's no residual electricity. Of course, Starliner was already powered down, but it's just an extra safety step.
You guys cutting the parachute rigging. All right, next team in should be the green team for environmental control. Blue shirts are the video team. Silver team is grounding and safing of the vehicle. What Minecraft resource could you get from here? Quartz. Yes. Salt. I don't know. Red is hatch opening and crew extraction from what I can tell here. Sand. Blue is the video team. Green is the vehicle environmental control team. Red is hatch opening and crew extraction. Silver grounds the vehicle and safes it. Gold is the decon guys. All right, crew's moving in. There's the Humvee with the radio antenna on it. Where's the deuce? That gas they're looking for. That gas they're looking for. Why is that considered so dangerous to humans? Because it makes your lungs stop working. Yeah, that's kind of a problem. You need those. If I recall, the last 2 years, we've been kind of playing cat and mouse with a virus that also makes your lungs stop working. Yeah, that's kind of, yeah, you need those. That's kind of important. That's properly called a Colt. Sell on light truck. Oh, neat. So this is a shot of the recovery site. That capsule right there in the center, iconic vehicle, just came back down from space, and now they're going to back up the ramp to it. Yeah, it makes your lungs stop lunging. Your lungs will lung-int. Yeah. Yeah, that's kind of important. You need to do that. Speaking of hydrazine being back, worked a Pegasus launch years ago. They said if the little circle on your badge stops being white, don't walk away, run. Yeah, there you go. NSF dropped a new flyover video. We can watch that after coverage if you want. There's the Deuce! Oh, the Deuce truck is sick, dude. Look at that thing. She's a beast. Bring on the Deuce truck. Come on, switch back to drone cam. Switch back to drone cam. Yeah, see the trailer. See, look, there's the U-Haul trailer with the gantry built on it. There's the Deuce. Look at the Deuce truck. Hell yeah.
To set up that environmental enclosure.
Oh yeah, the Starliner tent. I forgot about that.
Discovery, go and throttle up.
And on the right side of your screen, the red team is moving in, and that's the team that we really want to pay most attention to because they will be opening the hatch. That team is made up mostly of Boeing Fire Rescue, and as you can see there, they're moving that mobile access platform in right up to the hatch on the crew module.
It is nose,
just so they can have the closest access to
what's the Starliner tent for?
Hatch.
FOD contamination. Make sure that
and of course,
no foreign objects get inside a Starliner any more than they need.
Astronauts on board that would be getting them out and moving them over to the medical truck where they would get
It's just a big
post-landing
balloon
medical
castle.
checkups.
Seriously, it's a Starliner-shaped bouncy castle. I'm not even kidding. Watch. They'll take it and they'll pick it up and they'll put it over the capsule. It's actually really funny. I want to know what the Deuce and a half with the huge Starliner logo on the side is for. See, it's up there in the top right. Come on. Yeah, or we could watch this picture of sand. That works. Sand is good. They have a truck that's red called Blue One. Oh, okay.
We're ready now to take you back to the landing site to hear more from Dan Hewitt and Rosa Benuelos to give you the latest information on what's going on out there. Dan, Rosa?
Is anybody watching the cameras? No.
Thanks,
Tango Delta.
It's great to
Touchdown
be with you
confirmed.
again
We're
from
safe
our
on the.
landing
We're
site
safe
here
at White Sands Space Harbor.
Mexico. It's been quite the eventful day. We continue to go through the landing and recovery operations as a team has been now. Where we see the mobile access platform behind us. The medevac has been backed up to the crew module, and we will keep moving forward with the different procedures here for the recovery effort.
It's painted white.
Yeah,
It's
we
cool.
had a little bit longer wait at the 500-foot bar, so everybody's been following along. And again,
look at this.
We're able to continue to sweep around. No hydrazine's been detected. That's why you obviously see everybody has moved in now to continue through our operations. We should be getting you some close-up views, I hope, of the capsule and the recovery as it's unfolding.
Putting down the landing gear.
You can see, so as Rosa said, the mobile access platform's getting into place now. This is kind of the yellow stairs, and we are going to be able to use that to get access to the hatch and all of the other items, all of the hatch operations, and then you may not be able to see it in every single view, but there's a large truck just
This is
to the
awesome.
right
I like
of the
this.
capsule from our viewpoint, with a big Starliner on the side, and that's the medical truck. So
Oh,
it
the
doesn't
Deuce is the
have
medical
a
truck. Got
purpose
it.
today with no crew on board, but we're still going through all of the operations as we would if a crew were flying on Starliner, and that's going to get
Yeah, I
backed
got
up.
you, Thomas. That's
And
cool,
that'll be
man.
really kind of the first place on planet Earth that the crew goes after they return in a trip on Starliner. So we'll see that back up, and then we'll get into some of the hatch ops.
And off to your left, now I'm not sure
Green,
you can see
please.
this in the camera. We do see those, again,
Please,
beautiful
green.
red, white, and blue parachutes. Again, the silver team will be safing those. It will be taking care of collecting any of the other jettison parts. And to our right, also not in your camera view, is our
Please.
decontamination
Please, green.
tent.
Please.
That's set up again for any potential exposures to the hazards. It has not been used, but it is here
The
ready
truck is
to
red. The truck is
be
red. The
used
truck
in
is
case of
red.
anything. So again, we are still moving forward with that, putting up that mobile access platform, and the team is still now. It looks like they're adding some of the.
How do you move it towards
connecting
the
some
capsule
of the tubing
now,
for the cooling
fellas?
system.
It's kind of.
And then we're taking a look. So yeah, you can see it almost looks
Is it
like
a
a moon rover,
is it a
but that's just
retractable
part of
gantry?
that HVAC system that they're using to provide some positive pressure inside of the capsule. And we also have, again, like an HVAC cooling
dude, it
system already
extends.
hooked
Dude,
up
that thing
to
is
provide
cool.
cooling
That
inside the
trailer's
capsule.
legit.
And you're going to be able to see a lot of the red team through all this
I have
action.
to remember all this.
And
Yep,
we've
gotta
already
sweep
got
up.
somebody up on the map getting some of that gypsum sand that is everywhere. Getting that off, and
I don't like
everybody's
sand.
color coded by our vests. The red team,
of course.
Again, that's a mix of
Rough.
Boeing medical, fire,
It gets
a lot
everywhere.
of different professionals. One of the key
That was a
Boeing
broomstick,
people on the
yes.
red team is going to be doing the hatch operations. We're going to be going in through the side hatch. So again, Boeing has two hatches on Starliner. You've got the side hatch, and you've got the what's called the IVA. It's essentially the hatch at the very top. We use that whenever Starliner's docked to the space station, but for all of our ground operations, we're using that side hatch. It's been closed since it was on the pad out in Florida, and it's going to get open for the first time here in just a little bit.
That's right, Dan. As you mentioned, that Mars rover looking car to the left actually is a humidifier. And again, that's providing some of that positive air into the crew module and keeping any of that
bouncy
dust
castle hasn't
outside.
inflated
And that's
yet,
part of the
Laser.
purge
I don't
system.
know.
It's really
I
critical
don't know,
to
dude.
keep the
Let's
humidity
see.
levels at a stable condition inside the crew module as we are getting ready to open that hatch. So we're seeing some great views on our side here. Again, the team continues to work, continue to work on
Medical
setting up these
deuce.
different systems. That mobile platform looks like it's ready. The team is up there working. There are procedures, and we
Hello?
Looks like we have some technical difficulties. May have lost Dan and Rosa for the moment, but we'll hang on to see if we can get them back in a little bit later. But as Rosa was saying, the mobile platforms moving in for the hatch opening of Starliner, so that the teams can begin unloading, among other things, Rosie.
Rosie, and of course our gravity indicator, Jeb, or Jebediah, part of the Kerbal Space Program.
Yes, the Kerbal Space
It was a bit
Program.
of a surprise for some folks. Once we docked to the International Space Station, we started getting views of him doing his job as the gravity indicator. And there on your screen you can see the red team, which is made up of mostly Boeing fire and rescue crews. They are working to get the hatch open right now.
No way. Yo.
All right, we are going to try and get back out to Dan and Rosa now. Guys, do we have you?
Look at the drone footage. Look what antenna they're setting up. That's from Joey Roulette. Oh my goodness.
Hey, Brandy, yeah.
They got a Starlink antenna out there.
One of the joys of working from a really remote location is you do run into some occasional technical hiccups. I will say we've got a bunch of certified wizards on the blue team here today who are bringing us all of these different views for folks around to take a look. But again, we're getting into our hatch operations, so the access panel on the hatch is getting opened up.
Does that mean it's
There's a
not
special
redundant
tool
to
that
similar
our
architecture?
lead hatch ops engineer is going to be using to get that open. The hatch can operate within a pretty small range of PSI.
It's not redundant to similar though, man.
Side, basically just meaning we need to make sure the pressure inside of Starliner is relatively the same as the pressure out here. And after they get that confirmed, we'll be able to get the hatch open.
Not really, Jack. No.
That's right, Dan. And once we're done with this hatch opening procedure, we will be going through the closeout. Starliner will actually stay overnight.
I actually like this camera.
It will
This
be
is
sent
cool.
to a processing center and then make its way back to Florida. So Starliner will be remaining here in New Mexico for a few more days as we go through those procedures. But again, we're very happy that we have Starliner back home here in New Mexico, and again that we've had the successful test flight in preparation for our next crew flight test.
And one of the operations we're going to be carrying out here is going to be cargo. We have some of the NASA cargo teams out here with the crews, and they're going to be able to move in once we get the hatch open. We've got a small amount of really time-critical cargo that's going to come off, including some radiation monitors and a couple of utilization items from our NanoRacks modules on board. And then they're going to bring out a couple of other items just to test that real-time cargo retrieval. When crew members are returning on Starliner, they're going to be bringing
what's that, Thomas?
Essentially pieces of themselves home with them. Crew will take a number of different blood samples, other things like that, just prior to their return, and those get stowed into cold bags or cold-powered cargo containers on board the vehicle. And that's one of the really critical science items that we return from the space station, and that's one of the reasons we're really excited to have Starliner come on board and add another cargo delivery service back to Earth. We definitely have a lot of vehicles bringing cargo up, but it's a much smaller number of vehicles that's able to return that cargo down. So
very nice.
Some of that time-sensitive cargo will get brought off board today. The rest will remain on board Starliner until it gets to a processing facility, including our large cargo items that are coming back today. Those 3 NORS tanks, as people have heard about, the nitrogen-oxygen recharge system that we use to essentially recharge the atmosphere on board the space station.
That's right, Dan, and I'm sure a lot of you are wondering if Rosie will be exiting the crew module, but she will as well with the NORS tanks and make her way back to Florida.
He knows, Green.
Again, the team is still working here on opening that hatch. As you can see, them going through their procedures there on top of the mobile platform. There's a good look there at those airbags. Again, those fill up with nitrogen to provide that soft landing for Starliner, and again, a very soft landing for our crew for the next.
They're still sniffing for it, Signer, but everything
so again, a
is
great
good.
day here for the whole Starliner team. You know, as a native of New Mexico myself, I could definitely be proud to be part of this orbital flight test too, and I know I share that same feeling with everybody here on the ground and everybody around the country and our teams in Houston and Florida.
Yeah, it was, I think I said it earlier, it was pretty surreal for Starliner to just appear in the air. At first, it feels like it's almost above you, even though it was several kilometers downrange from us. Those airbags are really cool. There's essentially an airbag inside of each airbag as it inflates. There's also a central airbag in the very center of the capsule. That only gets used if Starliner is in a water landing. That can help with the uprating system on board the capsule. So obviously and we see the hatch is
open. And that's fantastic news. Again, the team is now going to be making their way into the hatch to do some of those closeout procedures. We're going to have again some of our team from the red team start going into the cabin and again doing some initial assessments, and then again continue with those procedures for that red team.
All right, so 6:06 Mountain, 7:06 Central, 8:06 p.m. Eastern, Starliner hatch is open. So they'll get their first look inside, and again, we've got some cargo specialists that'll be allowed to move up close pretty soon.
I like it, Pulse. I like Starliner a lot.
Some of the items
I've always liked
that Starliner's brought home.
It's a great system. Dragon is too. You can like both of them, remember.
And we just got word that while Starliner was landing in White Sands, New Mexico, it was landing at about 26 feet per second, which is right what we expected. A very comfortable ride if we had astronauts on board.
It's the power of shuttle
cushioned
parts,
by those landing airbags.
Yeah, Joe, me too. Me too. Jeb, EVA report for extra science, man. Before you egress. Actually, you got to do it again when you egress the capsule. No video. This is cool, man. I like this. Calypso is the next one up, Green. I don't know if this one's gonna get a name until crew flies on it. This one should be. What is this one scheduled for? This was supposed to do the crew flight test, and now it's going to do PCM-1 because Calypso is gonna fly the crew flight test instead. So this one is PCM-1, so I don't think this capsule will get a name until somebody flies on it.
But a brief cutout there, but we are going to go back now
or
to
is this
Rosa,
one
who is
Calypso?
with
I'm not
Mark
sure.
Nappy. She's
One
going to
of-
get a
one of them is
few
named
post-landing
Calypso.
words from
I don't know
him.
which one
Rosa?
it is. Mark.
Hey there, it's actually Megan Gessner out here in the field with Mark Nappy. And Mark, you know, we did experience a little bit of a delay there at the beginning with the hydrazine link. Can you talk to us a little bit about that?
Okay, well, the team comes in and has to check the vehicle out to make sure it's safe for others to approach.
Mark.
When they got in, they have these things called sniffers that
Jeb?
come in and check for
Jeb?
hazardous gases such as
Where's Jeb?
hydrazine. They came in, the thruster covers were put on, and they got a little bit of a high reading. So they fell back like they were supposed to and made sure that they could assure that the area was
Jeb?
safe. They went back, checked again, and all of it had dissipated, so everything was safe. So the team reacted just like they were supposed to. It was a sort of a nominal situation that we sometimes encounter, and everything's back to normal, and the team is off getting the vehicle safe.
And that's why it's so important that we practice these types of things to ensure the safety of everyone that's here.
Absolutely, and today was just a perfect example of how well this team is really trained.
Absolutely.
The
And
stuff we
you know,
knocked out of it.
today's been a long time coming. It's now finally landed. How do you feel?
I feel great. There's lots of emotion. First of all,
He's an
really
engineer.
happy for
Oh,
this
yeah, I
team.
feel great.
People
Lots
have been
of
working
emotion.
on this for 10 years, and just waiting for
That ain't
today to be here so that we could have a successful mission. I'm proud of the team because they've just put so much work and effort into this, and then I'm
That's
really
correct,
humbled
Scoggs, yep.
because I'm standing on the backs of two really excellent program managers that got us here, and John Mulholland and John Vollmer. They have to be sitting home with big old smiles on their face.
Oh, I'm sure they are. And
Kyle
there's a lot
Estover
of the
made
team
the
that's
airbags,
here
guys.
today. Have you had a chance to talk to anybody, any of the ground crews just yet?
Oh, a lot of folks. They're just ecstatic. This was really something, seeing the vehicle come in and just gently come back to Earth and settle down on the lake.
It'll be
here.
Kerbal
So
rated
It's just
hip-hop,
been
yes.
incredible. People are really feeling good.
Absolutely. It was definitely a beautiful sight watching it come down. And I know we'll hear a little bit more from you a little later today. I
Mark
believe you're going to be a
is
part of
very
that
excited. You
post-landing
can tell from his voice.
conference that's going to happen on NASA TV a little later today. And for now, we're going to send it back to our friends over at KSC.
Starliner is
JSC.
Kerbal
I'm not sure
rated.
where y'all are at. Lauren Brady.
Thanks so much, Megan. Yes, here coming live from Houston in Mission Control. Great to hear from Mark Nappy, our program leader, the leader of our Starliner team, and really pretty awesome for him to be out there at the landing site with our crews. I'm sure it was a very exciting moment for him and everyone else to see
People are so
Starliner
excited they can't
land
speak
so
straight.
delicately there at about 4:49
Should be
Mountain
by the end of the
time
year
this
roundabout, but it
afternoon.
really depends on how good a condition that capsule's in. Not because they're going to use that capsule, but they want to make sure that Starliner did basically everything that they wanted it to do. I wouldn't put people on this unless we reviewed the data from this CFT or this OFT test before you put people on it. You want to be absolutely sure. So they're going to assess the data on this capsule, make sure that everything went honky-dory, and then once that data has all been kind of combed through, because they are out in the desert. They got to comb through the data, sometimes with a comb, sometimes with an afro pick. And if they report back that they ain't found
We're going to keep
nothing,
sticking with coverage for a little while longer as
then
the teams make their way
they'll start
through
making
the
steps for
post-landing recovery
the crew flight test.
checklist. As you heard there from Dan and Rosa earlier, and as you can see here on your screen, they do have the hatches
Gotta
open.
comb the desert.
Still got about 2 hours left until sunset in New Mexico, so they've got some good working daylight hours to go.
And as Megan was talking to Mark Nappy, we did get a peek inside the crew capsule. We could see Rosie there in her seat, everything looked good. She looked exactly in the place that the crew on the ISS left her just this morning. She undocked.
You heard about the rubber plane? It goes boing, 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 boing. Anyway, Jeb is riding right seat,
We'll
guys.
get to hear a little bit from astronaut Butch Wilmore, who is at the scene along with the recovery team. He, of course, expects to be in the capsule for this scene next time it comes around. So
See, this
great
guy
to
on the
get
right.
his
This guy
perspective.
has the right idea.
Lots of activity still
Gotta get that neck
to
flap.
to observe as we
Hey,
make our way
come
through
back
these checklists.
So, you think we're taking this too literal? No, we're told to cold the desert, so we are. What are you preparing? You're always preparing. Just go. Just go. You got positive pressure inside of the capsule. That's what that hose is. They're pumping air inside of the capsule, and the capsule is airtight. So it basically creates a draft that pushes air out of the capsule, right? Through the hatch. That makes it so no bugs or dust or anything climbs in there. Maintaining that positive pressure helps make sure that the capsule stays clean. They accidentally vacuumed up. Jeb, it's not a vacuum, it's a leaf blower. Chief, good morning. But as you can see, OFT-2 is back on the ground here, landed almost dead center on its landing target at White Sands. Really, really good. Please. Thanks for the answer. No problem. This is cool, man. They're actually just... I like how the camera's just chilling here. This is cool. Oh.
And we're going to go back now to Megan Gessner to hear a little bit from our resident astronaut on the scene.
I'm going to
Megan?
go over to this side. Go.
Okay.
Megan,
We're live,
hey, all right.
Butch. So good to see you here today. I know you weren't able to make it out here for OFT-1, but today you are here in person. What are you feeling?
Oh my. I mean, we all tracked towards from the beginning, from launch all the way through the mission, and this is what we were hoping for at the end, right? I mean, a soft, safe landing, culmination of all the hard work. I mean, you've got to give a huge congratulations to the folks at Boeing, all the way from Mark Dabney, all the way down, everybody that's worked the program, gone through some difficult situations, and now to culminate in this after a wonderfully successful mission. I mean, well, you couldn't ask for more.
Absolutely. Definitely takes a big team effort to have all this happen. You know, now as a casual observer, you know, I see one thing when I see a spaceship coming down.
And as we mentioned earlier, we have had some trouble with the signal going in and out with our live crews there on the scene. So if we can get them back up, we will.
They were very
and
excited.
If not, we will probably get one more check-in with our crew before we wrap things up here for the day.
Come on, give us another shot of Jeb. She despawned. Yep. Some stuff hammer nails for the most part. Damn you, Starlink. If only you had a small constellation of internet satellites. Yeah, I know, that'd be pretty useful, I think, huh? Depends on who engineered it, hammer nails. Most NASA stuff is public resources, but some of it's proprietary now that we're using commercial stuff. Did this land in California, White Sands, New Mexico, Doom?
And you are seeing live pictures of our crews that are performing many of the closeout procedures and landing procedures that we've been talking about, making their way through that crew capsule after a 4:49 Mountain Time landing this afternoon, 5:49 Central. And it sounds like we do have the signal back, so we are going to go back out live to Megan Gessner and astronaut Butch Wilmore.
going in? Oh, no, not yet. Megan? What? Megan? Hello?
Sounds like we are not going to get Megan and Butch back, but we're going to hang with this this view a little while longer, see if we can get another update from the team out there.
Ah, the drone is back up. Yeah, remember when I said the drone was back up? Yeah. Kind of. Excuse me, I was expecting a hot new song to commemorate this event. I still like the red Humvee over there that says Blue 1 on the side.
Discovery, go at throttle.
Who's directing this? Guys, the drone shot's doing the flyover and no, we gotta cut. How much online on NASA? Yeah, I don't know what that means. I'm not sure what you're trying to tell me. Hey, Afnek, 4-month resub, thank you. It looks like the Starliner tent broke. The Starliner tent is not inflating. Did they just say?
We promised you one more last update from the scene in New Mexico, and now's the time. So we're going to go back to NASA's Dan Hewitt and Boeing's Rosa Benuelos to give us one final report for the day.
Hey, thanks, Brandy. Yeah, we'll get through it quick, just in case we drop out. So all the hatch operations have continued. They're moving inside the capsule now, so we're about to get into the cargo operations. Again, we've got a small amount of cargo that's going to come off, some radiation monitors, and then a couple of other utilization or science items. And then one test that's going to be coming up in a little bit is with some of the safety hardware that's on board. So the crew will actually have a satellite phone that they can plug into the CM or the command module systems that uses its antennas that they can then make a satellite call if they land somewhere in a remote area without a recovery team. So we're going to do that test in a little while. A plane's going to fly overhead to test it out, and then that'll largely wrap it up for most of the team before we head back in.
That's right, Dan. And again, we've taken quite a bit of time and really carefully gone through these procedures. This crew module is reusable up to 10 times.
Dan on the left,
so
Anopedic is NASA,
in good
Rosa
condition, and so we
right,
could expand the lifetime. Again, this crew module will be used for a post-certification mission. And so again, after tonight, it will stay here, and then we will take it to a processing center and then take it back in a vehicle to back to Kennedy Space Center. So again, it's been a fantastic day. The sun is starting to go down. We probably will see a sunset to our right here in a little bit. But again, it's been a little warm, but again, we're hanging in there. Everybody is still, excited to be part of this mission. And again, as myself, I'm excited as well to be here. And so it's been a fantastic day.
Yeah, it's been an absolute pleasure to see Starliner come down, to see all the operations, watch the team walk through everything. Even when we hit a little bit of adversity, they overcame. The capsule's safe now, and welcome home, Starliner.
Yes, so welcome home.
That'll do it for us here in the desert. Thanks everybody who's been following along and watching. We hope we showed you a little bit of the magic, the excitement of human spaceflight. Looking forward to the next time when we're out here and there are humans coming out of Starliner.
Thank you. Back to you, Brandy and Lauren.
Thank you so much to our entire team out there, and thank you, of course, to our partners at NASA as well as our partners at ULA for that safe launch. Just a few days ago, it has been a big day for human spaceflight, and it has just been a wonderful journey to watch Starliner launch from the Space Coast and rendezvous, then dock with the International Space Station, and then make that beautiful landing today, just a little while ago in the desert of White Sands, New Mexico. Just like they said, we cannot wait to see astronauts on board next time.
Thank you so much for joining us for both today's coverage and the entire mission, but you are going to want to stick around just a little bit longer. We do have coming up for you at 8 p.m. Central Time the post-landing news conference, where we'll have NASA and Boeing officials give you one final look at the Orbital Flight Test 2 mission. Again, that's going to be coming up at 8 p.m. Central Time here on NASA TV. But with that, we are going to wrap up our coverage for today. So thanks again.
I love how Brandy was just like,
Good night, everybody.
Fixed. Oh, keep the camera. No, just keep the camera on this. Keep the camera on this. That's not what I said to do.
Discovery, go and throttle.
Hey. Not bad, guys. Not bad at all. Not bad. We're on our way to having 2 crew-rated orbital spacecraft. That's pretty good, man. It's pretty good. I'm pretty excited. I don't know about you guys. Seeing that thing come back down is pretty damn cool. Let's get some people on that thing, as long as the data is reviewed. Also, this banger of the outro music, banger outro music that we have here. Not sure we had enough space today. Dude, we had a lot of space today, man. Oh, yep, did just cut it before the music ends. Yep, that's fine. Not bad. Not bad at all. Not bad at all. Sorry, I'm just looking at the thread that Felipe was talking about. What's next? So, we got about 34 minutes until the presser. I thought you guys would want to watch that. But, yeah. Man, what a day. Yeah, we'll watch the press conference. Press conference is really where you start learning stuff about the capsule, but, so you're saying buy Boeing stock? That's what I got from today's stream. I give no economic advice on this stream. Ever. Did they determine why it overperformed in the initial burn? Nope. Haven't heard anything about that. I'm back. Did I miss the NSF video watch? No, but we could do it now. Coverage just ended. You guys wanted to watch some NSF footage, so I'll switch us back over to Space News here. And then we'll get the press conference, and then I'll get us to EJ's Space and Rocket review. All right. So we'll do some space news here. A little more space news. NASA Spaceflight did post a new KSC flyover video, so we'll check that out. Do that for a little while, and then we'll watch the press conference. And I'd say that would probably be good putting a bow tie on that. Putting a bow on this stream, not a bow tie. Bow ties are good, but probably put a bow on this one. Today was a good day. A lot of stuff happened. We watched the launch. We watched an undocking. We watched a re-entry. We watched a Falcon 9 land. Whew. Can we do this every day? Can we do this every day? This is great. This is great. I love it. What's the next launch? I can't get enough of this stuff. The next one is tentatively scheduled for June 6th. It's a capstone mission. And then on the 7th, got another Falcon 9. SpaceX 25 is going to go up and dock an uncrewed Dragon capsule to the docking port that Starliner was just at. Yep, Starliner had to vacate. We got another mission coming. Pretty freaking cool. All right, so let's flip over to this NSF flyover video. Let's see what we got here. We'll be worn out after day 5? Hell no, never tire of space, man.
This video was sponsored by Skillshare. In this week's flyover, legs for the orbital launch mount at Pad 39A begin going up. Foundations for the Mega Bay at Roberts Road are completed. And Blue Origin continues with expansions of their campus. I'm Ian Atkinson with NASA Spaceflight, taking you on an aerial tour of the recent progress around Kennedy Space Center. Let's start off with SpaceX's Roberts Road complex at Kennedy Space Center. On the east end, as always, we have Hangar X. This facility is used to refurbish Falcon 9 boosters as well as fairing halves.
Yeah, that's true, Thomas.
By its main entrance lies the empty Falcon 9 booster transporter parked to one side, waiting for yet another booster to be loaded onto it and moved to either of SpaceX's launch pads at the Cape. This is quite common these days, as SpaceX is ramping up its launch cadence. To the north end of Hangar X, we can see that an area has been cleared for what appears to be upcoming parking space. Moving from here to the west, we have the Starship Launch Tower assembly area. This is where pieces for the Starship Launch Tower are being assembled in segments before later being transported to the launch site for stacking in the near future. Counted in order of construction, the 5th and 6th segments are now structurally complete compared to our last flyover. All columns and crossbeams have been installed in them. Additionally, the 5th segment can be seen sporting a new floor to facilitate worker access to that particular level once the segments are stacked at the 39A launch tower area. Feet stands for the 7th segment are already in place, with a column getting ready for lifting and installation, and several crossbeams staged nearby. Also in this area, we can see the feet stands for the 8th and 9th segments. One set is next to the 3rd tower segment, and the other set is near the water tank.
That's the jig that they built
It is believed that these two will be the last segments to be built, based on the available concrete stands for the tower segments. Moving a bit south from here, we can see that the tent area has seen the arrival of several cryogenic pipes, and work is already ongoing to prepare them for installation on the tower segments. SpaceX is most likely going to outfit the tower segments with these pipes while at Roberts Road to reduce the amount of work needed to be executed on the launch tower once it's stacked. Having to install large pieces of hardware, like these pipes, onto the assembled tower is time-consuming and requires tall cranes. And last but not least, it now appears that these tower segments have been identified with numbers, but they don't match the order they were built in. It wouldn't be surprising if these numbers end up being their stacking order. Moving to the south from here, we can see that the Mega Bay foundations are now complete, with rebar sticking out of the ground. The pile driller has also been moved away from this area, which is a great sign that work on the foundations has ended. We can't really say the same about the Star Factory building, however, as work is still ongoing on its foundations. The pace of work in this area is slower than previously expected, given the agility the SpaceX teams had at the beginning of this building's construction. But good news for those who like cleaning though, SpaceX has finally removed the burning pile of wood they've had here for the past several months. These were trees and bushes that were cleared from the construction area. Some concrete has also been laid out nearby. It's still unclear why, but we'll be keeping an eye out as to what happens here. Next, we'll discuss progress on the Starship pad at 39A, but first, thanks to Skillshare for making this video possible. Skillshare is in this video. SpaceX has started installation of the legs for the orbital launch mount, with 3 already visible in this flyover. It is notable that these legs don't sport any elbow structures like the ones do at Starbase. It is yet to be seen whether they'll be added at a later time, or if this launch mount design already takes into consideration the absence of these elbows. The base of the Starship launch tower remains visibly unchanged. It is likely that teams are waiting for the concrete to cure before pouring the next section. It is also to be expected that minor work is still ongoing on the interior areas of the base. On the main ramp of Pad 39A, we can see the Transporter Erector, or TE, used for Falcon rockets, now having its top section in Dragon configuration.
Yeah.
The TE uses two different top sections depending on whether they're performing a mission with a Dragon or a fairing on top of the rocket. This work was needed to take place in preparation for the CRS-25 mission, currently scheduled for liftoff in about 2 weeks.
Yep, that's what we were just talking about.
Just west of Pad 39A is NASA's Vehicle Assembly Building. This massive facility was used to assemble the mighty Saturn V and Space Shuttle rockets. Currently,
I'm just going to pause Ian for a second there. See this building with the blue on the side? That capsule that you just saw re-enter was built in that building. Yeah, that's Starliner's Commercial Crew and Cargo Processing Facility, or C3PF. It's right next to the Commercial Crew and Processing Office, right there. Commercial Crew and Cargo Processing Office, which is this building right there. That's the C3PF and the C3PO.
It's used to put together NASA's Mega Moon rocket, the Space Launch System, which will carry humans back to the moon for the first time since 1972 as part of the Artemis program. Various components of the SLS are delivered to this massive facility, where they are stacked atop the mobile launcher before rolling out to Pad 39B. Soon, we'll see the SLS roll out again to this pad to complete the wet dress rehearsal test, which the team wasn't able to complete due to a failure of a helium check valve on the rocket's second stage and a hydrogen leak at the tail service mast umbilical. The wet dress rehearsal is crucial to test the fueling and countdown procedures and to make sure that the rocket and ground support equipment is all good to go for an orbital launch. Just beside the Vehicle Assembly Building is Boeing's Commercial Crew and Cargo Processing Facility, or C3PF for short. This former shuttle processing hangar was used by NASA for extensive preps and refurbishment of the space shuttles before Boeing converted it to manufacture, process, and refurbish its Starliner spacecraft. A Starliner capsule is currently docked to the ISS as part of Orbital Flight Test 2.
Well, this video's outdated.
And once it returns back to Earth, the spacecraft will be refurbished in this facility before flying another mission, likely the first operational crew rotation. Next, we'll discuss progress at Blue Origin and at SpaceX's fleet. Over at Blue Origin's complex, the 2-cat structure is the main focus of progress. The cladding on the roof is completely done, and the side buildings got more and more covered as well.
Dude, Blue's
in addition, the staircase seems to be fully assembled. What also changed a lot since last week is the frame in front of the 2-cat. That seems to be related to a door for the facility, or perhaps just external bracing. If it is a door, it may be used to seal the building in the future when it hosts the precious new Glenn second stages. Also at Blue Origin, we saw a wrapped dome structure in front of the rocket factory. While this is of course speculation, it seems to be in a range of about 7 to 8 meters in diameter, based on very rough guesstimations. If only there was a rocket that had a diameter of about 7 meters that could be built here. Anyway, the warehouse expansion at the southern end of the campus is slowly progressing as well. Since our last flyover, Blue has submitted updated plans that no longer show a building in the center of this area. Now, they plan to build a maintenance support facility and extra storage areas just to the west of there. Over at the Kennedy Space Center Visitor Complex is the Rocket Garden, which houses various old rockets on display. Beside it is the complex's newest attraction, the Gateway Building, which will be opening soon. Inside it is a flight-proven Falcon Heavy side booster, B-1023, suspended from the ceiling, which supported 2 orbital launches before moving into the new building. Once it opens, people will be able to get up close and personal with the sooty first stage of America's workhorse rocket. Nearby, we spotted a pair of Space Shuttle-era tail service masts, or TSMs. These were used to fuel the shuttle on the pad, as well as maintain data and electrical connections. It is believed
I
that
want
these
it.
two are from Mobile Launch Platform 2. At the launch and landing facility, we spotted some construction work taking place at a patch of land just beside the runway. This is the first stage of Space Florida's development to attract even more industry to the area. The first phase of this expansion will have over 400 acres of usable land, and, according to Space Florida, potential uses for this site include operational hangars, office space, aerospace manufacturing, and more. Over at Air Liquide, things still look unchanged since our last flyover. It's unclear if the upgrades needed for SLS have been implemented or not, since the appearance of the facility hasn't changed a bit.
That's the nitrogen
At Port
flow.
Canaveral, Booster
Flowing
1052-5 sits atop a shortfall of gravitas after having arrived hours earlier at the dock. The booster and drone ship were part of SpaceX's Starlink Group 4-18 mission that launched just last week from Pad 39A. The tug in charge of bringing the drone ship back to port was none other than SpaceX's multi-purpose recovery vessel, Doug. This vehicle helps SpaceX's
Doug.
recovery crews quickly approach the booster once it's safed on top of the drone ship.
Bob.
It is capable of scooping Falcon 9 fairing halves out of the ocean. These days, recovering intact fairing halves from the ocean is routine, and we can see here that Doug indeed came back with both fairing halves from the mission without any visible damage.
Pretty fresh.
And that's it for today's flyover.
Call it
Be sure to
fresh.
check out our daily videos of Starbase and Boca Chica as well, to stay up to date on everything SpaceX and Starship. Finally, thanks to all our members who make videos like this possible. See you all in the next flyover.
All right. Not bad. I know this is really old news, but I recently discovered that they found F1 engines from Apollo 11. Jeff Bezos found engines from Apollo 11. He funded that expedition. I was wondering where they were being displayed. Museum of Flight, Seattle, Washington. Bob is being refueled by the barge being moved by the tug Miss Juanita. And to viewers like you. I noticed some things here. Let me go back. Let me go back here. Can we actually just... That's really cool. The gateway building is really neat. They have a bunch of stuff in there. Let's see, what else is in this? This is NASA's scrapyard, by the way. Dude. Oh, the tail service mast umbilicals. Those are the fueling umbilicals. Dude, they need to donate those to the California Science Center. I'm serious. Donate those to the California Science Center so the Endeavor exhibit actually has the fueling umbilicals next to it. That would be really, really freaking cool. And also, they have the mobile launcher pegs right there. These things are the columns that hold up the MLs when they're sitting out on the pad. Yeah, those are just rusting away. That's a thing. I'm wondering what all this stuff is down here. Some condensers right there. Bunch of other things.
Shuttle era tail service.
Yep. Okay, if you want to know how big these things are, look at the ladder on the side. That is a normal human-sized ladder. Just for some scale purpose right there. See the two ladders? Looks to me like most of the guts of those things have been taken out already. Yeah, maybe. They probably reused it, to be honest with you. Well, some of it's still in there. Yeah. See the doorway right there? That is a human-sized door. That should tell you how big these TSMs are. They're huge. The ones on SLS are basically the same size. They're very similar. See the doorway? Yeah, they're freaking huge. Yep. What's that, Thomas? Yeah, there you go. There's a picture. Yep. Yeah, see the guy standing next to it? They're freaking gigantic. That's a shame. Those were from Omega's mobile launcher, which has since been scrapped, which is really annoying. But yeah, these should go into the rocket garden or something. Put them in the rocket garden, man. They ain't doing any good there. Just take them down the street. We clearly need bigger humans. Yeah, just put them on display. That's really aggravating. Anyway, all right, cool. I think we have one more Starship update to watch too for space news. Let's see. Yeah, we do. Here, let's check that out. We got a little bit of time here. All this footage that we've been watching, guys, is coming from our buddies over at NASA Spaceflight. Be sure you go over there and give them a sub. This footage is coming from Mary and Boca Chica Gal and Nick and Sweeney, the 2 full-time photographers that they have down there. Make sure you go over there and give them a sub, okay? They haven't pulled Jeb out, Loopy, but yeah, Ian, they're pretty neat. That Ian guy, though, making weird jokes there about, you know, about Blue with the 7-meter bulkhead and stuff. That guy's a little bit weird. It's a little bit of a weird one. Nah, good job on the VO, dude. Sounded good, man. All right, they're moving more methane, guys. Once again, indicative of rocket engines firing if they're moving oxidizer and methane. Ian, why did you have to mention the damn TSMs? Why? Why'd you do that? Why'd you gotta do that? Oh, what? Why you gotta make me feel bad? Methane. Blame Julia, she got pics of them. Right. $7 meters larger than the normal, or just not 7-meter diameter on the core, which is New Glenn. Starship is 9, Saturn V was 10. SLS is 8.4 on the orange core stage. More trucks offloading fuel. Do it roundabout. Is Babby. Yep. Who does the copy, Ian, if you don't mind me asking? Note the coolant loop and the heat exchanger on the bottom of the trailer to keep the propellants cold. Alex and Adrian, quite the knowledge warehouses. I don't know how they write so fast. Okay. I am Optimus Prime, leader of the Autobot, and I just crashed into something. Samuel James Wiki, descendant of Archibald Wiki. Whoa, lightning! See that? Sheriff's like, man, what the hell are you doing? I'm trying to back in. All right. Forgot to tell you that the crane is here and waiting for the go-ahead to be put together. Cool. Thanks, Gully. That loop might be there to boil some of the propellant so they don't have to use a physical pump to move around the methane. The one that has ice all over it is used to heat the propellants. Maybe, I don't know. Boy, I'll tell you what, if that truck ain't full of propane, 1073. That's 1073 is oxygen, liquid oxygen. I'm propane. Man, now that's an impact wrench, dude. Look at the size of that impact wrench that boy has. Damn, that's a big one. You see, yeah, Roundabout, you saw it too. That socket was huge. Could use that as a coffee mug. Something about to get the Ugga Duggas, indeed. Did you see that thing? It was freaking huge. That was awesome. I don't know what those dudes are doing. BPW? BPW. How much do I think SpaceX has spent on this? A lot. He did have a chrome bit. Cleaning out the pipes? Yeah, maybe. I mean, Jack, I don't know. It's got to be a couple billion worth of work here. I mean, considering how big that pad is, I would say it's easily over $1 billion thus far. Big pocket wrench. Ah, yes, yes. 1977 is liquid methane. Or no, nitrogen. Methane is different. So 1073 is oxygen. 1977 is nitrogen. I forget what the load indicator is for methane, to be honest. Yeah, 1972 is methane, Thomas. That's right. Thank you. $15, $22, and $20. Nice lawn art. It's its designated number signer. There's a whole list of different things for load designators. I don't know what the numbers have any correlation to. I honestly have no idea. I know that 1203 is gasoline, 1992 is fuel oil, or 1993 is fuel oil or diesel. 1203 is gasoline. Yeah, those are the only other ones that I really know, to be honest. Will it fly this year? I think so. Crane. I have no idea, Draco. Yeah, I'm gonna have to go look. It's pretty crazy, Builder, isn't it? That sounds right, Socks, yeah. Poor Ship 16. Never even got a chance. It's still alive! It's still alive! Oh no! Oh! It's trying to tell us it's to save me! Oh no! Somebody old yeller that thing! Put it out of its misery! Jeez, don't just leave it there to die! Now I feel bad! Oh no! It's terrible. That's not terrible. Oh, Raptor 2. Hello. Oh. That was nice. That's the barrel section that they just moved in a second ago. It's a warning for the other ships. Yeah, I think so, Shadows. Looks like a fixed mount. Fixed mount Raptor 2. Yep. Yeah, I think so. Those are pipes. Laughing pipes. They say you can hear singing pipes. Maybe they're just getting this barrel section out of the way. Maybe, I don't know. One of them things have to be used for testing. How are we going to load them up for the big move? I don't know. Maybe that's what they're going to use 20 for. There's an app for iOS called ERG that has most, if not all, the hazmat number marks. Oh, cool. Called ERG. All right, sweet. Hey, more Oh, they're leaving. The Fagiolis are leaving. No. Well, SpaceX has their own now, so it's fine. Also, Peterbilt. 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 What a view. That barrel section was put over the forward dome for Ship 25. Perhaps they are going to Florida. Actually, that's not a bad guess, Shadows. How's your Peterbilt? I don't have one. I don't have Peterbilt. All right, guys. Well, that finished up just in time for that Starliner press conference. So that's what's going on down in Boca Chica. And let's flip back over to NASA TV and see what we got for the post-flight press conference. Change the title back up, flip it back over to here, flip this back up. Let's see what Boeing has to say about that Starliner flight. All right, fellas, I'm just going to take a stretch break real quick. I'll be back momentarily. And, yeah. Haven't moved from the seat in a little while. Be back in a second.
throttle up.
Discovery, roger. Go for deploy.
H2 and to everybody in the shuttle program, the crew is go for launch.
Roger. Nice to be in orbit.
We have followed in their footsteps to get us where we are today.
Just in time. Here we go. Post-flight can't say that word, but you know it's the thing. Post-flight press conference. Got it.
Good evening and welcome to the Johnson Space Center in Houston, Texas. I'm NASA's Sandra Jones. Thanks so much for joining us following the successful landing of the uncrewed Boeing CRS 100 Starliner vehicle as part of Operational Flight Test 2. Starliner launched from the Cape Canaveral Space Force Station just last week on Thursday, May 19th, and docked to the International Space Station just a day later on May 20th, completing a series of flight test objectives throughout the mission. Starliner undocked earlier today from the forward port of the Harmony module of the International Space Station and landed just a short time ago at the White Sands Space Harbor at the U.S. Army's White Sands Missile Range in New Mexico. That landing occurred at 5:49 p.m. Central.
Hello.
Joining us for tonight's briefing to provide comments after Starliner's landing and to address any questions are Steve Stitch, manager of the Commercial Crew Program, Joel Montalbano, manager of the International Space Station Program, Sonny Williams, NASA astronaut, and Mark Nappy, the vice president and program manager for Boeing, who will be joining us remotely today from the landing site. So we'll first start off with some initial remarks from each of our briefers before opening it up for questions. And we'll be taking questions on both our phone bridge as well as here in the room and on our social media platforms. If you're on the phone, please press *1 to add your name to the queue and ask a question. And if you're on social media, you can use the hashtag AskNASA to submit your question. So we'll now begin with some opening comments from Steve.
Yeah, thanks, Sandra. What an incredible day it was today. You know, we had the landing of Starliner today. It was a picture-perfect landing at the White Sands Space Harbor. Starliner hit another bullseye. I think the landing point was about 500 meters or so from where it was intended, just due to the winds being a little different than what was predicted. You know, it's great to have this incredible test flight behind us.
That's cool.
The test flight was extremely successful. We met all the mission objectives. And of course, today was a big one with the undocking, the separation sequence, and then the deorbit burn, entry, and the landing.
He's been good.
I'd like to congratulate the entire Boeing and NASA teams that have worked so hard on Starliner for many, many, many years. It really is a testament to these teams, to everybody who worked on it, their hard work, their perseverance, their dedication, working through various issues along the way and getting to this test flight today.
It's pretty damn good.
You know, putting the vehicle through its paces on this flight is really the only way to prepare us for the crewed flight test. And the systems performed great on the vehicle. And, you know, once we work through all the data, we'll be ready to fly the crew on this vehicle.
Joel's pumped.
As you know, this is the second landing for a U.S. vehicle on land on the airbag system. And again, that system performed flawlessly today. The entire sequence of the day went beautifully.
So
the
happy.
undocking with the NASA docking system for the first time worked great. It was flawless. Starliner backed away and separated very cleanly from the space station. All those maneuvers were very nominal. Went to a position beneath the space station and phased out in front, and then got into position for the deorbit burn. We worked through a couple of things on the way out. We learned a little bit about calibrating the navigation system. It took us a little longer than expected. I think that was just learning by the team, going to a couple of different attitudes to get stars and to calibrate the navigation system. We also were able to hot fire the thrusters that had shut down earlier in the flight. We hot fired the 2 port OMAC thrusters, and those we did not recover. We saw an interesting signature that looked a little bit like the signatures we saw at shutdown. So maybe 25% or so of the thrust that we expected out of those thrusters, and so we'll have to go work on that after the flight.
Oh, yeah.
We did also
it's
hot fire the reaction control system thrusters. Remember, there were 2 of those that were deselected and shut down during the rendezvous sequence, and those worked fine. Those were available for the software. We checked out another 4 thrusters, and those worked really well.
Interesting.
As I said, the whole SEP sequence went really well. The nav system performed well. The Vesta system took more navigation data backing away from the station, and that all worked great.
Cool.
We had a couple of things during the entry and landing. First of all, the deorbit burn was nominal. Put the vehicle on the perfect entry trajectory. The crew module and service module separated just as we expected. During entry, one of the navigation systems dropped the communication with the global positioning satellites a little bit for a period of time. This is not unexpected for a vehicle that goes through entry. The system came back and was tracking satellites just nominally. We did have one of the CM thrusters, the crew module thrusters, that looked like it might have shut down toward the end. It was really hard to tell when we transitioned from the use of the thrusters to the parachute sequence. It looked like one of those may have shut down. And then, of course, at landing itself, there was a bit of that detectors registered a little bit of hydrazine. So the teams backed away until they could get a good reading. Sometimes there's maybe a little bit of unburned propellant around. Sometimes those detectors can be a little finicky. It was about 5 parts per million. And then we saw no evidence of any leaks on the vehicle. The thruster pressures were all normal. The manifold pressures were normal. So this sometimes just happens. It happened with Space Shuttle as well. You know, when I just think back to the landing today, I mean, it was picture perfect. Beautiful to watch. All the parachutes worked just as expected. That forward heat shield came off right on time. We had 2 good drogue parachutes. We had 3 good main parachutes, and then a really soft landing. Landing was about 26 feet per second or so, which was very nominal. The airbags deployed just as they were expected to, and that whole sequence went
like 10 miles an hour at best.
I'm thrilled to be here today. It was a great day. We will learn from this flight, and we'll move forward, and looking forward to the crewed flight test very soon. And I'll turn it over to Joel.
So this guy runs the ISS.
Thank you, Steve, and thank you again for joining us today. You know, just a few days ago, we were talking about an outstanding launch, rendezvous, and docking sequence. And today, I'm proud to congratulate the Boeing team, the Commercial Crew Program, International Space Station Program, and our international partners on just an outstanding undock and landing. And, you know, we've talked that this was a landmark mission for everybody and for human spaceflight as we move forward.
Absolutely.
The vehicle was only docked for 5 days, but we kept a busy pace while docked. We were able to demonstrate the delivery of cargo. We delivered 500 pounds of cargo was delivered to the International Space Station. 600 pounds was returned from the International Space Station. We're able to do an inspection of the thermal protection system, which is critical for us to demonstrate for this mission, such that when we have humans on the vehicle, we send home a vehicle that's solid and ready for re-entry. We did an audio checkout during the mission. We had the hatch open. During the mission, we were able to test the different system compatibilities between the Starliner and the International Space Station. We also took a Space Station command and control laptop over to the Boeing Starliner and did some testing with that as well. All successful. So from our standpoint, just a huge success on this mission.
Good.
You know, I'd like to say that to the Starliner and team that we now have a cousin to Dragon and Soyuz that can safely deliver humans to space and safely return to Earth. So with that, a huge congratulations to everyone, and I'll hand it over to Sunny.
Oh, that's legit, man.
Thanks, Joel. Wow, I'm just really psyched to be here. I mean, this team has just crossed the finish line on OFT-2. It's pretty amazing. Of course, like Steve and Joel said, it was a flight test, and we learned a whole bunch of stuff from it that we're going to be able to incorporate into the crew flight test. I had the opportunity to talk to the crew on board while they were doing their activities. They just loved it. It had that new car smell as they got in it, you know, and they were just excited to be there and helping us work through the activities that they had to do for the International Space Station. I'm just really looking forward to this mission completion and why I'm so excited about being here, because of course that paves the road for the crew flight test before too long, and we're going to have to kick out Rosie and Jeb and maybe take their place.
Thanks, Sunny.
You can't do that.
Let's turn it over to Mark Nappy, who's joining us remotely from the landing site. Mark, are you there?
She mentioned Jeb.
I am. Thank you very much. I'm really so happy for our team and very proud of them for the accomplishments that led to such a successful mission. We are extremely pleased with the results of this mission. I certainly want to thank ISS, the Commercial Crew Program, and all of our suppliers for such a successful mission. The mission went extremely well, like Steve said. All the phases from launch to orbital insertion, all the demonstrations that we did for the near and far field approaches through docking, all the docked and undocked work that we did, and then, of course, undocking into the re-entry and landing today that you saw that was, like Steve said, picture perfect. We stood here on the white sands and watched it come down, and the team was just extremely excited and pleased with the results. OFT-2, it was a test flight, and we expected to learn from this thing, and we did. We talked a lot about some of the previous anomalies that came up in previous conferences with the OMAC thrusters, the RCS thrusters, and the cooling. But the team handled those, the vehicle handled those extremely well, and it was a really good learning experience. The Starliner crew cabin remained around in the mid-70s, so it was a good environment for the crew next time that we fly. The Vesta system worked extremely well. It was just something to watch as it navigated itself to the International Space Station and then came in and docked. All of the operations that happened during docking with the hatch opening and the cargo destow and then packing all went extremely well. And, of course, the inspection that Joel talked about just a little bit ago was a good learning experience for us for future flights. So we are, again, extremely pleased with the results of this mission, and it just was topped off today with an incredible landing. All appears to be in really good shape. The team is working on the vehicle right now to get it secured so that we could get it moved to a staging area tomorrow and then start prepping it for shipment and be back to KSC around the 9th of June. And then we'll start preparing the vehicle for PCM-1. And the team is extremely excited about this. Again, congratulations to the whole team. We couldn't be more pleased with the results and the great mission. So thank you, and back over to you, Sandra.
Great, thank you to all of our briefers for those initial remarks. We'll now open it up for questions. Again, if you are on
here's
our
the
phone bridge, you
Q&A.
can press *1 to submit a question. And once your name is called, please state to whom you'd like to direct your question. If you do find that your question has already been answered, press *2 to withdraw it. And on social media, use that hashtag #AskNASA to submit your question. We'll start with a question from David Curl with the Discovery Channel.
Oh, cool. David? David Curl?
David, are you able to hear us? All right, we'll come back to him. Next up, we have Chris Davenport with the Washington Post.
Okay.
Good evening and congratulations. I just want to be clear, I guess, for Mark or Steve. I mean, based on the objectives that you've accomplished with the mission, can you say now for sure, like 100%, that you're going to go proceed next with the crewed flight test? Or is it still too early and you want to see what the data looks like on the mission and on those OMACs?
I can start, and then we'll let Mark add his comments. When I look at what happened in the flight and the kind of things we'll need to work through over the next few months, I mean, I don't see any reason why we can't proceed toward the crewed flight test next. The vehicle performed really well. If I step back and look at this flight test, we met all the objectives. We went and looked at the performance of the vehicle, the flight software for one thing, from the point that Starliner separated from the launch vehicle all the way to landing performed extremely well. The comm system performed well. We have a few upgrades to that for the crewed flight test as well. We have a few things to work on between now and then, but I don't really see any showstoppers this time relative to last time, when we had challenges with the flight software and the comm systems. So I think we'll work through it, and we really do have the crewed flight test next on our focus. It's also nice that Mark mentioned talking about the post-certification mission, or we'll call it Starliner 1, because that's really the long-term objective, is to have these vehicles come up, carry a crew of 4, carry the powered payloads, and then stay docked to station for a 6-month increment. And I think now we're pivoting to the crewed flight test next, and then working our way toward that first post-certification mission.
And Mark, if you have anything to add, we'd love to hear it.
And that we're really pleased with the mission, all the objectives and the demonstrations being satisfied. The next step is to really now dig down into all the details and of the mission, with looking at all the instrumentation. So all of the subsystems will look at their subsystems in much more detail to make sure that we saw everything that we wanted to and got the expected results.
It could be.
So after that, we'll have a lot more confidence in being able to turn the vehicle around for the next mission, as well as get into CFT. So planning for the end of this year, and as long as all those data reviews come out good, we put ourselves in a very good position.
Good to hear.
Great. And our next question is from CBS News with Bill Harwood.
Hi, Bill Harwood, CBS News.
This is a question for Steve, I think. Every new vehicle has issues. I mean, things maybe you didn't expect, but they're within the boundaries and this, that, and the other. How does this flight compare to Demo 1 in terms of expectations versus reality? And I'm not looking for a scorecard. I'm not trying to compare SpaceX and Boeing. I just want to get a general sense of how the Starliner did in that context. Now that it's got a full-up, flight to station under its belt. Thanks.
Good question. I hadn't had a chance to think a lot about that, but I would say the performance was very, very similar in lots of ways. We had a few minor challenges on this flight. We talked about the OMAC thrusters that have performed really well. We've hot fired on the ground numerous OMACs, so we have something to go look at there. We learned how to manage the cooling system, I think, on this flight. I think there was a lot of learning on how to manage things. When I step back and look at Demo 1, we had challenges between Demo 1 and Demo 2 that people may forget about. We had a major redesign of the propulsion system between Demo 1 and Demo 2. I don't see that here on what we saw on this flight. Between Demo 1 and Demo 2, we did a redesign of the parachute system on Dragon. Again, I don't see that here on Starliner relative to these parachutes. We've worked with Boeing and done numerous drop tests. The parachutes perform fine. So I don't really see. I think both flights, we learned a lot from both test flights, both the uncrewed test flights, whether it be Demo 1 or OFT-2. I think that learning may be a little different in different areas, but it's relatively the same. And then, we were able to move forward from Demo 1 into the Demo 2 test flight, and I think, given the data reviews that we'll have to do that Mark talked about, I think we're on track for that here with the crewed flight test.
And our next question comes from Stephen Clark with Spaceflight Now.
Thank you, and congratulations to you all. Just a quick question for Steve Stitch. Could you clarify the number of RCS thrusters that you hot-fired after undocking, and how many of those were actually recovered that you saw issues with earlier in the flight? That's a quick one. And then separately, the issue with the acceptance testing of the Dragon heat shield on the Crew 5 vehicle. NASA put out a statement earlier this week talking about about replacing that heat shield structure with a structure from a future mission. Was wondering how you go about clearing the heat shield structure on Crew 4, which is currently on orbit. Any concern with that? Has that been cleared of this manufacturing defect, or is that still under review? Thanks.
Bruh.
Yeah, good questions. I'll start with questions relative to Starliner. So, we had 2 of the reaction control system thrusters that shut down, and the flight software fault detection took them out of the logic to be able to be fired earlier in the flight.
Cool.
Today we hot fired those 2 thrusters, plus we even looked beyond that at some other thrusters, and we hot fired 4 more thrusters for a total of 6. And what we do is we put the vehicle into a free drift, so when a thruster fires, there's a corresponding rate on the vehicle, and that the navigation system measures that rate, and we can determine it with a thruster fire. And all 6 of those thrusters fired just fine, looked like they had nominal thrust, and we made them available for the flight control system. So we hot fired 6, and they were all good on the reaction control. Relative to Crew 5, both Starliner and Dragon have very complex composite parts, and so Dragon has a composite heat shield. And during manufacturing of the heat shield for Crew 5, we found a problem with the manufacturing, did some x-rays, and so we had to determine that heat shield wasn't a viable heat shield for Crew 5. So we moved up another heat shield in the flow, and we'll do the similar kind of x-rays and testing on that. We also take those heat shields and we put them through a battery of tests, and those tests actually apply physical loads to that heat shield, the kind of loads we'll see during the aerodynamic re-entry sequence and also at the splashdown event. When the heat shield passes all those tests, and we can look at the measurements that we have instrumentation on that heat shield, when it passes all those tests, then we clear it for flight. So we'll go through that process for Crew 5 and clear the heat shield, and then we'll deem it good for flight. The heat shield on Crew 4, we went back and looked at the data. It does not have the same issues in manufacturing that we saw on Crew 5. It has been through this testing sequence where we go apply all the loads to it, and it has passed all those load cases, so we don't have any concerns with the heat shield on Crew 4.
Ian. That was actually a good question. Good on Steve.
Okay, great. And we do have a question here in the room. That will be from Eric Berger with Ars Technica.
Thank you, and congratulations on the mission. Congratulations on the mission and bringing it home today. It's a question for Steve, I think. Can you talk a little bit about the plan forward for the thrusters in terms of addressing the issues you saw both on day one and then the potential issue with the thruster on the crew module, I think you said, coming back today, where you said it may have failed right at the end. Is that the kind of thing where you're going to be able to look at data and sort of go with those basic designs? And you said you probably weren't going to need to redesign the system, but sort of what's the plan forward to dealing with those before you get to CFT? Thank you.
I'll take a crack at it, and then I'd like to hear Mark make some comments as well. So I think what we've got to do is we'll lay out kind of a fault tree. The one thing on the thruster that we saw really late during entry on the crew module is that vehicle will go back to the C3PF as Mark talked about. And so we can actually do some physical inspections and some more tests on that thruster and see if it performed as well. Did it really fail off? We can look at the data. On the other thrusters, I think we'll have to go build a fault tree, look at those fault trees, see what kind of data we have. Do we have any of their data during the flight week? And we can look at and then make a determination as what the next steps are. It could involve some offline testing as well for those ones on the service module, and then we'll see if Mark has anything to add.
Mark.
It's about the same place I am. You know, the team has done quite a bit of work to try to put the fault tree together and look at the probable causes of the shutdowns that we saw, and none of them looked to be serious that they would turn into some kind of design change. So we have more work to do. I agree. We probably need to be doing some offline testing to try to verify some of our probable causes, but I'm more optimistic that we'll be able to explain these and move on.
Our next question is from Jim McKenna with Aerospace Tech Review.
Or not.
Jim with Aerospace Tech Review, are you with us? Okay, we'll move on to Josh Dinner with Space.com.
Are you talking about Mark Nappy? It's because he's at where the capsule landed, B-Money. He's out in New Mexico, where the capsule came down. He wanted to see his capsule come home. That's why Mark is not there.
Josh, are you with us?
Josh, hello. Okay.
All right, we'll try Marcia Smith with spacepolicyonline.com.
Well, thanks so much. Can you hear me?
We can hear you.
Okay, I'm wondering if you could just, maybe this is for Steve, could be for Mark. I'm just trying to understand all the different thrusters and the issues that have developed with them. So there are 12 RCS thrusters on the crew module, is that right? And 28 on the service module, and 20 OMAX. So which of those has had the problems on this flight? And the valve problem that you had back in August, are those the same thrusters? I'm getting a little confused with all the different thrusters here. And what are the commonalities amongst them? Are the RCS thrusters on the crew module pretty much the same as the ones on the service module, or are they entirely different systems?
Yeah, boy, now you're going to test my knowledge in numbers. Let's just, okay, so on the crew module, I believe there is 10 or 12. I forget the exact number, but those are used during the entry phase. Once the crew module separates from the service module provides all the propulsion during ascent, should an abort be required during ascent or during orbit. And during the rendezvous phase, the service module provides all the propulsion. It's also there to execute the deorbit burn, and then the crew module separates after the deorbit burn, and then it provides the attitude control all the way in space to the atmosphere, and then all the way through. So we looked like maybe one of those thrusters shut down. Again, the data was a little sparse, so we'll have to go look at that. That thruster is a hydrazine-only thruster, so it is not a dual propellant thruster. The OMAX and the reaction control system thrusters on the service module are dual bipropellant thrusters, so they use monomethylhydrazine and nitrogen tetroxide as the oxidizer. And again, we recovered all the RCS thrusters that failed. All those are good.
Shuttle-derived, Ian.
And then the two OMAX that failed, there's in each of the 4 doghouses, there's a total of 12 of those aft thrusters. And so during the flight, we fired 10 of those, and those all worked fine. For some reason, in the port doghouse, 2 of those shut down early, and so we'll have to go look at those. These thrusters are totally separate from the oxidizer isolation valves, the OMAC and RCS that we talked about, that we had the challenges with back from August. So those, think about, it's a way to isolate the thrusters that are on a line from the propellant tanks, and so that's what those thrusters are. That's what those valves are there for. So those all worked nominally through the whole flight. They were cycled several times, worked just fine. So those valves performed as expected. You know, and occasionally in Space Shuttle we would have a reaction control system thruster fail off as well. We'll just have to go try to build the fault tree as Mark talked about and understand what happened with the thrusters.
Thanks, Steve. Next up, we have Micah Maidenberg with the Wall Street Journal.
Ian, the hydrazine-only thrusters, that's Space Shuttle derived, dude. The low Z thrusters for docking to the space station.
Micah, can you hear us?
Yeah, low Z thrust for station docking.
All right, we'll move on to Jeff Faust with Space News.
Yeah, they're definitely shuttle derived. That's how the low Z thrust works.
Hi, this is Jeff out of Space News. Can you hear me?
Jeff is good.
We can hear you, Jeff.
Jeff will ask a good question.
Okay, great. Question probably for Mark Nappy. You know, when you tested the OMAC thrusters, the 2 that had failed earlier, and you mentioned you got an interesting signature and maybe 25% thrust, does that give you any clues about exactly what might be the cause of the failure? Does that help you winnow down the fault tree any further? Thank you.
It's a good question.
Yeah, Steve can maybe help me when I get to the more of the details, but because I was on the ground and of course we couldn't hear the results from the tests that we ran. But I can answer the last piece of that. Is it certainly helps us understand some of the items on the fault tree, because this indicates that we had we had thruster failures, and this isolates it more to the thrusters themselves than any other part of the system.
I can add that what that helps you do is so that the thruster fired, so you know the flight software commands were getting out. There's a device called an integration propulsion controller that then sends commands out to the valves on those particular thrusters, so we know that functioned fine. So we'll have to look at the legs of the fault tree where we got thrust, but it wasn't quite the level we expected. So we can kind of narrow down to what would those blocks of the fault tree be, and then what steps would we go take to remediate those.
Interesting.
Our next question is from Irene Klotz with
They're
Aviation
talking about
Week.
why the thrusters failed. That's actually super interesting. I'll get more into it later if you guys have questions.
For Steve and probably also Mark, at this point, would you consider the oxidizer isolation valve something that would be an impediment for the crew flight test? And if so, how long do you think it would be to do a redesign of those valves And then also just wanted to verify that if a redesign is decided on, that the costs for that are borne by Boeing, or might NASA be contributing to that? Thanks.
Yeah, I'll take a crack at it first, and then I'm sure Mark will have something to add. But
okay.
Relative to the valves, what we said when we brought this item to the joint Commercial Crew Program and Space Station Program Control Board, we would approve it for one flight, and we were going to, which was OFT-2, and we were going to sit down after the flight and look at the data from that flight, and then determine what the next step was for the crewed flight test. And so that's really the next step, is looking at all the data from the flight. Now, I can tell you that so far, the mitigations that we put in place for OFT-2 looked very promising for CFT. Every time we cycled the valves pre-flight, whether it was in the C3PF where the vehicle is processed, or at the pad, it worked as expected. There was no signature of any kind that showed we had a performance issue with any of those valves. I think Mark talked before that they are off looking at some options to redesign the valves. I'm not sure we have a timeline yet for when those redesigns would be in place, and I think they're looking long term at redesigning the valve. So I think we need to look at the data again from the flight in a little more detail, but I think we might have a good path for the crewed flight test with the oxidizer valves, and I'll see what Mark has to add.
I agree, Steve. We've got a good system now. We know how to manage it in order to get to a safe place for launch. We have options for CFT. We still need to look at the longer-term solutions, and we've got several options in front of us. We have a good team working on it, and I feel confident that we can get an option in place for use on CFT, and then look at the longer-term solutions for PCM1 and beyond.
Thank you. And our next question will come from Manuel Mazzani with Debate.
Manuel. All right, Lunchbox. No problem, dude.
Daniel, did you still have a question for us?
Yes, can you hear me?
Yep, we can hear you.
Okay. What is your level of relief, and of course for NASA, knowing that after this successful mission, we are basically on the verge of having two crew capsules capable of carrying astronauts to LEO. And another one for Mark. If you have to rate this mission from 1 to 10, what would be your rate? Thank you.
Yeah, from a commercial crew program perspective, we're just ecstatic with this orbit flight test. My favorite picture really was one that the robotics team took a few days ago of having Starliner docked at the forward port and Dragon docked at the zenith port, and then thinking about the crew doing comm checks between, I'm getting goosebumps a little bit talking about it, because between Starliner and Dragon, that's really what this commercial crew program has really been about all along, is having these two different companies with the great systems they've developed provide crew transportation to the space station under this new commercial crew model. And the flight that we have just landed today demonstrates that the Starliner is a great vehicle for crew transportation. And so it was just, I probably can't express into words what it meant to me and the team to have Starliner at station, to see the whole mission go well, to have that picture of the two vehicles there. It really is something I've been working on for the last 7 years of my career, and so it was just an incredible day for us. And I'll let Mark answer the second part.
Dude, I didn't know that they had Dragon and Starliner talk to each other. That's really cool.
I think on a scale of 1 to 10, I think I'd give it a 15. This was incredible. Really cool. We wanted to learn. We did. The team reacted to everything that was thrown at them perfectly. The vehicle reacted to changes like it was supposed to. The flight software worked in an excellent manner. We couldn't have asked for a better mission. It was truly a fantastic test play, and really puts us in a great position to fly CFT.
Hell yeah.
Absolutely. Very special to see. Our next question comes from Jim Siegel with NASA Tech.
I didn't know that they made the capsules talk to each other.
Thank you for taking my question, and congratulations to all of you and your teams. This is a question for Sunny. To what extent are you and the other astronauts involved in the work that's done on this vehicle prior to its next flight? And are you going to be looking over everybody's shoulder there as they work on it?
We try not to do that. We just try to be an additive member of the team. Myself, Mike Fink, and Barry Wilmore have been working hand in hand with the Boeing team and the NASA operations team as we were getting this spacecraft ready to go to flight. And then as they were executing the flight, a couple of us even went over and did some of the sample stowage stuff for transferring the cargo from the International Space Station, working hand in hand again, like I mentioned, with the Boeing team. As this spacecraft comes home, I think we're a little bit hands-off. Let the experts take care of it. I think the three of us would definitely really like to get our hands on the next spacecraft, the crewed flight test vehicle, and work with the team. We still have a lot of work, like Joel and Steve mentioned. We learned a lot during this flight. Some of that learning will be applied to the CFT flight. And we'll be working hand in hand with the Boeing engineers and the NASA folks who will be doing the operations, NASA Boeing team. And we'll be getting ready as best as we can. Hopefully we'll do a better job than Rosie and Jeb did. And we'll be ready to fly when the spacecraft's ready to fly.
Nobody's better than Jeb.
Mark Carreau with Aviation Week.
She said cargo. Did you hear that?
Oh, thank you. I'm
There was an
wondering
H in there.
how soon it might be before you can put a target date or a target period on the crew flight test, and also assign the crew members who would definitely fly.
Yeah, let me take this. I'll take the second part, and
Sonny's
I'll
like,
let
"I'll do
Mark
it."
take the first part. How's that? Since Mark and I are certainly a team. So, relative to the crew assignments for the crewed flight test, we really need to look a little bit more about when that flight's going to fly, and then what the complement of the crew members being assigned to the flights around that, and then we'll make a decision. Hopefully here in the summer time frame, we'll have a decision relative to the CFT crew. And then I'll let Mark talk a little bit more about what that process will be to figuring out the crewed flight test date.
So there's a couple pieces to being able to set a flight date, and part of it is fairly on us to get the vehicle turned around and get all the engineering products complete, and we're off working that right now. And of course, like I mentioned earlier, we need to finish off our data reviews to be able to solidify what needs to be done to this vehicle to get it complete. The other couple things that have to happen are, first of all, International Space Station has to have a place for us to go. So we'll have to play that one by ear until we can get a better understanding of their situation, as well as ULA being able to provide us a launch vehicle on the range. So all that has to come together in order to set a flight date, and we're probably several months from being able to do that.
End of the summer.
We have a few more
how long
questions.
it
The
takes
next
to
one
review
is
the
from
data.
David Curl with Discovery Channel.
Okay, David.
Can you hear me this time?
Can hear you.
Good. Excellent. Thank you very much. I'm a little confused, Steve Stitch. No showstoppers, but there are questions to be resolved. Can you give us a better sense of that? And Sonny, did Jell or Hines say anything to you specifically? I mean, you're very ingrained in this vehicle. Is there something that they said about the vehicle that you can give us specifically? Thank you.
What?
Yeah, I would say every flight that we fly, and I have a lot of experience all the way back to Space Shuttle, there was always something
Steve's been doing this for a while.
that we needed to look at after the flight. Even after the 135th Space Shuttle flight, there were things to look at. So every single flight has things to resolve. It's been the same with every flight we've been flying with SpaceX. And so when I say I don't see any showstoppers, I mean, if you step back and look at what we were trying to do with this orbit flight test, it was really to see does the vehicle perform in every single phase of flight like we need it to, separating from the launch vehicle, doing the rendezvous burns, which we did not get a chance to execute last time, doing the navigation to the space station with the Vesta rendezvous system. That system performed flawlessly with all the sensors. We got great data on that. Testing the NASA docking system and docking to the space station, opening the hatch, and then establishing airflow between the two vehicles, looking at how the thermal environment was managed between the vehicles. How does the cooling work
He's on a roll.
Starliner and space station?
Let him go.
How did the cooling work on Starliner in the transit time? And then, could Starliner do the functions we need to while it's docked to station, which, as Joel talked about, we went and took a laptop in and tested it. One of the requirements that we have is that Starliner would be a safe haven for a crew that's there for 6 months. If there's some reason they need to get in Starliner for a period of time and stay in Starliner, can they do that? And we tested some of those functions, including the audio between the station and Starliner. And then the undock sequence, and how did that work with the NASA docking system? How did the SEP sequence work? The things that we encountered in flight were really loss of redundancy in several thrusters. We needed to learn how to manage the cooling loops. We needed to learn how to manage a little bit of aligning the navigation system after we undocked today, which we did. And then if you look at the entry sequence, that went flawlessly, and that system has to work perfectly every time, including the landing system, the parachutes, the airbag system. We tested all those things. The cabin temperature was 70 degrees, 74 degrees, which is what we need for the crew. And so if I just look at overall performance of the vehicle, it was extremely good. What we do is then we go to the next level of detail, and our engineers between NASA and Boeing will do a detailed review, and we'll go look at the things that we saw, and we'll go see if we're really ready to go fly CFT. So.
And to answer the second question, Bob and Chell, they were really busy inside the spacecraft, so we were talking to them a lot about what they were doing and trying to get some feedback, just so now that we had that spacecraft in space, learning about how everything is set up, and can we optimize it, can we make it better? So there was a lot of that conversation, but I think one of the coolest things that they said on the first day that we had the hatch open, they were like, do we have to leave yet? Because we haven't showed Samantha and Jessica it. We want to show them around and give them a little tour. And we were like, yeah, you got it. It's yours for right now, but you can't keep it.
Nice. It's coming home.
Thank you. And we do have a social media question for you as well, Sunny. Sawyer on Twitter wants to know if you have plans to name the capsule now that it has landed.
Oh, that's not up to me. I was lucky enough to name the first capsule when I was out in the desert. But this one, I think that's other folks have other plans for it. So we'll see.
All right, we'll stay tuned. Our next question comes from Bill Harwood with CBS News.
Thanks very much.
It's actually a good question,
two questions. I want to follow up on Irene's question about if there is a valve redesign, is that on Boeing? Is it on Aerojet? Is it on NASA? How does that work? And following up on Stephen Clark's question, regarding the Crew 5 heat shield, did the failure manifest itself in a loads test specifically? In other words, was it a splashdown load sort of thing that caused the problem? And was the problem only seen in X-rays, or was there physical damage to the heat shield, like a crack, for example? Thanks.
Yeah, Bill's good. Those are good questions.
Yeah, let's see. I'll take the heat shield question first. What happened for Crew 5 is when we put the heat shield through the landing loads case, it did not pass, and so we could tell there was some damage inside the heat shield from that test, and so we knew we couldn't go forward and fly that heat shield. In terms of the valve redesign, we'll work hand in hand with Boeing on any testing that's required. We have provided some testing that's a little bit special for the valves for this flight, but basically, I think Mark would be working that valve redesign out with his suppliers, and I'll let Mark address the rest of the questions.
Yeah, that's correct, Steve. We are working with the supplier on what's next for that valve. I would emphasize, though, that Steve and NASA has been very gracious with helping us with testing and certainly lending their expertise towards getting to the right solution so that we can come up with the right design. So they're giving us quite a bit of help.
Our next question is from Ken Kramer with Space Up Close.
Oh, hi, thank you, and congratulations on a great mission. I want to ask about the CFT, about the mission length. I think you guys previously had said about 2 weeks, and I'm wondering, that seems a little bit short. If you might make it a little bit longer, and if you Demo 2 was 2 months, for example, and if you do whatever length you make this mission, will it be crammed with science? Thank you.
Yeah, we have said a couple of weeks for the crewed flight test. We have the ability with that vehicle to have it fly up to 6 months. We have put that on contract with Boeing. We'll have to look at when it flies and what the time frame will be. You know, it's really going to be another test flight of putting Starliner through its paces, this time with the crew on board, and testing the displays and the life support system and those sorts of things. I'm sure we'll have objectives of testing. I talked about having a safe haven capability, or a capability to go close the hatch of Starliner and use that as a bit of a lifeboat if you need to get away from station for a little bit of time, or if there was a micrometeor impact that we had to put the crew in there for some period of time. So we'll do those kind of tests, and I suspect it will be a short flight, but we really have the capability. Boeing's built a great vehicle. If you just look at these vehicles, they really are the same config that will go fly for the longer PCM flights, and so it could stay longer if required.
And I'll add, you know, once we have the mission objectives set for the CFT mission, we'll make every use of the crew time and add science as required. And so I'd love to add science. We added a bunch of science you saw on the Axiom mission. So every time we get an opportunity with humans on board, we're adding science to those missions, and we'll do the same on the CFT.
Joel,
thank you both. Our next question is from Josh Dinner with space.com.
Hi, thanks so much. My question is for Mark. It was reported recently that SpaceX is capping the production of its Crew Dragon capsule at 4. Has there been any number discussed at Boeing for the production of Starliner?
Interesting question.
I'm sorry, can you repeat the question, please? You broke up.
Oh, I'm sorry. Yeah, so it was reported that SpaceX is capping the number of its Crew Dragon vehicles at 4. Has there been any discussion at Boeing for the number of Starliner vehicles to be produced?
It's actually a good question.
Okay, so we have 2 Starliner crew modules that are available to us right now, and of course we build the service module for each mission. So we need to really understand what the manifest is going to be for the future to determine if additional crew modules are required. But right now we're at 2.
Interesting.
And we do have time for just a couple more questions. One of those will be from Marcia Smith with spacepolicyonline.com.
Thanks so much for giving me a chance for a second question. So the Aerospace Safety Advisory Panel, when they reviewed your program a couple weeks ago, they came back and they said that they urged NASA and Boeing not to rush to CFT. And certainly you've been saying this evening that you're not going to do that. But I'm just curious. You know, they talked about a concern about
he said if the market's there, Phil,
Boeing, about the parachutes, and about
there's going to be more.
Just how difficult it is to go from an uncrewed to a crewed flight. So I guess for Steve and Mark, could you just talk about how you're feeling these days after the successful landing, about when CFT might happen? Are you still looking at by the end of the year? Or realistically, is it like into the first quarter of next year or the second quarter?
They'll fly when they're ready, man. That's it.
I'll take the first part of it, and then we'll see. I'm sure Mark will have something to add. But yeah, right now Mark's getting the hardware ready, has been getting the hardware ready to go, and have that hardware ready by the end of this calendar year. And then I think what we'll do is look at the data from this flight and look at the rest of the things that we need to get done before the crewed flight test, and look at where that flight needs to be. Certainly it could move into the first quarter of next year. We've got to go work with Joel on the manifest and find the right time to go fly the flight. I think, you know, we're on a good path now. I've been saying for quite some time to my team, and you know, I really think the most important thing to make progress towards CFT was a successful OFT to test flight, and I think we had that over the last few days. I think we just got to look at the rest of the pieces. Sonny and the crew will be extremely important. There's software updates with displays that Sonny and the crew will be, and the astronaut corps will be testing. We've got to look at the seats and an ECLS test likely in the summer time frame with the vehicle
environmental control
to make sure that we have all that right. So it's the next step really is to take the things that are hard to test without crew and make sure we're ready for those. And then we'll move that into CFT, and I'll see if Mark has anything to add.
Yeah, they're pretty good, Novus.
Yeah, I think first of all, you hit the nail on the head. We are not going to rush into anything unsafely. We monitor our resources on a weekly basis to make sure that we're working the appropriate amount of hours and we're not pushing any discipline beyond their limits. We're very accurate metrics to make sure that is the case.
Interesting.
We have a schedule laid out that says we'll be able to complete the vehicle preparation for the end of the year, but we have to spend the next couple of weeks again going through all the data to make sure there's nothing that's applicable to CFT that we need to do differently. We also have to really nail down all the engineering products and put that schedule laid out so that it fits the vehicle being complete. So I think we just have a little bit of time in front of us to collect all this information and be able to put it into that schedule and make sure that we can support the schedule that we currently have laid out.
Fly when they're ready.
And our last question this evening will come from David Curl with the Discovery Channel.
Oh boy.
Thank you very much, David Curley from Discovery. Steve Stitch, I asked you after docking about the personality of the vehicle, so how about an update? Are you still with Patient? Do you have something else for us?
Oh, man. I would say this vehicle is determined. It was determined right out of the gate for this flight to go fly it successfully. It was determined to meet the flight test objectives, and it was determined to dock with the station even when it might have taken a little longer on my birthday to get there and make me wait a little longer for that present. It was determined today as we undocked and moved through the sequences back and away from the space station, and then all the way down through the atmosphere into landing. It was determined to go through its paces and to show that Starliner can do what's required to fly cruise someday.
Hell yeah. And that's about as much emotion
Thank
as
you
you'll
all
get
to
out of
everyone
Steve.
who submitted questions today, and a big thanks to our briefers for taking the time to discuss the landing of Starliner. We do hope you'll continue to follow along with the Commercial Crew program at nasa.gov/commercial crew. Thanks again for joining us. That will wrap up today's briefing.
Joel is still like, yeah, I'm about to have 2 capsules. Yeah, that was pretty good. It's good. I learned a lot there, actually. That's very interesting. They got 2 of the reaction control system thrusters. They fixed them. And then they fixed the OMAC thrusters, too. On orbit. Interesting. What I just missed, that was the Starliner OFT-2 post-flight press conference, Jim. It's pretty good. I didn't know that Steve Stitch had the capsules talk to each other. That's really cool. They had Dragon and Starliner talk to each other when they were both at the space station. That's really freaking cool, man. That's hype, man. That's hype. Landing was perfect, man. Perfect. Textbook landing. It was excellent. Between OFT-1 and this flight, Boeing's ability to solve issues mid-flight has been very impressive. True. Yeah, they're good. They got all shuttle. These are all shuttle people. Steve Stitch is shuttle guy. So is Mark Nappy. They're all shuttle people. They know how to fix stuff. Shuttle had problems on it a lot. They know how to fix this stuff, dudes. It's not a problem. Dragon, hey, Starliner. Hey, what's up? Who are you? Oh, dude. That's cool. You do what I do? That's really neat. Yeah. Just to give you my question from earlier so you don't have to scroll. As far as Starliner being a safe haven, do they just mean as far as the station pressure vessel being compromised or something else? Yeah, Steve Stitch actually answered your question a little bit later, dude. Yeah, pretty much. There are other things that there are other things where you might need to use the capsule as a safe haven just as a precautionary thing. Like when a new space station module docks to the space station, they usually have the crews inside of their capsules with their flight suits on just in case they need to eject, like quick. That's how it was during Nauka. They basically shut all the doors in the space station, so if one module depresses by accident because a new module docks or something, then that's another way that you could use it as a safe haven. Yeah, but it's for micrometeorite impacts. But there's a bunch of things. Starliner, hey, what took you so long? I got left out in the rain. What do you want from me? No. Crew vehicle. Starliner, how do you read? That's pretty cool, man. Pretty good. Yep. That's really cool. There's a lot of good information in there. Yeah. All right, dudes. Well, I think we're putting a bow on this stream. I think we're good. A good solid 10 hours of space stuff. Kerbal, Starliner, Falcon 9, rockets landing, capsules landing, ISS undocking. It's just freaking great. Love space, man. There's so much good stuff. There's so much good stuff. All right. So, next Falcon 9, the next mission actually is Capstone, and then there's another Falcon 9 launching SpaceX 25, which is a resupply mission. That is in June, so I think we're clear of Falcon 9s for the rest of May. But yeah, that's gonna do it for me, guys. This is good, solid stuff. I think we will play more Kerbal tomorrow. Kind of want to play Flight Sim. Maybe we'll play Flight Sim on Friday. Friday Flight Simulator. Kerbal tomorrow. I want to play more Kerbal. We got to play more Kerbal. Got to finish those hold down points. And we got to finish fixing that SSTO pad as a good way to get back into it. Kerbal Thursdays. Yep. Higher up at Haas saying this. Did we get to see Jeb post landing? No, we haven't seen him yet. Oof, that sucks, Hellfish. We need capsule flights. When is MSC returning? I don't know. MSC should be going on right now, but I'll play it when it comes around, Facha. Like, maybe next week. I don't know. Remember, the new Tim video releases tomorrow. Yep. Anyway, let's see who's still streaming. Let's see who we can drop a raid on. I think. Let's see if is Sim around. Let's see what we got.